As companies increasingly shift workloads to the public cloud, cloud computing has moved from a nice to have to a core corporate world. Studies 60% of corporate data is already over the cloud, and major service providers who hold an abundance of this data are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. However, AWS is recognized as an industry leader in this field of cloud computing. This is not at all a vague statement. The tycoon research organizations such as Gartner believes in the same. They consider AWS as a thought leader and point of reference for all cloud computing competition. Besides that, AWS is kind of dungeon master of cloud, powering many organizations like Netflix, Airbnb, Adobe, BMW, GE Oil and Gas, as well as UK Ministry of Justice, and many more. And owing to these facts, along with an overwhelming growth the cloud sector has to offer, learning the intricacies of cloud with AWS is quite worth a while. Well, that being said, hello everyone, welcome to this extensive video on Amazon Web Services framework by Intellipaat. Today with this session, we are going to cover some intricate details about AWS platform and some of its features. But before we begin with that, please make sure that you enable subscribe button and bell icon so that you never miss an update from Intellipaat YouTube channel. We'll start this session on a friendly note by talking about technical architecture and application architecture to sort of gauge why we need cloud resources. Once done with that, we'll talk about what is AWS, how to set up AWS, and some of the advantages of AWS. Then we shall dive into the AWS hands-on, AWS services, introduction to cloud computing, and some important cloud services and deployment models. Moving further in the session, we'll also talk a little about competitor cloud providers. And then we'll come back to the discussion on AWS, where we will cover concepts of ELP, autoscaling and EFS, use cases and components of simple storage service, that is Amazon S3, and finally we'll learn about hosting a static website using Amazon S3. That's all for the agenda, guys. I recommend all of you guys stay until the end of this video to build some strong intuition about cloud computing and AWS as a cloud platform. Also, throughout the session, you'll come across multiple interesting quiz questionnaires. Don't forget to participate in answering them. You can put all of your answers in the comment box below with a small explanation. That being said, let's get started with the session.
AWS was introduced in 2006, and since then they have been the largest player in the public cloud market. According to Forbes, AWS grew $4.3 billion revenue just in the second quarter of 2021. The top 3 companies who offer cloud services in terms of market share are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. AWS by itself covers 32% of the public cloud market share. So what exactly is AWS? Amazon Web Services, or AWS, is a cloud service provider owned by Amazon. It offers cloud services in compute, storage, database, content delivery, networking, and other domains. Most of the offerings from AWS are infrastructure as a service offerings, but it also offers PaaS service such as Elastic Beanstalk and Lambda, which are popular and highly used services. AWS offers you all the necessary tools you would need to set up your IT infrastructure without paying any upfront. For example, Netflix, the world's biggest premium video streaming service, is completely hosted on AWS for its application needs. The world's largest e-commerce company, Amazon, is also hosted on the AWS infrastructure itself. When you see such big players in the respective fields rely on AWS for their infrastructure needs, you as an individual user can trust and be inclined towards AWS for your cloud needs. AWS offers a wide range of services that can be categorized into the following. We have compute and network services, storage and content delivery services, security and identity services, database services, analytics services, application services, and management tools. Now we have few applications of AWS. What are they? Let's look into it. The first one we have is storage and backup. That's Amazon's cloud storage is an easily accessible and useful services for business. Next we have enterprise IT. That's Amazon Cloud Services offer the ideal solution to enterprise IT's time-consuming pace. Mobile, web and social applications. AWS can launch and scale various applications like mobile applications and SaaS applications. Big data. AWS and big data work well with each other to come up with the power and infrastructure necessary to meet the needs of high-end intelligent software. Websites can be hosted on AWS Cloud. It is also good for hosting CDNs and DNS and domains. In gaming, AWS makes gaming applications easily available to the worldwide gaming network and provides gamers the best experience in online gaming across the globe. Now, how much salary does an AWS engineer earns? In India, it earns on an average basis 7 to 13 lakhs per annum, while in USA on an average basis, he or she can earn $137,000. The reason why Amazon is so huge is because of AWS along with its retail arm. The cloud service has a very high revenue and is growing rapidly. Now, did you know that AWS IaaS Cloud is 10 times greater than the 14 competitors of AWS combined? Now, this speaks volumes about the strong capabilities that this service possesses.
In this project case study, we'll be merging multiple services and we'll be seeing how that outcome comes. Like using multiple services, how do we make use of them and get our ultimate output? So to get these services, to deploy this particular services, we need to have a particular scenario, right? Without having a use case, nobody will deploy any service and do anything, right? So people moving on. So the scenario is, there you go. Let's say you all guys are employees, okay? And you all people have joined a particular organization. So when the organization want to have your details, for example, let's say your name, what is your profile, like on what basis you are good at, something like your image, something, all these type of sort things, okay? Now, to upload that, we have an application, guys. We have our developers designed an application using Python. So in that applications, we have a particular template, something like this. So there you go. We have a template, something like this. So it shows you EMP ID, like you can give your employee ID out there. And followed by that, you can give your first name, followed by your last name, your primary skills in which you are good at, followed by your location and the image. So whatever the data you give out here, okay, this should be going to the organization. And this should be going and storing to your organization, say database or something, whatever the use cases. Yes. So we'll see what are the multiple services we use to get this scenario working. Okay. So if I scroll down the PPT or the PDF, so there you go, guys. Okay. See, this template we will not be doing. Being a solutions architect, it's not your job to do it. The developers or abstract developers, somebody will be doing it and giving you. Okay. No need to worry on that part. Cool. So people, today we're going to be seeing multiple services together. So today we'll be seeing Route 53. We'll be seeing load balancer. We'll be seeing your EC2s. We'll be seeing your subnets. You'll be seeing your RDS. You'll be seeing your DynamoDB. You'll be also seeing your S3. You'll be seeing, if you can do it, you can also keep a SNS trigger as well for the same. And all these things you can see in this particular class. Okay. So here we are using multiple services to come and work for us for a particular thing, which is storing the data. So let's see how the use case works, guys. Okay. So you being an outsider or outside of the organization who joined, so you will be visiting the organization website. So we'll be having a domain, guys. So we'll be logging into that particular domain. Over there, you'll be getting this particular template. And whatever the data you store, okay, whatever the data you store in this main page, like your employee name, location, age, technology, or the one which you are good at, all the details which you will be giving, right? That should be going and will be saved in your RDS, in your database. Okay. On the same note, if you remember, we have some option called as upload image, like the image which you will be uploading. So people, whatever the image you upload out here, that should be going and storing in your S3. That's what the use case scenario out here is. So the image, whatever the image you upload, that will be going and will be storing in your S3, and whatever the other data you upload, that will be going and storing in your RDS. Okay. And now if you're thinking, why do we have this DynamoDB? Okay, so DynamoDB is, I'll talk about what is the main difference between your RDS and DynamoDB. But already we have a DB, right? Why do we need another DB?
Let's have a quick quiz question, guys. And the question is, which of the following dynamically grows and shrinks the load balancing capacity to adjust the traffic demands? And your options are Amazon CloudFront, Elastic Caches, Amazon RDS, or Elastic Load Balancing. Please mention your answer in the comment section below.
So people, metadata. So what type of metadata and what all type of, how the metadata looks like, we'll dig in once we go ahead. So people, if this is clear, can you tell me what is the first service which you need to create? The first service which you're going to be creating is nothing but VPC. Okay, because ultimately VPC is the backbone of every service you create in your AWS. Without having a VPC, nobody will be going to do anything else. So here, what is the use case scenario we're trying to build is, so let's presume all the fellow mates, your fellow mates and you are being an employee of an organization. So when you join the organization want to have your details. For example, your name, your skills, the location, your picture, and something like this. For this, we have an application already. Okay, so this is the template from that application. So here you will be filling up all the details, credentials, and your image as well. Okay, so whenever you click on update database, right, so all these particular details should be going and saving to your RDS, and whatever the image you upload, that should be going and storing to your S3 bucket. That's the basic use case scenario, or the basic scenario what we are trying to do out here. Is that clear, Arvind? And also we are having multiple other services which we will be using when we go ahead, right? Cool. So people, let's start with VPC. Okay. Now let me create a VPC, guys. So guys, I'm sticking to North Virginia. If you want to work with any other region, that's completely up to you. I'm leaving it that for you. Okay. So when you're trying to implement from your end, you can go with Oregon or Ohio, whatever it is. Cool, guys. Now over here, let me create my VPC. Let me call it as project VPC. Simple. Okay. So I'll go with any random notation. Okay, let it be. And now let me create a VPC. So people, VPC is created. What do you think is the next step? Very good, guys. Subnet is the next one which I need to have, right? Cool. I'll go and create a subnet. People, as per the question, if you see, they're asking you to create 3 different subnets, but 2 are more than enough, guys. Okay, for the use case scenario which we are dealing up right now. So let me show you one for public and other one for private. So let me click on create subnet. And over here, project VPC. Cool. Now let me call this as public itself, simple, and give it a notation by giving the availability zone. Let me add one more subnet since I need a private one. So let me call this one as private. Cool. Let me keep it in 1B. And now 10.10.2.0/24. Cool. So 2 subnets, I'm creating them. Yes, I have done that. Now after subnet, let me go to internet gateway because I have a public subnet out here. I need to have an internet gateway for the same. Let me create internet gateway. Project IGW created, and let me attach the same. So cool guys, internet gateway also I have created. You need to have a NAT gateway. Why? Because your application gonna be running in a private subnet. So if your application is running, you should be having an internet flow, right? I hope it's making sense to you people, right? Cool. On the same note, let me create a NAT gateway.
Just a quick info for all of you cloud enthusiasts. If you want to make a career in AWS, then you might want to check out Intellipaat's AWS certification training course for solution architect. Learn from industry experts through hands-on session, projects, and case study. Reach us out to know more.
So cool guys, let me go and create a NAT gateway. So I'll say project NAT, simple. And here I'll keep this one in my public. Elastic IP, yes, it should be there. Yeah. So this is gonna be assigning very soon. Now I have my internet gateway, I have my subnets, I have my NAT gateway. Everything looks perfect. Now what I can go and do is I can go and create a route table. Simple. So now let me say create route table. Now let me create a route table. So people, by seeing this scenario, can you tell me how many route tables I need to have? I have 2 subnets, guys. Can you tell me how many route tables I need to have? Very good, 2. Because one is private and other one is public. So now let me call this one as public RT, public route table. So project VPC, and let me create this particular route table, guys. Okay, we have done that. Now what I'll do is, since it's a public route table, I'll have internet, but from where? From where I'll be taking the internet, guys? Can you tell me? What is my target? Very good, people. I'll be taking the internet from internet gateway. Okay, since it's a public one. Save changes. And now what I'll do is I'll go and associate the subnet. So here you go, my public one. Let me go and associate for the same. Save associations. Done. Now let me create the other route table, which is for private. So now let me create the second route table, people. Okay, I hope you come to understand why we are creating a second route table. Why? Because we are having a second subnet to have. So private RT, I'll name this. So VPC, I'm going to be creating in my project VPC. So I'll be choosing that. And let me create this particular route table. Cool. Now over here, people, I need to have internet. That I'll give. The destination, I'll give internet. But what is the target? From where I need to take the internet? So very good, guys. NAT only. So people, if any one of you feeling confusion regarding internet gateway and NAT, simple. Remember this one thing. When you take internet from internet gateway, your route table or your subnet will become public. Okay. So when you take the internet from a NAT gateway, your subnet remains private, but will be having internet flow. So now let me click on save changes, and yeah. So now I'm having internet from the NAT gateway. So this is a destination, Vinod. 0.0.0/0 is the address of your internet. Okay. Subnet associations. Now let me go and associate the private one, since this is a private RT. Cool. So there you go. I have associated my private one to this. So everything looks good so far. Now what I'll do is, let me go to EC2s and launch my instances respectively in different subnets. So yeah, let me go and launch the instances respectively. Okay, let me briefly explain and get in so that you don't feel like as going a bit faster at one point and going a bit slower at one point, right? So cool. People I'll be choosing personally, I use Ubuntu a lot. I'm going with Ubuntu, but if you want to go with Amazon EC2 also, that's completely fine. You can go with that. Okay, I'm choosing the AMI. So I'll go with T2.micro. That's more than enough for my purpose out right now. And over here, I'll choose the VPC as my own VPC, which is nothing but the project VPC. Okay. Any company use Manikanta? Yes. See, basically in real time, in the sense like based upon the use case scenario. So for example, if some company purchase some different AMI from community, okay, AMI community, then they will be using their other third-party AMI. But basically, yes, you can go with any AMI if you want to go with, because this is the official one and provided by AWS itself. No need to worry on that part. Okay. Yes. So when you talk about, I want to add on this same point. So Amazon EC2 is also, yes, one of the widely used if you want to have your instances to be having CLA pre-configured, which remains as private. Okay. Because if you remember, when you learn about VPC endpoint, so when you are having an instance in a private subnet, if you're not having internet, but you want to access your S3 and all these things, right? In that moment, you need to have CLI. So Amazon's Linux comes up with that CLI pre-built in. So that will be used in that case scenarios. Now, let me keep this in public, and I'll assign the public IP since it's my public machine. So I'll be having a public IP so that I can connect. The only way how you can SSH into a private instance is by using public instance. That's the reason we are launching a machine in public subnet first, so that it helps us to SSH into the private. So when you want to SSH into a private instance, the only way you can SSH is using a public instance. Okay. So storage, I'll skip it off. I don't require any storage additionally. And tags, I'll name that something called as Bastion host. So people, this is one of the keyword. Okay. Bastion host means jump server or jump box. In simple terms, public instance. Okay, this is just an alias name for your public instance. But this is the keyword which they use in your examination, guys. So security group. So people, you can have a security group if you want to be very serious about the security. Like you can allow only RD people. I mean, your MySQL port and all these things. So fine, let me give it anywhere, review and launch, and let me launch it. So people, one of my instance or the Bastion host is getting launched. In the meantime, it get launched. What I'll do is, let me launch one more instance, which is going to be my private. That's going to be very main one, right? So select. I'll quickly fast forward this. People, I'll call it as application tier since my application will be running inside this. So yeah, this is also getting launched. Now what I'll do is, let me first of all SSH into my public one. So where's my Bastion host? Here it is. So let me copy the public IP. In organizations, do we have key pair saved for instances? It depends. Okay. So whatever the questions you basically ask, everything depends upon the organization to organization. If they think like they want to be very in a perspective of security, they're gonna be using key pairs every time they create a machine, or they get into the machine and use SSH keygen to create new keys. So cool guys, let me quickly get into my public instance. So I'll paste the public IP, username, I'll give Ubuntu since it's a Ubuntu machine. And over here, I'll give my key pair. There you go. Okay, I was successfully connected. Okay, I'll check it out all later. No need to worry. So let me enlarge the screen a bit. Cool. So people, now to SSH, I need to have the key pair of the private instance. So let me get the key pair rather than using FileZilla or WinSCP. I'll just copy and create a key pair simply out here. So I'll open the key pair, Control C, copied. I'll write nano here, some random name, and paste it. Save and come out. That's it. As simple as that. It gets you lots of time saved rather than getting your FileZilla, getting and transferring out. Even mobile XTEM helps you with that. Even if that's a timeout, basically it will not go into timeout. If it goes into timeout also, you can click R, simply it restarts. That's the best part of mobile XTEM. Okay, I have given some random name as K. So fine, guys, let me hit chmod 400 so that the key will be in a readable format. Green, I hope this is a basic step which everybody knows. See, I opened the key pair in my local machine, copied it, and created a new text file using nano and just pasted that. Simple. Okay. So fine, guys, Ubuntu at the rate of the private IP. So yeah, here you go. There you go. You have successfully SSH into your private instance. This is your private instance, guys. So since we have given the NAT gateway as well, it should be able to talk to internet. There you go. I hope it's pretty much clear to you, right? Cool, guys. So people, we have done the first step till now. So let's see what other things we can do. Where is that? Yeah, here you go. So we have created the VPC. We have set it up our security groups as well. NACLs, we are going with default. That's fine. So create a Bastion host. Yes, we have done that. Now let's create an S3 bucket. Okay. So let's go ahead. So let's say create bucket. And let me give a name to this bucket. Let's say project bucket 7. Hopefully, I hope it will be there. So people, as you know, S3 is a global service. There you go. It's not region specific. It's a global service. Now, if this is a global service, why do you think it's asking AWS region out here? S3 is a global service. So people, whatever the data you store into bucket, that should be stored into some region, right? Ultimately, that's the reason it's asking you AWS region. S3 is a global service, but whatever the data you store inside a bucket, that's gonna be region specific. Okay. So yeah, I kept in North Virginia. Fine. ACLs, let me enable that. Cool. Bucket versioning, I don't require that. Let me create this particular bucket. Okay, this name is not available. Okay, there you go, 007, very fancy name. Let's check. There you go, it works. Cool, guys. So we have our bucket. Bucket is ready. Let's go to the next step. So people, bucket we have created. Now create an RDS instance. Okay, we'll do that. So people, let's come to this RDS part. Okay, so I need to have an RDS instance now. Let me go and create it. So click on database. So RDS gives you multiple cluster engines, guys, like Amazon's Aurora, MySQL, MariaDB, Microsoft SQL Server, Oracle, Postgres. So I'll go with MySQL for tonight because I have the code for MySQL, to be very frank. So I'll be going with MySQL. But based on your organization need, for example, there are many organizations who use Postgres as well. Okay. So based upon their need, you need to go and deploy it. It's not your personal choice which one you will go with. Okay. Cool. So now let me see. So cool, people. Okay, people, now let's go with free tier. That's more than enough. And I would also suggest you to go with free tier, guys, because or else you'll be getting charged. I don't want you to get charged. So go with free tier. That's more than enough. And it even reduces the time of creation. If you go with production or developer, you'll be having even multi-region also. So that takes lots of time for the deployment. But let's go with free tier. That's fine. So DB instance identifier, DB database one, let it be. So the username of the database is admin. Okay. I need to have a password for the same. I'll give something like admin123, which is very easy to remember. So let's say admin123 out here as well. Cool. Now I'll leave everything to default. So 20 GB is more than enough for me. Auto scaling. Okay, let me enable that. Here, people, I'll go with my VPC. Since I have my own VPC, I don't want to go with anything else. Project VPC, I'll choose that. Cool. People, here comes a $1 million question. Should I give public access or not? So people, if I don't give public access, whatever the data you store, how it will be coming and storing, right? Making sense now? If I don't give public access, guys, the correct answer is no. Why? Because you're not directly accessing your RDS, right? How you're accessing your RDS? You're accessing your RDS through some instance, right, guys? So instance will be able to access that RDS, right? Even if it's a private. I hope it's making sense to you. Exactly. Then we need to give that, Arvind. If you want this another instance where if it's launched in some other on-premise or if it's launched in some other cloud or some other region or some other account, maybe, then you need to give public access. Okay. But right now I have my instance in this particular VPC. So I'll make it private. And the main purpose of this is, guys, it's my data, which is very confidential, right? All these companies like Meta, your WhatsApp, your Apple, they'll not be keeping their databases to be accessible by public, right? They'll be keeping them everything in private. So they'll be only able to access that data. So fine, security group, let me go with mine. Cool. Let's check the additional configurations. Okay, that's port. Cool. So people out here, initial database name. So what is this is, whenever this cluster is getting created with this particular MySQL engine, it will ask you to create an initial database if you want to give any initial database. If you don't give it now, you need to connect to your database engine, then you need to create the database. But I'll just mention out here something like project. So it creates this database when this cluster is getting deployed. Okay. So it will save us some time, nothing more than that. So cool, everything looks perfect. Guys, any service you deploy in AWS, once your thing is done, terminate it instantaneously, even if that's free tier eligible. Okay. Cool. Let me click on create database. Okay. So people, this database is going to be taking time to create. Okay. So we'll do one thing. By the time it gets created, it takes around about easily 10 to 15 minutes to get created since it's free tier. If that's production or development, it's going to be taking around about 25 to 35, 40 minutes even. So people out here, my RDS instance is successfully created. Now, I need to connect to this particular instance. So to connect to this particular instance, you need to install client first. So for example, if you are dealing with EFS, right? So what will you do? You will install a client first, then you will try to connect to that EFS. Like if you have created an EFS, elastic file system, right? So before you want to use that EFS, you will be installing the client first. EFS utils or NFS common. I hope you would have heard to these terms, right? These are the clients. They act as a bridge in between your EC2 instance and the elastic file system. The same way over here, we need to have a bridge for my EC2 instance as well as the RDS instance. So the bridge in between out here is MySQL client. So let me install that. So first of all, let me update the machine. Sudo apt update. Say and now let's give the other code. Sudo apt install MySQL client. So this is the command, guys. MySQL client -y and hit enter. Okay, cool. So people, my client is successfully installed. Since my client is successfully installed, I will be able to connect to my RDS instance. Let's see how does we connect. Okay. So the command is MySQL first and followed by -h. So -h over here means that host point. Host point is nothing but the endpoint. So you'll be having an endpoint. It's like your public IP when you want to connect to your EC2 instance. On the same note, here you go, you have this endpoint. So yes, you need to copy this endpoint first, come back over here and paste it, followed by -u, and you should give the username. So people, can you tell me what is the username of my this RDS instance or the cluster? Very good, guys. Admin it is. And the pass is admin123. Small p stands for password, capital P stands for port. Anyway, I'm trying with the EC2 instance. I will not define the port. It automatically takes it out. So the password is admin123. Let me hit that and hit enter. Everybody able to notice this? MySQL? Yes. So we have successfully connected to our RDS instance. Cool. On the same note, now, if I see what are the databases available, like let's say show databases. So can you see, guys, you're able to see something called as project. If you remember this project is the one I have given initially when that cluster is getting deployed, right? Agreed on this point? Or else you need to hit create database and give the name of the database and you need to create it. Cool. Since I have my project, I'll use that only. Let's say use project. Cool. In this project, let's check whether I have any tables or not. Let's say show tables. So what do you think? Do I have any tables or no? Of course, no tables, guys, because this is a fresh database. We don't have anything out here. So to create table, you need to have SQL command. But trust me, this is not our part because we are architects. We don't know that. So what you can do is you can take the code from your developer to create the table. So let me take it out. So there you go. I'll copy this and paste it. Hit enter. That's it. Now, if I hit the same command, show tables, can you see, guys? There is a table with the name employee got created, right? Now, if I describe employee, let's see what else are the contents in it. So people, can you notice in this particular table, I have some fields like employee ID, first name, last name, primary skills, locations. So now I able to recollect, you have seen all these things somewhere else. Where did you saw all these things? All these elements, employee ID, first name, last name, very good in that web page or the template, right? So whatever the information you gave out here, that should be ultimately flowing in and saving in this particular table. I hope everybody are able to relate this. Right, guys? Yes, there you go. Employee ID, first name, last name, primary skills, locations. So there you go. Cool. So everything looks good. So what I'll do is, I won't disturb this page since I might come again to check whatever the data you have inserted. So people, now what I'll do is, now let me duplicate this tab because I don't want to go back leaving MySQL. Let me duplicate the tab. So by default, I'll be landing in my public instance. Now I should get to my private again. So ultimately, what are the commands you have written to your previous machine, that should be carried forwarded here, actually. Okay, cool. There you go. Back to the game. And if you see here, my existing commands are. Okay, cool. There you go. So fine, RDS is created. That's great. Now what I'll do next? Now create a DynamoDB table. Okay, let me come to the DynamoDB now. So people, as I already told you, I hope you had a basic understanding regarding why we are having a DynamoDB. We are having DynamoDB just to have the metadata of your S3. So what is metadata? Something like this, okay? So let's say there is a class and there are a bunch of students, okay? So in that class, the attendance register gonna be handing over the metadata of the students. Ultimately, they'll be having their names, they'll be having their information, their number, and something like this, right? Which means that it's giving the data about data. Metadata is nothing but data about data. For example, I'll give you the scenario what exactly is going on out here. Like whatever the image gets uploaded into your S3 bucket, okay? So you will be having that employee ID as well as the URL of that image, okay? That's what your simple metadata is. Rather than going to your S3 bucket and checking who uploaded which image, you will be directly having the metadata in your DynamoDB, okay? That's your metadata. Now let me create a table, guys, and you will come to see how quick this is gonna be. So table name, let me give something like metadata itself, metadata table. Okay. So partition key. So people, partition key is nothing but it's your first column in the table. Okay. So I'll say EMP ID, employee ID. Now let me click on create table, guys. So people, if you can see, it's in creating state. Now let me refresh this. Can you see this? The table is in active state. It's roaming outside, but yes, table is active and everything is active. That's how quick your DynamoDB gonna be, because it's a non-SQL database. Now, okay, we have done this. Now let's see what exactly we need to do next. Domain name setup. Okay. So there you go, guys. 25 GB. Still, we didn't complete static website hosting in S3. For example, in static website hosting, you can give some about us page and you can refer that to the application. You can do that. So sky is the limit if you want to just do it. Okay. Now they're asking me to set up what? Domain name setup. Cool. So people, anyway, I'll not be creating this auto scaling groups or auto scaling group. Why? Because we are not having that much load even. So even if we create also, nothing will get launched. But we need to have a load balancer. I'll tell you why. Okay, guys. Now let's go back to the instance. Okay, so we'll do one thing. First of all, let's install the application. Okay, so we have that application inside this GitHub link. Okay, cool guys. So let me show you. Now let me copy this HTTPS link and let me go back to my instance. And people, now I'll use this command git clone. Okay, now git is it's a differently version control tool. I don't want to get into git now, but remember this: if you want to clone something from the GitHub repository and you want to download it in your machine, you can use git clone, and you should give the HTTPS link. And if I hit enter, it successfully cloned the application from GitHub to my local machine. And if I do ls now, can you see there is a directory with the name aws-code -main. Okay, now let me get in. So let me do ls. So there you go, people. We have multiple files out here. This is the main application file. I'll not disturb it right now, but I have some file called as config.py. Now what I'll do is nano config.py. So people, can you notice this? It's asking custom host, user, password, DB, bucket, region. So do you think it's necessary or not for the application? Of course, guys, it is necessary, or else your application might not write the changes or whatever the traffic is giving to it to this particular services. Ultimately, it throws an error. So now here I'll come and paste the endpoint of my RDS. Okay, where is my RDS? Here it is. Copy it again, come over here and paste it. And here RDS username. So what is the username of my RDS? Yeah, password is admin123. So inside this RDS, I might have lots of databases, right? So in this, which database you should write? That's gonna be project. So project bucket 007. Cool. So people, right now I am in North Virginia. North Virginia is nothing but US East 1 itself. But if you're working in some other region like Ohio, Oregon, that changes. So Ohio is US East 2. So there you go, US East 2. And Oregon is US West 2. Based upon this scenario, you need to change it, guys. For example, if you're working or making this entire deployment in Ohio, then you shouldn't give US East 1. Your application will not work and the data will not be written into this particular applications. Okay. Is that making sense to you people? It's like you're having a picture booked at some theater and going to some other theater. Okay. So cool, guys. Now where am I? Yeah, let me go back. I'll save it and come out. So people, did I configure every service or did I left anything else? DynamoDB. So in this entire file, I haven't configured my DynamoDB, if you see, right? So it's not our mistake, guys. It's our developer mistake. He hasn't given out here. So where he has given is, he has given inside emp app.py. So let's open that. So there you go. It's the entire application source code. I'll not disturb anything, but I'll simply go to DynamoDB section. So here you go, DynamoDB. And people, if you remember, what is my table name? My table name is metadata underscore table, right? So I should give that. Cool. And over here, you should also check which region this table is in. So mine is in North Virginia. So US East 1, it is there. But if you're giving somewhere else, make sure you do it, guys. If you don't change it, every data, every saving will be getting saved. but DynamoDB will not be working. So ultimately it throws an error. Okay, I saved it. Let me come out. Cool guys, looks like everything is perfect. You have configured everything, but if you try to run the application, it fails. Why? Because so people, my application is built using Python, but for that to get running, it should have some dependencies. For example, like Flask, PySQL, and I mean not PySQL, PyMySQL. Yes, all these things. So let me install the dependencies first, then followed by run that. Okay. So Python 3 by default it will be there in Ubuntu if I'm not wrong. Let's check that out. So yeah, it's there. Also Flask, this will not be there. We should install. Flask is an additional module. -y. So let me install this command. Let's say over here, I'll not give -y. Let me hit enter. Okay, let's try this one. This should, for sure, it will ask. Okay, so people, if I hit enter, do you see a prompt? It's asking, do you want to continue or not? So if you don't want to give it, right? If you don't want to give it additionally, what you can simply do is, whenever you're giving the command -y, that's it. So everything is perfect. So people, your application, if I hit this command, your application will also trigger and run. No worries on that part. But there is a catch out here. Now, if I show you, so people, where is my application running? Right, private instance. Very good, very good. Now, do private instance have public IP? Of course not. Then can I use private IP to get the application or the web server page if I have a web server? No, the private IP can also not be used to get the web server or the application. So whom do you think is the comes to rescue now? So there is the hint. People, the answer is load balancer. How? A load balancer will take the traffic. For example, where is this pen? Yeah. So this load balancer will first of all, so for example, let's say this is one domain, you're flowing in till here. And from here, this will be forwarded to your load balancer. And load balancer, with the help of target groups, it will be forwarding this particular hits or the requests to your instance wherever it is. Either it might be private or it might be public. For example, if you don't have a public IP address, you'll not be able to access your application. So if you don't have a public IP, what you can do? Arvind, I'm doing that only, Arvind. I'm repeating it again. Okay. So people, in that case, what you can do, if you have a load balancer, inside your application load balancer, you will be having something called as target groups, right? Agreed on this point? Target groups? Yes. So target groups are nothing but, for example, let's say I have this particular subnet. In this particular subnet, you can say you have two machines and only one machine is the load, application. So target group will forward this particular load to only to that particular machine, irrespective of how many machines you have. So with the help of that, the requests which are flowing to your load balancer will be directly reaching your private instance rather than going to your public instance or anything else. Now I need to have a load balancer, so let me go out here. Green, let me show it practically rather than a repeat. Okay, that will make more sense since I repeated already twice. Okay, just hold on. So let me get to a load balancer now. So let me say create a load balancer. Okay, let me say create an application load balancer. So let's say a project will be using what they have developed the front end application, React, Angular. So people, this load balancer gonna be internet facing. Okay, there you go. Because whatever the hit comes from internet, it should be able to take it. If you give internal facing, if any request comes from a particular VPC, then only it will be taking. But right now I'll keep it internet facing itself. Now VPC, I'll choose the one mine, project VPC. And here, let me choose the subnets. So security group, I'll give mine. Okay, cool. Now here you go, guys. Finally, target group. I really don't have any target group now. Now let me create one target group. Now you'll come to understand what is a target group and this thing. Green, it will be much more clear to you now. Have a focus look out here. So see, in this target group, in that particular two subnets, I have two different machines. But where is my application running? Of course, it's in the application tier. So if the traffic goes to your Bastion host, that makes no sense because even Bastion host will not take any requests. So you should select this, the application tier. Okay. So all the requests, all the traffic will be flowing to your application tier. And let me create this particular target group. So fine, target group is created. Now if I go to load balancer and let me refresh this, I should be able to see a target group. There you go. Target group is added. Now I'll come down and create this load balancer. Now this load balancer will give me a DNS. Okay, there you go. This is my DNS. Irrespective of your application is running in a private instance, you will be having this particular DNS. So if you access this, if you open this, you will be able to access the application running in a private instance. So it's in provisioning state. Let's wait until it gets provisioned. Okay, let's not wait. We'll do one more thing, guys. I need to show you one more thing as well. I have created a load balancer, created a target group, and just, I've just created, that's it. That's how. Like, if you want me to show, create load balancer, I went to application load balancer, gave it the name. We can create new Bastion host if we delete it, right? So chosen my VPC where my application is and created this one. That's it. Okay, no worries. So we will do one thing. First of all, let's trigger the application. Okay, let that get running by the time it will be created. Okay, application is started. Let's wait. It's gonna be pinging the internet very soon. So there you go. It started pinging. So where is this instances? Okay, it's active, guys. Now, if I copy this DNS and paste it, let's hold on. It's taking a bit of time. So there you go. This application is ultimately getting launched in your private instance and you got connected to it. Cool, looks fine. Now, rather than having this much DNS, how about I have a short domain name? So shall we go and do it? Yes, we'll do that. So where is my route 53? Yeah, here you go. I'll use Freenom, guys, for my domain. We're about to register for a new one. I tried to register, but it's not creating a website for me. is Freenom is not getting allowing you? That's what you're saying? Website address. So let's check what are my previous domains, which all I have. Okay, we have tons of domains. Let's use this one, guys. This is my personal domain actually. So first of all, let me get to Route 53. So over here, I have two hosted zones. Let's see what are those. Okay, both are not us. So people, over here, what I'll do is I'll click on create hosted zone. Okay. Once I click on create hosted zone, I should give the domain name, exact domain name. Let's say that is kevindomain.ml. So let me copy the same. Sorry, TK. I should be having ML also. Okay, no worries. Let's go with TK. So let me paste the same. Cool. So this is going to be publicly hosted itself because it should take the traffic coming from internet. But if you wish to have a traffic coming only from a particular VPC, you can go and give that VPC region and VPC ID. But I'll go with public because I want even you to access that and give your information. So let me click on create hosted zone. People, once you click this step, so as this is a chargeable service, here you'll be getting charged for entirely 1 month. Okay. So cool. So you have created the domain and you have created the hosted zone. Now what I'll do is I'll click on create record. I should have a record out here. Okay. I hope everybody knows this from here. If you have a public instance which is running with an application, you can give the public IP. But right now I don't have a public instance. I have a private instance where my application is running. So what is the DNS I have? From where I have the DNS? Very good. Load balancer, right? So I'll click on alias and I'll take the load balance out here now. North Virginia. And there you go. Project LB. Let me click on create records. Okay, one side it's configured. So the traffic from your load balancer is configured to your Route 53. But Route 53 and the other domain provider are not configured. So you'll configure them by copying the name servers. Okay, copy the name server, come to your domain provider and click on manage domains. Guys, the procedure is very much common if you're using GoDaddy, Hostinger, or whatever it is. Okay, don't get panicked. It's really taking lots of time since it's a free domain provider. It actually gets down. Most of the time, it's the website goes down itself. I hope my internet is good, but I don't know what's wrong with free now. Yeah, my internet is good. Looks like Freenom is down. So fine, people, here you go. Now I'll click on name servers and let me paste that. So cool, I have given my name servers. Let me click on change name servers. Yeah, for example, let's say register domain. So there you go, the charges. Have a look on this. .com is $12 and .ac is $76. This 100 .adult. Got it. Goes on and on, on and on. So people will do one thing. I hope this is really wrong with Freenom. So what we can do is let's use the DNS of the load balancer. Okay. Or let me try to do the other way. What I can do is since I already have some registered domains in hosted zones, let me try to delete the existing record and give the new record so that name servers are already configured out there. Let's try to do that way. Let's say I have this domain. Okay. Okay, let's check the moment of truth. I really don't know, guys. I just want to show you. That's the reason I'm experimenting. But if the name servers are not configured, it will not take me anywhere. Okay, looks like it's working. Cool. So people able to notice this? In place of DNS, I simply have domain. So don't get confused. What happened is this hosted zone or this domain is already pre-configured with the name servers. So what I have done, I simply created a record and ultimately the bridge is there and the traffic is flowing. So fine, guys. Now, guys, I'm really going with some random data. You can give with your own data. So let me upload an image. Yeah. And click on update database. What do you think? Will the data will be uploaded or not? Yes or no? Quick yes or no, guys. So let me show you. So people, can you notice? Unable to locate credentials. I'm getting an error. Can you tell me why I'm getting this error? I'll give you a clue. With the help of this picture, can you figure it out? We have mentioned the DB details. We have. I hope you are not following. We have given the DB details. So people, very good. IAM. So there is no IAM role given. So this instance can't talk to the other services. So I should give a IAM role to that particular instance so that it can talk to RDS and S3 and DynamoDB accordingly. Yes, let's try to give the IAM role and check it out. You should give the role of an IAM so that this instance can talk to the others. Okay. So I already have a role. So I'll show you what that role is having. Okay. So people over here, if I check the roles, okay. And if I show you the role, what is there? Okay, looks like someone has deleted that role. Guys, just give me a minute, please. So let me create a role. So I'll say AWS service. Let's give it to EC2 because I'll be giving it to EC2. Click on next. And here I should have RDS. Let me hit RDS. So I'll give RDS full access. Then I should give DynamoDB. So there you go, DynamoDB. I'm giving full access. Cool. Now followed by S3. S3 full access. Cool. Now, since I have given 3 of them, now let me click on next. Now let's say project. Click on create role. Okay, role got created, guys. Now I'll go to my instance. Let me attach the role. So here I'll type project. Yeah, there you go. And update the IAM role. People, I have updated the IAM role. Now this shouldn't be the error anymore. So able to notice this? It's saying save successful, right?
Let's have a quick quiz question, guys. And the question is, Amazon EBS currently supports up to -10 PS per volume. And your options are 10, 100, 1000 or 10,000? Please mention your answers in the comment section below.
Just a quick info for all of you cloud enthusiasts. If you want to make a career in AWS, then you might want to check out Intellipaat's AWS certification training course for solution architect. Learn from industry experts through hands-on session, projects, and case study. Reach us out to know more.
The LMS under the cloud computing curriculum, the AWS Solutions Architect Associate that we're going through, you have three sections over there. Self-paced are the videos. Now, I would highly recommend the people, especially from non-IT and freshers, non-IT background freshers, that whenever you get some free time, go through these self-paced videos. Whenever you get some free time, okay? Others as well also make the best use of it. These are pre-recorded lectures. You can just go through them whenever you get some free time. The assignments that you can see over here, assignment 1, assignment 2, assignment 3, these are the one that you're supposed to do by yourself after the class. So self-paced consists of these self-paced videos, and then we have the study materials, which consist of the module-wise PPTs and lectures. Fine. All right. So that's about the overview of the LMS. AWS is all about practicing and practicing. The more you practice, the more you're able to reap the benefits. So it is equivalently important that you should have all this free to your account, without which you can't practice. Okay, so it is mandatory. Website name is aws.amazon.com, right? So you have to go to this website. You need to have a credit card, debit card. Okay, once you have the credit card, debit card with you, you can go in and just sign up. And you have to sign up for a basic free tier account. So the account that you're looking for is free tier account, with support plan as basic, So make sure that you go ahead and do that after the class gets over. You have to put in your credit card information, debit card information. You have to put in your personal information, your phone number, your address, and that's it. See, don't use any account that's been given to you by the company, right? I'm not sure what rights the company has given to you. Don't use the account which is given to you by the company. Now, the thing is, all of you, I'm not sure. So no one has, okay. So anyhow, if you don't have the free tier account, this is exactly where you have to go. aws.amazon.com to get your free tier account created. Okay. It's a very simple thing. And you have to basically, if there's a support plan that you have to choose, support plan during the sign up is basic. Now once you use your credit card, debit card, there will be a small deduction of 2 Indian national rupees from the credit card, debit card that you're using. That would be reverted back to you in I think 24 to 48 business hours. In study materials, see, you sign up for Facebook or Instagram, it's the same thing, except that you have to put in the credit card, debit card information. There's nothing like that. You can easily do it. There's also a PDF. Let me see that. So guys, there is the step-by-step process to create the account. You can go with that. It's the simplest thing. I don't think there will be any challenge for you. You have to put in the credit card, debit card information. After that, you have to just sign up. It will take you 5 minutes only. On the other side, let's focus on this thing, cloud computing. What is cloud computing? Let's start with the basics now. So cloud computing means that it is, in the simplest terms, the computer server is given to you by someone else. Who's someone else? The cloud provider. The server has to be accessed over the internet using a web-based interface for personal or business use case. So cloud computing means that you use some compute capacity, you use storage, networking capabilities, compute capacity over the internet, and you just pay for the services that you consume. For example, the simplest example is Google Drive, right? One Google Drive link was shared with all of us, and we just use that Google Drive to download the documents, right? So we use that Google Drive. So the Google Drive is nothing but it's a cloud-based storage service. Fine. Now the document that was uploaded by Akshay on the Google Drive, was it stored, or I would say, was it uploaded to his own remote server? The answer is no. That was uploaded to a storage infrastructure or a storage device which is running in one of the data centers owned and managed by Google. So Google manages that service, Google Drive. It uses its own infrastructure to give you the amount of storage, 15 GB free for every account. Plus you have to buy more storage and you pay for that. So the storage that we're consuming is not owned by us or managed by us. It's been given to us by a cloud vendor, which is the Google in this case. So Google says that, okay, we'll give you some storage, you upload the documents, and also we give you some advanced sharing capabilities. Fine. So Google Drive is one of the best examples for the cloud computing that we use on daily basis. Okay, let's take a step further. Let's suppose we watch Netflix, we binge Netflix, YouTube videos. Those media files are not stored on our hard disk or on our computer. Down in back on those days in 80s and 90s, we used to have CDs or VHS cassettes, or then after then pen drives, right? So we used to save the media files on a physical storage locally and run the media files. Now we watch Netflix, YouTube, Hotstar. There are a lot of OTT platforms which are used by the people nowadays. Those media files are being streamed over the internet. Where those media files are being saved and streamed from one of the servers on the which are owned by your one of the cloud vendors. For example, Netflix is used by Amazon Web Services. So if you're watching Netflix, this means that the complete infrastructure, the media file management and delivery is managed by Amazon Web Services. Fine. So in simplest terms, you're using some storage capabilities, some compute capacity, streaming media services, storage services like Google Drive, Dropbox. And that infrastructure is not owned and managed by you. It's running at the back end. You're consuming those infrastructure resources over the internet. In Google Drive, you upload the document, store it on one of these storage servers in one of the Google's data centers by using internet as a medium. So this is what we say that as a day-to-day use case. Fine. What about businesses? Businesses have to run their very robust applications, and those applications need a lot of servers. Based on how large your organizations is, hundreds to thousands of servers are needed to have those applications running. So in this case, these cloud vendors say that, okay, you don't have to set up the data centers. So okay, so data centers are very huge. And they require a lot of investment in terms of money, time, and effort. So if you see the data center pictures, if you visit data centers, in your company's premises, you will see that these data centers are humongous. The acres and acres of lands are needed to set up a data center. You have to set up the racks, install the servers inside them, right? So a lot of investment is needed to lease the land out, get the entire physical infrastructure set up. You have to take care of the power backups, then amount of air conditioning, cooling, because if the air conditioners don't work properly, then there's so much heat being dissipated from these servers that they will blow off. So air conditioning, power backups, cooling has to be done. You have to hire employees to maintain these data centers, right? So setting up huge data centers or maybe medium-sized data centers requires investment of tens of thousands or millions of dollars. It's a very huge investment that goes into setting up the data centers. Let's suppose you work for a company A. Company A says, I want to deploy my own data center to host my application services. You can do that. But the problem is that setting up a data center is not a one-time investment. It's a long-term investment, because once you set up a data center, spend millions of dollars into that, then to operate it, make it operational, requires a lot of investment. A lot of investment. Fine. So it's not every company can afford to have that. So company A says I want to go with a data center deployment because it has a lot of cash to burn. Company B says I don't have that much of money. Even if I have that much of money, why don't I use a cloud computing platform, use their data centers, and pay for the amount of resources I've consumed? Both company A and B, they have let's suppose $20 million in their bank account, in their company's account. Both have 20 million US dollars. Company A says I want to just I will be spending 5 billion US dollars in data centers deployments. Company B says I want to save that 5 million US dollars, and instead of that I'll be using a cloud vendor's data center, pay them in on monthly basis, and I don't have those 5 billion US dollars that have to be put as capital expenses into data center deployment will go into my business use. For example, company B is a pharmaceutical company, right? A pharmaceutical company has the should not be going for a data center deployment. It's not their business. So they're saying that I want to deploy some application services. I'll be rather using that 5 million US dollars in setting up my big factories to manufacture medicines, and then I'll invest very small amount in running my workloads on applications through cloud on a cloud vendor's infrastructure. So AWS, Microsoft Azure, and Google Cloud Platform, there are multiple cloud vendors like DigitalOcean, Salesforce, Alibaba, IBM Bluemix, Oracle Cloud. What this says then that we have these huge data centers scattered across the globe. Okay, you don't have to set up any data center. You use our data centers based on the time consumed, resources consumed, and you pay the bills. That's it. Fine. So it becomes easier for the companies to use others' infrastructure at a fraction of cost. Fine. So in this case, this becomes very, very easy, especially for the small to medium-sized organizations. Plus, using a cloud computing platform is very flexible to use. A lot of flexibility. You can shut down, you can deploy the resources very, very easily. Okay, so I'll show you some more benefits over here. So in terms of cloud computing, virtualization is used. Virtualization is the creation of the virtual version of something, such as the operating system, server, storage servers, or network resources. Cloud computing platforms basically the resources are being accessed virtually in virtual format. Why virtual format? See, let's suppose you have this data center deployed, right? You are a data center deploy, right? You can physically do the cabling, you can do the server management, everything. You have access to physical infrastructure, you can touch it. But in terms of the cloud vendor, you have the same infrastructure that you physical infrastructure running at the back end. Amazon will have the same data centers running. However, you don't have access to those physical data centers because it's running far away from you. You use that infrastructure in a virtual format. So use this console to virtually remotely deploy the servers, right? So the virtualization technology, or I would say the concept is used so that you access all the resources virtually. For example, today I decided I want to deploy a server, right? Even though it's running on a physical server, but I would say it's a virtual server because it's not, I can't see it physically. I can't see exactly on which physical box it's running. Okay, so in that case, it's everything is virtual in nature. You have to access and consume the resources virtually. For example, Akshay has saved a document on a Google Drive server, but can he see that server? No. So he virtually uploaded the server and shared the link to us with us. Okay, so everything is virtual in nature in this case. All right, so everything is virtual in nature. So cloud computing has two main things that empowers it. One is, so basically the virtualized compute environment is over internet, or internet is the cloud. So if you access the compute infrastructure virtually using internet or internet intranet as a medium, it forms a cloud computing. So cloud computing, the simple math is, the formula is equal to virtualization plus internet intranet. So if you access the virtual resources or access the resources virtually over the internet or intranet, that becomes the part of, or that what the cloud computing is all about in simplest forms. Right? You can have multiple definitions. Okay, so what are the advantages? The advantages are tremendous. Of course, there will be some downsides as well. We'll also discuss the downsides. Live streams use storage services, how secure the data is. How secure the data is, it depends upon how safe you've made the data is, how safe the data is being made by you using security tools. Cloud vendor gives you different security mechanisms to safeguard your data. Okay, so in that case, you have to use those security mechanisms to make sure that the data is being kept safe. So depending upon, that's what you're here for. You have to learn the security mechanisms as well, how to secure the data. Depending upon how critical the data is, you can make it safe. You can use some firewalls, encryption algorithms. You can also use networking tools to safeguard your data. So that we'll be learning over the on-premises. Now, if I use the term on-premises, this simply means I'm talking about the physical infrastructure, data center infrastructure, which is owned by a company, which is owned by an organization. It's a physical infrastructure which is owned by an organization. Okay, first thing first, there's no capital expenses, right? For example, when you set up a Google Drive and you buy, so you say I want to go with Google Drive and I want to buy 1 TB of storage. I think that 1 TB of storage will cost you somewhere around 6,500 rupees per year. Even though this is very costly, in the same amount, Microsoft is giving us 6 TB of storage that I'm using as of now. So to get that 1 TB of storage, you don't have to buy any server, any physical device, hard disk. It's not required to you to buy, right? So, or for example, Google Drive says that we give you 15 GB for free. You just try. And if you think that you need more storage, you can go with 200 GB per year, right? They have some annual subscription, monthly subscription as well. And based on that, you can scale up your storage consumption. So upfront, there's no capital expenses that's needed. The cloud vendors are very flexible. They give you free resources or less expensive resources at the initial stage. You try those resources, right? And if you want to invest more, you can invest more. So at the initial stage, because you don't have to procure any hardware, you don't have to buy servers, physical servers, you don't have to set up the data center, there's no hard cash needed. Okay, because everything is being charged based on the seconds, minutes, hours consumed or the amount of storage consumed, right? So the time consumed by the running servers, you have to pay for that. For example, I deploy a server for 1 hour, right? And I stop it after 2 minutes, or maybe let's suppose I stop it. Okay, I have an instance or a virtual machine running for 1 hour. This is running. In that case, I don't have to pay for even for those 2 minutes. That cloud computing is so much flexible to use that you pay for every second, minutes or hours consumed, right? You deploy the servers and you stop them. So the time gap between the starting a server and stopping the server. So you start the server, or you stop the server. The time that is calculated in between, and you just have to pay for that time frame. You deploy a server, you launch a server, and you stop it. Whatever the time is, you just have to pay for the time consumed. That's it. You just have to pay for the time consumed. Getting a new server is very, very easy. It's as easy as clicking some mouse buttons. Getting a server on the cloud is one of the easiest things out. Okay, how? I'll show you. I'm not going into the details right now. I'm not going into the details at this stage, but guys, just give me a second over here. I'm gonna get a call from Intellipaat support. All right, so guys, let's get started with the next stuff now. So I was discussing with you the advantages of the cloud computing over having a data center environment. No capital expenses. Everything is charged based on the number of times consumed, the number of servers consumed, time consumed, and storage consumed. Okay, I was getting to the third advantage. Getting a server is as easy as clicking some mouse buttons. I'll show you that how easy it is to get a new server. How easy it is. I want to deploy a new server. Oh, this will be a virtual server only. Now, a virtual server is called an EC2 instance. What do you call it as? The simplest term that we use, you can see that it says, okay, it says instances, EC2. EC2 stands for Elastic Compute Cloud. I want to deploy an EC2 instance, which equals to the virtual server in the cloud. I just go ahead and launch an instance. I'm not going into the details right now. And I just want to show you that in next just 5 or 10 seconds, maximum, my server is deployed. Not more than that. 10 seconds, 15 seconds, you can see that my server was deployed in just two or three simple mouse clicks. Fine. Now, what if I have to deploy the server by myself without using cloud computing? I have to buy a server, a physical server, right, which requires some investment. Physical service is what? It's a computer only. It's a box with some RAM, storage, processor, everything. Fine. I have to buy a server. These consist of rack of servers. I have to buy a server, then configure it, install the OS upon it, get some licenses, then deploy a server upon it. Right. So that would have required me a lot of investment, planning, strategy, purchasing of software licenses, right? So it would have taken me a lot of time to get to that point. But deployment of a server just in next few seconds, is one of the easiest things out, right? So the ease of use, the ease of flexibility is what the cloud vendors provide to you. Okay. All right. What's the next thing? The next advantage is that they give you high available solutions without any extra effort. All right. What do you mean by high available solution? Let's imagine you have server A. Okay, you have server A. Okay, this is running your website. You have some web application running upon it. What if this goes down? Then a new server, a copy of A gets deployed automatically. A copy of a server A is deployed automatically in next few seconds. This is the best example of the high available solution. Or maybe, for example, you have server A running in for example, data center A. It's running in a different data center. Server B is running in a different data center. DC, data center. So this is running in first data center, this is running in second data center, right? So I physically isolate them. If one of them go down, the other one is still running. Then a B copy is deployed automatically. High available solution means that your cloud vendor may ensure that if something goes wrong, it can be taken care of. The servers can be deployed automatically. If the data has been lost, the data can be recovered automatically. Basically, without any extra effort, without any extra cost. There will be some cost, there's no extra cost, but there can be some cost involved, but automatically you can get some high available solutions with no upfront investment, with no capital investment. Security, error shield. Error shield means that you're doing some configuration, that some bad configurations is leading to the errors. So we can use some resources to rectify those errors before they can adversely impact our infrastructure. For example, there's a service called config, right? Config is a service where I deploy some firewalls, virtual firewalls called security groups, and I don't configure them properly. Immediately it will show me that this firewall is non-compliant, which means that if you put them it to use, then there will be a security threat. It will show non-compliant. Okay, so immediately I can rectify those errors in the infrastructure. So basically, it's not that they give the physical infrastructure. They give you a lot of enhanced features to make the best use of that infrastructure. So these now, if you have to use the same things in your own by your own, it requires a lot of investment. Okay, so that's why more and more companies are moving to the cloud, because it's easy, flexible, cheaper, and you get a lot of competition advantage over the competitor who's using its own data center, because you're investing your capital in your business, not in setting up the IT infrastructure. Fine, that's the concept. That's the concept. As easy as ordering an online product. Yeah, we can say that. Pablo, flexibility means you get a lot of flexibility in terms of resources management. You have a lot of flexibility to deploy a server in any of the data centers. AWS has multiple data centers across the globe. You have the flexibility to choose your data center where that server has to be deployed into. Error means that if you're doing some configuration which is leading to some errors, that can be rectified before it is adversely impacting your infrastructure performance. We'll discuss data center. We'll discuss the data redundancy options, right? So there's something called data redundancy. So in this case, the cloud vendor gives you some amount of data redundancy so that the AZ goes down. You can recover the data from a different AZ. Okay. Plus, we can back up the data using snapshots as well in other parts of the globe. For example, I can have one backup in California, second backup in Singapore. If, for example, in California, the data centers go down because of some disaster, I can recover the data from Singapore as well. We'll discuss that options. What's the reason the non-compliance occurred? So based on that, we can rectify those errors. Fine, we'll discuss those things. See, right now we are discussing the basics. Once we dive deep into these concepts, we'll make the practical use of all these advantages. Right? It's just a basic overview. Excess capacity usage. Excess capacity means that what is capacity, by the way? Capacity means the number of servers, right? What's the number of servers you have? Capacity means the number of servers. So you require 10 servers running at every time. But at a certain point, you need to have 5 times the servers because of the high demand. Right? No, that's not the thing. Capacity means in terms of cloud computing means capacity means the amount of resources you want. the amount of servers you need. Fine. So you set a 10 number of servers to be running every time, but because of the high load coming up to your infrastructure, maybe a lot of users are browsing your website, you want to exceed the capacity from 10 servers to 50 servers. So in that case, that's called the excess capacity usage. Guys, I'll not go with the slides very in detail because it will be very monotonous. Yeah, so that's for the basic of the cloud computing. And yeah, that was basic. Oh, questions? Okay, fine, no worries. All right, so we discussed the basis of cloud computing. You can also do a lot of research on the internet as well. What are the advantages of cloud computing? But it's not required. See, when you start going for the interviews and you start pitching in for the cloud computing architects and DevOps jobs, no one will ask you what is cloud computing. Believe me, now things have changed a lot. What's next? The next thing that we'll discuss would be the cloud providers. A cloud provider is a company that delivers services and solutions which are based on cloud computing to businesses and or individuals. So a cloud provider is an organization, a cloud vendor, we can also say that, which gives you the cloud computing resources over the internet, right? So you use the data centers, you use the cloud vendors data centers to deploy the services virtually. And these are the three big, I would say, big giants in terms of cloud service providers. We have Amazon Web Services, followed by Microsoft Azure, and then we have the GCP, which stands for Google Cloud Platform. Now, out of these three, AWS is the biggest cloud service provider, and the biggest means I would say this is the most popular. I can't say it's the biggest, but it's biggest in terms of shareholder, in terms of the popularity. Largest companies are Netflix, Reddit, NASA, even US government uses AWS. So it is one of the most popular. It is the most popular and the best cloud vendor as of now, followed by Microsoft Azure, and followed by GCP, the Google Cloud Platform. Right now, AWS started officially in 2006. Okay, so what is AWS? AWS stands for Amazon Web Services. It gives you the on-demand cloud computing services to businesses and individuals. It is owned by the e-commerce giant, which we all know, which most of us use, or all of us use, Amazon.com. And basically, this organization, AWS, specializes at providing infrastructure as a service. What it gives you, the infrastructure as a service. Now, what do you mean by infrastructure as a service? The compute, databases, networking, storage, all these comes under infrastructure. Right? They become the part of your basic IT infrastructure. What they become? They become the part of the basic IT infrastructure. So this basic IT infrastructure is given to you that you can access over the internet. Now, this platform will help the business to scale and grow, and they offer you secure cloud services like compute power, content delivery, database storage, and other functionalities. AWS has right now two main competitors: Microsoft Azure and the Google Cloud. Right now, Amazon Web Services is first as of now because it started very, very early. Officially, it started in 2006. So they officially got launched in 2006, but they were launched very much earlier, 2004. Right. So there were two people in AWS, Chris Pinkham and Benjamin Black. So I'm not sure they're still working or not, but they were the part of Amazon infrastructure team, Chris Pinkham and Benjamin Black, and they proposed that Amazon can also offer its huge infrastructure to other clients. And they started offering the services. The first service was SQS. SQS stands for Simple Queue Service. That was the very first service that they started out. So Simple Queue Service, let me just type it for you. It's called SQS, which stands for Simple Queue Service, right? That was the very first service that they started out offering to their clients in 2004, even before they got officially launched in 2006. Okay, Simple Queue Service. Then in 2006, they started offering other basic services like EC2, S3, and so forth. Fine. So that's the basics of that's the introduction to AWS. For example, if you store something on your computer, use a hard disk. The documents that you store on computers is stored where? On the hard disk itself. What's a server? A service is a computer only. It's a form of a computer which has its own physical disk or hard disk. So before cloud, the companies used to store their data into the physical disk of the storage servers. Hard disk drive, tape drives, solid state disk, whatever. They have to have some physical form of the storage, maybe in the form of tapes, maybe on the hard disk of the or solid state disk of the computer or the servers that they are running. Now, for example, let's suppose an individual has a budget of 90,000 rupees to buy a smartphone. Now, he can also buy an Android phone with the same money. He can also buy an iPhone with the same money. Even though it's a very layman example, what I'm saying is that it's not that which companies will use the best, which is preferred the most. Any company can use any of the services, AWS, Azure, GCP, whichever they think is the best for them, whichever they think is the best for the use case. It all depends upon the taste and preference. All are secure. There's no that one is least secure, one is less secure. Everyone has all the security mechanisms. So, but from the shareholding side, AWS has the largest shareholding footprint in terms of cloud computing, but all are good. Why Tesla gained popularity? Even though nowadays people buy electric cars from Tata Motors, from MG, from MG, from Hyundai, from other vendors as well. The electric cars have become very popular. The EVs, electric vehicles. But when we say EVs, the very first thing that comes in our mind is Tesla. Why? Because Tesla was the first manufacturer to bring out the fastest electric cars. It's not that Tesla was the first company to introduce electric vehicles. Even before, EVs were there, but they were very small. They were very underperforming. They didn't run very fast, right? So, but Tesla was the first manufacturer or the company to produce the fastest and very robust and high performant electric cars, right? So that's from there. That's why it established its brand as one of the biggest EV manufacturer or the most popular. The same stories go with AWS. AWS was the first company that set up the cloud computing business and made it popular even years before Microsoft and Google. They started with the same business. So AWS got the first move advantage. They started officially in 2006, even though they started offering in 2004. Microsoft Azure came, I think, 5 or 6 years later, followed by GCP. So they were very late into the competition. So they started the earliest compared to other competitors. So they got the first move advantage. So they were the first company to offer the cloud computing services to other customers, which were very innovative at that time. So they got the first move advantage. So they became the Tesla of EVs. They were the first major cloud player in the market. Even before Microsoft Azure and GCP, they jumped into this business. It can be done. You have different methods. You can back up the data to your own on your own computer's physical disk and upload the data to other. See, there's something called cloud interoperability. You can also link the clouds with one another. You can use a hybrid cloud kind of infrastructure. It's called cloud interoperability. So it's a concept that was there was a white paper which was introduced in 2014, something like that. So which means that multiple clouds can operate at the same time, right? You can have Azure, GCP, AWS used at the same time, and you can easily shift the workloads from one cloud to another, use them simultaneously, or you can shift your data. You can do that. For example, let's go with the India getonline.com, yeah, hostgator.com. Okay, these are some, for example, local companies which give you access to the website hosting on their own cloud platform. HostGator, indiagetonline.com. You can use their platform to host the websites on the infrastructure. Now, when you got access to the account, you might have seen this thing that on the right hand side, these are the different geographical locations: North Virginia, Ohio, California, Oregon, Cape Town, Hong Kong, Jakarta, Mumbai, Seoul, Singapore, Sydney, Tokyo. Can you see that these are different geographical locations? This is what we're going to be discussing about, that what these locations really mean, right? So the thing is that in terms of an architect, you have to understand that there's a concept called global infrastructure. What you have to understand is that how the Amazon has scattered its infrastructure in different countries. So how much footprint they have. See, the thing is that yesterday we discussed these things, that you're using the data centers which are managed by your cloud provider. You don't own that data center or those data centers which you're going to be using. The very first component of the infrastructure is called region. What's a region? A region is nothing but it's a geographical location, right? It's a geographical location which consists of your cluster of data centers. It's a geographical location which consists of the cluster of data centers of a cluster. Cluster means grouping. Cluster of data centers, right? So when you group so it's a piece of land on the planet. It's an area. It's a large area which consists of multiple data centers which are grouped together, which are interconnected together. Fine. And these cluster of data centers inside the region are termed as availability zones. What are these? What are these called? These are called availability zones. In the short form, we call them as AZs. These AZs are nothing but these are the facilities, or you can say also call them as data centers, but we generally call them as facilities, right? Consisting of racks of servers. So these are facilities which consist of racks of servers. Racks means where we keep our servers, racks of servers. So basically they are the facilities which consist of racks of servers, or these are the data centers, I would say that. So what happens is that in a region is nothing but it's a geographical location which consists of a cluster of data centers, and these cluster of data centers are nothing but these are the facilities only. These are the premises which consist of the racks and racks of servers. Fine. So the availability zones are located inside a region. So you have a geographical location, you have an area. For example, let's pick Mumbai. Mumbai consists of 3 availability zones, 3 separate facilities which are interconnected with each other. Okay, let me just give you a few examples for you to understand. So for example, let's go to Mumbai. Let's switch to Mumbai, right? So what happens is that every region is separate. I came to this region right now. Now the thing is, if I show you this thing, you're going to be seeing that this is Mumbai region, right? Okay, one more thing before I can start with the next stuff. If it is to show you the AWS Global Infrastructure, there's a website where you can see that. This is the link to the website. You can just go through this thing, and when you can just open this page whenever you want. Basically, this is the map that shows up. The green dots, you can see these are the regions, existing regions. So as of now, there are 27 operational regions, 27 launched regions, each with multiple availability zones. So they have in total 87 availability zones. So as of now, because they're very fastly increasing the number of data centers that they should be operating. So they have 87 availability zones or 87 data centers, you can say that, in 27 distinct regions. Fine. And the green dots, you can see that these are the existing regions. For example, this is Mumbai, right? This is Sydney. This is Switzerland, Stockholm, London, Ireland, North Virginia. We have Canada Central. So the green dots, you can see that these are the existing, these are the running regions. The red dots, you can see that they're coming soon. For example, they are planning to set up a new region in Spain, so it is work in progress. In India, in Hyderabad, one in Melbourne, in Sydney. So they are planning to set up 8 more regions by end of this year in Australia, Canada, India, Israel, New Zealand, Spain, Switzerland, and Thailand. Okay, and this is what exactly the infrastructure really looks like. Okay, so it's very diverse, very scattered. Now the question that comes in, how exactly this can be accessed on the page itself. Now if you carefully see this page, on the right hand side, this is the Mumbai region, right? Every region has a special name assigned to it. Every region has a special name assigned to it. How does, for example, Mumbai is AP South 1. North Virginia is US East 1. California is US West 1. Cape Town is AF South 1. Tokyo is AP Northeast 1. Frankfurt is EU Central 1. Paris is EU West 3. Stockholm is EU North 1. Now you don't have to remember these names. There's no need for you to remember these special names. Once you start working on the AWS management console a lot, the regions that you access the most, you'll automatically remember these names. Now, no one expects you to remember them. There's no need to remember them, right? Basically, we are coming from that school background, college background. We have to memorize everything. Here, you don't have to learn. I would say you have to learn, not memorize. I would say that you don't have to just go and start learning these names. So let's focus on Asia Pacific AP South 1. So Asia Pacific is denoted by AP South 1. Region, that's the name of the region. That's a label assigned to it. So let's imagine. So let's take one example. In this example, let's assume that this circle represents the region of Mumbai. So this circle is the region of Mumbai, and this is depicted. The special name for it is AP South 1. What's that? AP South. So AP South 1 is the region that's Mumbai, right? So this circle represents Mumbai region. Now inside this Mumbai region, I have three distinct data centers. I'll show you them. I'll show you right now where exactly they're located, but you can see them. So for example, these are three distinct availability zones. Now, how can you see these three AZs in Mumbai? If you access few services, let's go to EC2. EC2 is a service that helps you to deploy a virtual machine, a virtual server in the cloud, right? So I go to EC2 right now. All right, this is called the EC2 dashboard. What's this called? EC2 dashboard. Once you go to EC2 dashboard, you will see that there's something called service health column. There's a separate section. It consists of three zones: AP South 1A, AP South 1B, AP South 1C. So if you see the Mumbai, what is Mumbai? AP South 1. AP South 1 is which region? That's Mumbai. Then AP South 1A, B, and C are three distinct availability zones in Mumbai. Fine. So you can see that in this case, if I just go back, AP South 1A, B, and C. These are three distinct availability zones inside the region that's AP South 1, which are interconnected with high-speed fiber optic cables. You can easily synchronize your data between or your services between them. The data, the services, anything, the traffic can be easily synced between them because they're interconnected. Right? So AP South 1 is the region of Mumbai, which consists of three distinct availability zones: AP South 1A, right? So AP South 1A, AP South 1B, and AP South. So these are three distinct AZs. These are three AZs. I'll give you some more examples. Let's go with the next example. Let's pick, for example, Frankfurt, right? So Frankfurt is labeled as EU Central 1. Okay, let's go there. Now, once I just go to the EU Central 1, you will see that I just go to the same EC2 dashboard, right? I've just changed the region. So EU Central 1 is the region which is Frankfurt, fine. And there are three distinct regions out there inside it. EU Central 1A, let me just annotate if you can do that. These are the one. EU Central 1A, B, and C, which are located where? In EU Central 1, what is EU Central 1? That's a Frankfurt region. I'll give you a few more examples to get some more understanding. Let's go to North Virginia. Now, North Virginia was the very first region that set up in 2006. So this is the oldest of all the regions. I would say this is the first region they set up. And inside this region, so this region is labeled as US East 1. It's on the east coast of US. So US East 1, North Virginia, and US East A 1A, B, C, D, E, F. So there's six distinct AZs or availability zones inside the region of North Virginia. Inside the region of North Virginia. So that's how these two things operate with each other. I would say in cooperation, they're interrelated. A region is nothing but it's a geographical place, it's a location, it's a piece of land on the globe, which consists of distinct AZs clustered together and interconnected with high-speed fiber optics. They're interconnected together so that you can easily synchronize your data, your traffic, your services between them. Right now, it's a very common question that people ask me very, very often: that are the regions interconnected? The answer is no, because these are very far distant apart. They're very far apart. They're not interconnected, but you can easily sync your data between them or traffic between them using internet as a backbone. Now you say internet, this means there's a security threat. No, you can easily sync your data and traffic, which can be encrypted. Cluster is nothing but I'm using a very common term. Cluster is nothing but it's a what is a cluster? It's a grouping of something. If you group the things together and bind them together, it becomes cluster, right? So inside a region, we have a cluster of availability zones. There's one cluster, one group of AZs together in a region. Now you're seeing POP's point of presence. It's a very common, see, we're using common terms over here. Point of presence means exactly, so I can say that a region is a point of presence. A region is nothing but it's a point of presence only. Point of presence only. So you can also say that each region is kind of a POP, or it's a point of presence. This is where Amazon is present and operational. So a region can be considered as a point of presence. That's how they're being present. That's where they may be being present in a specific geographical location. Sort of redundancy options we'll discuss afterwards. Okay, we'll discuss those redundant options afterwards. But okay, let me just elaborate this thing to you. Basically, the thing is why. Okay, AWS go with this type of this thing that they have this protocol to follow. What the protocol says is that there should be at least 3 AZs per region.
Let's have a quick quiz question, guys. And the question is, which of the following is not used for load balancing? And your options are Zeus, HA Proxy, Nginx, or OpenSwan. Please mention your answers in the comment section below.
Just a quick info for all of you cloud enthusiasts. If you want to make a career in AWS, then you might want to check out Intellipaat's AWS certification training course for solution architect. Learn from industry experts through hands-on session, projects, and case study. Reach us out to know more.
Previously, they had this notion of 2, but now they have 3. Why they go with at least? Now you can see they have in some there are 4, 5, 6, but you haven't seen anywhere less than 3. Now, why they go with this 3 number of AZs? There's a reason behind that. See, basically what you're going to be doing is that once you start launching your applications and deploying the infrastructure, generally what we do is that we scatter our resources distinctly in different AZs. For example, I give you one example over here. Let's take one example to understand it's in depth. So let's take one example. The example is that, for example, you have a Node.js application, a Node.js web app. There's a web application which is supported by 9 EC2 instances, right? Now, what happens is these 9 EC2 instances are scattered in such a way that this will consist of 3 instances. This is consist of 3 instances. This consists of 3 instances. Generally, we try to distribute the number of instances equally in different AZs. Okay. Why that's the case? The reason is we want to make the data and the services more redundant in nature. For example, for some reason there's an outage and A goes down. Right. Now, by the way, so from one AZ to so the median distance, the average distance between the average distance from one AZ to another AZ, the average distance between one AZ to another AZ is around 60 miles, or it's close to 100 kilometers. Okay. Now, let's suppose there's a flood or natural disaster because of which A goes down, right? Now, in this case, this means that you have lost 1/3 portion of your infrastructure, your instances. Now, you can have some automation tools available. For example, auto scaling. Auto scaling can launch 3 additional instances in, maybe it can launch 2 additional instances over here and 1 additional instance over here. We can use a term called auto scaling. Auto scaling is for automating the things. We'll discuss this thing, but I'm not going into details as of now. So auto scaling will say that, okay, I'll deploy 3 extra instances and scatter them in 2 availability zones which are available. Okay, now what if B goes down? Yeah, there's a chance B also goes down. Then in this case, you will lose these instances. Now, using auto scaling, those 5 instances can be launched over here. Fine. Now you say, okay, what if C also goes down? Now, if C also goes down, this means that the entire region is down. If the entire region is down, then you also have different procedures to switch to different region, right? You can say that, okay, for example, you can say that Mumbai is, okay, let's imagine, you can say that the traffic is coming, it's being split to Mumbai, it's being split to Singapore as well, right? Now, if just in case, if Mumbai goes down, then I can go to my traffic can be sent to Singapore as well, right? So what you're doing is that you're increasing the amount of redundancy. So we use the term like high availability, which means that your resources are more available. We make the things, for example, redundancy, which means that we create we have the backup things, we have the backup plan in place so that the data is more redundant, we don't lose the data. High availability means that an application is highly available with least amount of downtime, right? That's what we are here for. We are here to understand the tools, processes, and procedures to fail over quickly and automatically if some event occurs. It can be a man-made event, it can be a natural event, which can bring down the infrastructure. You want to minimize the downtime. First thing first, there's no notion of 0% downtime. There will be downtime in every infrastructure, right? So, but how to minimize the impact of it, that's we have to learn. How all the zones are connected, Murali Krishna is asking, using the fiber optic cables. So there's a fast 10 gigabit per second of connectivity between them. How regions are interconnected? There's no connectivity between the regions. But basically, if you want to switch between one region to another region, then you have to use internet as a backbone. So ideally, we have to unlearn a lot of on-premises jargons we used. Not necessarily, because most of the jargons we're going to be using over here, but there are a few new things that you're going to be learning. I'm pretty much sure that you will be able to grasp those concepts. Using region data centers in the world from India, or you have to use a Mumbai data center only, these two things are very much different. You can access any of the locations from your place, right? So it's not hard and fast that if you belong to, if you can, you're restricted to only one data center or one region. You can use any one of them. Okay, it all depends upon how diverse your application is. Where is your user base? For example, you're a developer in India. A US client comes to you saying that, please deploy my application, my mobile app for the users in America. So you will use one of the US regions to deploy the infrastructure. Okay, so for example, let's imagine there's a taxi service app like Uber that you have to deploy for American users, US users. Even from sitting in India, you can access US based regions and deploy a complete mobile app or infrastructure in US regions using US regions. Assume one AC is equal to one DC. Simple. One AZ is equal to one data center. It's a single facility, right? It's a single facility which consists of your racks of servers. That's it, right? We'll not use the term data center over here. So an AZ is equal to a single facility which consists of racks of servers. We cluster the facilities together in a single region. Fine. This will, because we play around with the words a lot, that confuses us. If you choose region from my location, will it lead to latency or packet data loss? It can or cannot, depending upon the user base, what's the distance, how much latency you can endure. That all depends. Simple thing, one AZ is a single facility. That facility consists of racks of servers. We cluster those different facilities in a single region. A region is nothing, it's a geographical location which consists of multiple facilities. Facilities means they're buildings, fine. Each facility consists of thousands of servers. We bind these multiple facilities together, at least 3 facilities per region. These facilities are called availability zones, which are clustered together in the same region. A region is a geographical location which consists of at least 3 facilities clustered together with high-speed fiber optic cables. Now, how accurate the failure would be, it depends upon our design. It depends upon our design. See, what the role of the architect is to create a very robust and highly available infrastructure. For example, let's suppose there are 2 architects who are constructing a building, right? The material is same. The material used in constructing a building is same, but depending upon the expertise of the architect, the experience he or she has, both architects will create different designs. Fine. It's the same thing with us as well. Amazon gives us the complete raw material, instances, all the services at our disposal. Based on our expertise, our experience, as it's a team effort, we have to create a very robust design so that it's very less likely that it will fail completely, right? We have to use different tools and strategies to make sure that even if we are diverting the traffic to other AZs or regions, then it's a very smooth transition that happens, and also the experience of your users, your customers, is not impacted. Right? For example, you're running for example a web application, a mobile app service through this infrastructure. You want to make sure that the experience of users is not impacted, right? So that's what we have to learn, how to create a very robust infrastructure using regions and the services. Next thing that we're going to be discussing would be the concept of EC2 instances. The next concept that I'm going to discuss with you is the concept of elastic compute cloud. EC2 means that it's a service which provides resizable compute capacity in the cloud. I'll elaborate every single word for you. Let's imagine this is the AWS cloud that you have. This is the AWS cloud that I've just created. Fine. This AWS cloud consists of a virtual machine. Now, what's a virtual machine? Virtual machine is nothing but it's a small machine running on a physical server only. But since we can access it virtually, we call it as a virtual machine. We call it as a virtual machine. This virtual machine is called, so in terms of AWS, this virtual machine is called an EC2 instance. Now, this EC2 instance is nothing but it's a virtual machine running in AWS cloud. It's a virtual machine which runs inside the AWS cloud, right? So the common term that we're using is virtual machine, but from the context of AWS, it's a EC2 instance, right? It's a virtual machine which runs inside the cloud. Now, this virtual machine has some compute capacity which can be resized, has some compute capacity. What do you mean by compute capacity? Compute capacity means that it will have some amount of RAM. For example, it will have, let's imagine it has 1 GB RAM. right? It has a 2.5 gigahertz of Intel Xeon processor. It has, for example, two two cores, fine, which would be, for example, virtual in nature. These are two virtual cores. It has some graphics, right? So it has some, for example, network capacity. Right. And yeah, it has some dedicated graphics. Right. So what happens is that in terms of a virtual machine has some, so it's kind of, for example, you go to the Best Buy or Chroma or any electronic store, you want to buy a laptop. What's the first thing that you see in the laptop? Physical specifications. What's the amount of RAM it has? Which processor is it using? Intel i9, i7. How many cores are there? How many graphics are there? The graphical capabilities. How fast it can communicate over the internet. So basically, you see the entire hardware infrastructure, architecture of the machine itself. Now, this complete hardware thing, in terms of an EC2 instance, is being depicted by something called instance type. Right. So what is this? Okay. So this entire thing is depicted using something called instance type. What is that? Instance type. What is instance type? It's a virtual representation of underlying physical infrastructure, or virtual representation of underlying physical resources. What's the amount of physical resources that an instance offers to you? What's the amount of CPU? It's a kind of a compute capacity, right? So so basically, instance type is equal to the compute capacity. How much RAM, CPU it can offer to you. Okay, so what is the instance type? It's the amount of compute capacity it offers to you. So instance type is equal to the compute capacity. Now, this compute capacity can be changed easily. How? I'll let you know. Fine. So we understood this thing that a virtual machine, so an EC2 instance is nothing but it's a virtual machine running inside the cloud. Fine. Now, the instance type has some examples I'll show you. If I go to, let's suppose I want to launch a virtual machine inside the cloud. What's a virtual machine? It's an EC2 instance. I click on launch instance, click on launch instance again, and you will see that there's a section which says instance type, right? For example, there's a free tier eligible instance type, which means that if you use with a free tier account, it's a free instance. T2.micro. Can you see that? Family T2, now there are different families, T2, T3, C4, C5. It gives, okay, let's go to compare instance types. If you go to compare instance types, you will see that there's special names assigned to them. You can see the definition on the top. EC2 gives you a wide selection of instance types optimized to fit different use case. Instances are virtual servers that can run applications. Now you run applications upon them. The applications that you're going to be launching would be launched upon the instances only. Now these instance types have different combinations of varying combinations of CPU, memory, storage, networking capacity, right? Of course, storage is also an important thing. I forgot to mention that. Storage is also one of the most important things to have, right? How much storage it offers to you. Fine. How much storage it offers to you. Now, for example, I was looking into T2.micro. Now there are different families, T1, T2, T3, C4, C5. You don't have to learn these things. So for example, let's take one example over here. Example is T2.micro, right? T2.micro. So T2.micro, the family is T2. Fine. And if I show you the stats, it gives me 1 GB RAM. Okay, how much RAM it gives me? It gives me, what's the amount of RAM it gives me? It is 1 gigabyte. Okay. If you see over here, it gives me a low to moderate network performance. So what's the network performance it gives me? Low to moderate, right? So I don't expect too much out of it because it will give me moderate network performance, which means that if I cluster them with other servers, how fast it can interact. Okay. I can see the hourly charges, and also it gives me 1 GB RAM, and I think it gives me 1 virtual CPU. Yeah, you can see that 1 virtual core vCPU. It's a virtual core only. So what's the amount of virtual CPU, or it's called vCPU, or amount of virtual cores it has? It is amount to 1. I think it's 1 only. Yeah, 1 virtual CPU. So in this case, this is the stats of this this instance type. Fine. Now let's imagine I want to increase the RAM. I want to switch from, for example, RAM 1 GB. I want to add on 2 GB RAM. I'm saying I need 2 GB RAM for my applications. This is the bare minimum requirement I have. In this case, what I can do is that I can change to a different instance type, which is very near to it. It's called T3.micro. Can you see that? T3.micro will give me 2 virtual CPUs. Okay, I'm sorry. I need 2 virtual CPUs, 2 virtual cores. I forgot about that. So I want to add 1 more virtual core. So my requirement is 1 more virtual. Okay, my requirement is 1 more virtual core needs to be added. In this case, I can change from T2.micro to T3.micro, which will give me more virtual cores to play with or to use. I want to increase the RAM. So to increase the RAM, I can go with, for example, if I want to 2 gigs of RAM, I can just go with T2.small. I want to go with 4 gigs of RAM, I can just choose T2.medium. So every instance type is designed for a specific hardware resources that it can give to you. For example, C1.medium, it gives me 2 virtual cores, 1.7 gigs of RAM, 350 gigs of storage. Storage type is HDD, hard disk drive. C3.4x large, it gives me 30 gigs of RAM, 16 virtual cores, 320 gigs of storage, and it's a SSD storage, which is very fast. and network performance is very, very high. So this is a very robust, yet it will be expensive. So the more resources you add, the higher you go for the instance type, the more you have to pay. Fine. Now this is basically, it can be resized. For example, today I decide to go with C3.x large, which gives me only 7.5 gigs of RAM. I want to go to up to 28 or 30, then I can just go with C3.4x large. So this means that whenever you deploy any instance, you can easily resize instance type afterwards as well. It can be changed. It can be changed. Fine. This is called resizing. It is very flexible for you. You can once you deploy a virtual machine or the instance, you can allocate, you can increase or decrease the amount of RAM allocation, virtual cores, you can change its network performance, even storage can be resized afterwards. Okay, so for example, I deployed the instance, I went with T2.micro. After few days, if I think that it's not performing as I want, I can go with T3.micro. Maybe I can increase to a very high instance type, which is C4.2x large, which gives me more amount of RAM or storage. Or I can downsize as well. I can go the other way around as well. So I can increase or decrease the amount of resources that the instance offers to me by changing the instance type. What's instance type? Instance type equates to the compute capacity that the instance offers to you. It's the amount of physical resources that instance offers to you. The amount of RAM, CPU, storage, graphics, networking capacity that the instance offers to you. What's instance? It's a virtual machine. You can resize it. You can upsize or downsize it. You can upgrade or downgrade it anytime you want. Okay. So for example, today I launch an instance. I go ahead and launch a virtual machine. Fine. So I say this is a virtual machine which is T3.micro, right? After a few days, I want to have a big virtual server with more amount of RAM, more amount of CPU. So I can go with, for example, C5.4x large. I can upgrade it if I want. And if I want, I can downgrade as well. So this can be resized. This can be resized. This resizing thing is called resizable compute capacity. The compute capacity can be easily upgraded or downgraded. There will be certain downtime because you have to shut down the instance for some time. But what I'm saying is that this is very flexible to use. Very flexible to use. Fine. That's the concept of EC2. EC2 and the instance type. Now, any questions or doubts you have, just let me know. I'll just pause for a few seconds. If you have any questions, just do let me know. The next thing I'm going to discuss with you is the AMI, the Amazon Machine Image, for fast storage. So if you're looking for the fast storage, then sure, you'll go with the SSD storage. Going for a fast storage, you have to go with SSD storage. Network performance is when you have to cluster the instances together, and the instances need to communicate very fast with other instances. For example, you have deployed a very high-end application. You have create a cluster, like you want to create, for example, SAP HANA type of application, right? You want to create a cluster of instances. There has to be 10 gigabit per second of communication going between the instances. Then you have to go with the high network performance. For fast storage use, you have to go with SSD. No, you don't have to install the apps again, Murali Krishna, if you change the instance types. If you change the instance types, you don't have to change the apps again. We're not changing the virtual machine. The machine is same. It's only that we are changing its physical resources. So what we have discussed, that we have a virtual machine running inside the cloud. That virtual machine is called an EC2 instance, which has some compute capacity. And then that compute capacity is equal to instance type, which can be resized. The next thing that I'm talking about, we discussed the hardware specification of the instance that's been depicted by the term EC2 instance. Now, what about the concept of, or what about the operating system part, the software part? See, every server that needs to be deployed requires an operating system, right? No server can run without an operating system if you want to manage application services. So the operating system can be of Linux, right? It can be a Linux operating system. It can be Mac OS. It can be Windows. Every server requires, every machine requires an operating system to operate. Plus, upon the operating system, you'll be launching some applications upon your servers. Plus, there will be some scripts that will be launching upon the servers and services, etc., etc. This bundle of this software configuration, the OS, application services, scripts, form the software part, which is being labeled by this term called Amazon Machine Image. In the short form, it's labeled as AMI. What's an AMI? It's nothing but it's a pre-configured template which consists of all these software components. What's the operating system you're running? Is it Linux? In Linux, for example, we have Ubuntu, Debian, we have Red Hat, Mac OS, Monterey, Big Sur, Windows Server 2019, 2016, 2022, apps and services, scripts running upon them. For example, I'll give you one example. Let's imagine the Ubuntu 22.04. This is the operating system, the OS, right? This is the base operating system. Plus, you have installed upon it. Let's pick, for example, Apache PHP package upon it. Let's imagine you have launched upon it, for example, WordPress service, WordPress version 5.1.1, right? And you're running MySQL version 5.33, right? You bundle it together, right? And it can be your customized image or customized AMI. You can customize it if you want. Fine. So I've given one example. Ubuntu 22.04 is a base operating system, Apache PHP web application, proxy server, WordPress 5.1.1, and MySQL database. Fine. So this becomes the software part of your server, your instance. Hardware part becomes is being depicted by the term instance type. The software part is being represented by the term that's called the Amazon Machine Image. Fine. Okay, I'll show you this thing. If you log into the AWS Admin Console, let me show you this thing. You will see this thing that over here on the, once I go to this launch an instance page, you will see that it says application and OS images, Amazon Machine Image. An AMI is a template that contains a software configuration, which includes the operating system, application server, and applications which are required to launch your instance. These are needed to launch your instance. Okay. So we get a catalog to choose from. So for example, if I show you this thing, I can choose the Amazon Linux AMI, Mac OS, Monterey, Ubuntu 22.04, Windows Server 2022 base, Red Hat, Enterprise Linux, Debian, for example, Debian 11. This is one of the Linux distributions. If I click on this magnifying glass which says browse more AMIs, if I just go over there, let me show you this thing. You're going to be seeing this thing, is that I can see more AMIs over here. Basically, they have put the AMIs into 4 different categories. One is quick start. Quick start, there are 46 AMIs. These are the AMIs which are being used the most by the customers. We are the customers only, right? We are using AWS as a cloud vendor. So quick start AMIs are the AMIs which we use, which the customers use the most, right? You can see that it's macOS Monterey, macOS Pixar, Amazon Linux, Red Hat Enterprise Linux, Catalina, macOS, Ubuntu Server, Microsoft Windows Server, right? Different AMIs for different use cases. And you will see that some are labeled as free tier eligible. This means that you have signed up for a free tier account. In a free tier account, we can use it for free of cost without paying any charges. Fine. So these are quick start AMIs. On the right hand side, it says my AMIs. Can you see that? It's being it's blank as of now. I'll show you the process how you can create a new AMI for yourself, which can be customized based on your business needs. Then we have the marketplace AMIs. Okay, quick start AMIs are the very commonly used AMIs. My AMIs are the one that you can customize by yourself. Marketplace AMIs are most of those AMIs which you have to buy from software vendors like Microsoft, SAP, Xent, Cisco, Juniper, Palo Alto. For example, I want to deploy. Okay, let's go with OpenVPN. OpenVPN basically I want to get the enterprise VPN running in the cloud service, right? So I can just go to OpenVPN access server, and you can see that delivery method Amazon machine image. What's the base operating system? Ubuntu 18. Okay, so OpenVPN access server is delivered to me in the form of AMI special package, which is running OpenVPN access server services on Ubuntu 18. And this is the cost I have to pay. These many cents I have to pay on the hourly basis. Okay, and it says total pricing per instance hosted on a T2.small in usage one. So basically the pricing depends upon that you can also bring your own license, right? And it says T2.small is vendor recommended, and if you go for a high instance type, then you have to pay more charges. So most of these AMIs are paid, which means that you buy from software vendors. Let's go with, for example, let's go with this one. Palo Alto VM Series Next Generation Firewall Bundle 2, right? I want to deploy a Palo Alto firewall, and the delivery method is Amazon machine image. Fine, and it uses its own, I think, base operating system, and this is the cost per hour. Fine, I can just go with the product details, and I can deploy a next generation firewall inside AWS, which is the VM Series Next Generation Firewall Bundle 2 by Palo Alto. So I can deploy a Palo Alto firewall inside AWS by using this marketplace AMIs. Fine. Community AMIs are the one which can publish by anyone. It's a community effort. It's a developer community. You can create and share your AMIs free of cost. Most of them are free. These are used for testing purpose, for research purpose. I don't think you're going to be using community AMIs in a business environment. For testing, for lab research, you can use that. But community AMIs are maintained by developer community. You can publish your AMIs over here in the community forum. You can see that anyone can publish an AMI and it will show in this catalog. So you're going to be using the first 3 categories in your business production environment: quick start, my AMIs, and marketplace. Fine. So an Amazon machine image is nothing but it's a mix and match of different a mix and match of the operating system plus application services bundled together in a software package. Fine. That software package will be installed upon the virtual machine or the instance. Fine. So this forms the software part of your virtual machine, which is nothing but it's the Amazon machine image. So we discussed three main concepts. What's an EC2 instance? What is an Amazon machine image? And what is the instance type? That what we have discussed as of now. And what is the global infrastructure? The instance type forms it gives the representation of the physical resources the instance offers to you. And the Amazon machine image offers you the type of software installed upon the virtual machine. That's the overview of these things. What's your business requirement? What type of services you're going to be deploying? Depending upon that, you choose instance. Depending upon that, you're going to be choosing the instance. What's the amount of traffic it will be processing? Some applications run on 64 ARM architecture, some run on x86 architecture. So depending upon the applications, they run on different types of architectures. So this is how your system is designed. What are its every server is designed based on a specific architecture. The next thing that I'm going to discuss with you is the security part. I'll discuss the security afterwards. Let's discuss the tagging first, because tagging has to be discussed. The next thing that we're going to be discussing is tagging. Super important. Tagging means labeling the instance. Labeling the instances. For example, I want to launch an instance. Fine. There's an option which says name and tags. I name it as, for example, okay, let's suppose I name it as WordPress server. WordPress server. Okay. Why I'm labeling it? What's the purpose? I can add additional labels. For example, I add a tag. A tag has two components: key. I can type in key as, for example, name, and a key has a value. For example, value can be, this can be, let's suppose I can say demo instance. Demo, hang on one second over here. Demo instance, something like that. I can add multiple tags. So the question comes in, why this is done? Okay, why do that? So tagging means labeling the instance. Okay, I'll discuss with you. If you tag the instance, it has key and a value. Okay, key and a value. What's the purpose behind that? I'll let you know. So you have the tag. It has two things. It has key and it has value. Right? What's the difference? Key means that basically let's suppose you assign the key as name, and the value is, for example, WordPress server. Right? So for every key there's a value. So this is a kind of a labeling that you do that towards the instance. So you assign a key is most probably it's name only, name, and the value is WordPress server. Okay, now why we tag the instance? First thing first, tagging has multiple benefits. It helps you in recognizing the resources, recognizing the instances. For example, I have a bunch of 100 instances running in a dashboard. If I tag them, if I label them, I can easily recognize them. Fine. So for example, let's imagine I go ahead and let's do one thing. Let me just deploy 2 instances. I'll show you this thing, what exactly I'm talking about. And Tagging means labeling the instances. Tag has two things: key and the value. The benefits are, what are the benefits? Okay, I'll just put that over here. The benefits of the tagging is are, what are the benefits of tagging? What are the functions of the tagging? First is that you can easily recognize and group similar instances. Okay, what do you mean by that? For example, I just deployed 2 instances in front of you. Fine. Now you will see that I have you can see on my dashboard, you can see a list of 4 servers, 4 instances. One is labeled as Node.js web app server. 2 are labeled as WordPress server, and the 4th one is labeled as my first demo web server, right? So let's suppose I have a bunch of 100 instances running. Right now you can see 4 in the list. If I have 100 instances running in this list? How can I recognize which instance is what? A very layman example. Tagging is labeling the instances, naming them. I can say that, okay, these second and third servers, they belong to the same class WordPress server. So it's an ease of recognition. You recognize them, you filter them. Okay, it's a good thing to label the things because it is easy to manage them properly. If you label the things, you can easily recognize them and manage them. Make sense? What's the next benefit? Next benefit is that it helps in automation. Now, automation we'll discuss afterwards, but why how automation makes sense in this case? Let's imagine these are 2 WordPress servers. Let's imagine I have 4 WordPress servers. Let me change them. Let me change the label. I have 4 WordPress servers. Now I want to update them. I want to update the software upon them. What do you mean by that? For example, I give you one example over here, and I'll show you afterwards once we go advanced into the steps. For example, I have 4 EC2 instances right with the same tag. What's a tag? In this case, WordPress server. Okay, now all these 4 instances are running WordPress version 5.1.1. They're running WordPress version. Okay, so let's suppose they're running WordPress version 5.1.1. I want to upgrade it. I want to upgrade it. Upgrade to 6.0. Okay. So what I do is there are 2 approaches. I go instance by instance and upgrade the software, or what I would do is that I'll map the upgrade to the tag. I'll point the upgradation process to the tag of the instances. So all the instances under the same tag will be upgraded automatically. I'll push the update based on the tag. All the instances with the same tag will be updated. This will make the process much faster. There are 2 approaches. I can manually say I go instance by instance, right, and upgrade the software from 5.1 to 6.0, or I can send the upgrade to the tag. So basically in this case, every instance with the same tag will be upgraded. So in terms of automation, if I have 4 servers with this 4 servers running with the same tag, if I push an update, all the servers with the same tag will be updated. It will, I would say, it will reinstall the software update upon it, but it will not do any harm. If you reinstall the update upon it, but it will not do any harm. Maybe it will not do anything, but it will not impact its performance. Okay. So in terms of automation, that's how the tagging is important. Fine. What's next? The next thing that you have to understand is that it also helps in extracting billing reports, or I would say generating billing reports. Generating billing reports. Let's suppose your manager says, I want you to let me know that what's the collective amount I have to pay for the WordPress servers. So you say that you generate the report. So you run a you generate the report against the tag, right? For example, the tag is the same thing. For example, the tag is Node.js app, which consists of, let's suppose, 40 instances, right? So you get the collective billing report of all the 40 instances in one single spreadsheet. Right now, we're just discussing the theory. We'll do the hands-on of this afterwards. So what are the benefits of tagging? You name the things, easily recognize them, you group the instances together. It helps you to automate the things, and also you can generate some billing reports. So you can, based on the tag, you can extract the billing reports, and you can see that under that same tag, what are the number of instances, what's the collective expenses you have to pay on monthly basis for those group of instances which have the same tag. Fine. These are the three main benefits of tagging the servers. Fine. In your business environment, you tag the servers for this reason. For example, the amount of RAM, the kind of processor, the amount of cores, the network capacity, the graphics, storage that a virtual machine or the instance offers to you, right? Which it will give you. Now, why it is important? Because based on your business applications that you'll be running upon the instance, you need to decide that what's the best hardware capacity suitable to you. I'll give you a very layman example. Let's imagine you enjoy playing games on computers, right? And very high-end games. So you will use a very high-end laptop which has dedicated graphics into that. Or for example, you store a lot of data on the hard disk. So you'll buy a laptop or a desktop which has a very at least 1 terabyte of storage. You want to run a lot of processes upon the laptop or the desktop. So you run a lot of applications simultaneously on the same computer. So in that case, you need a more amount of RAM. Okay. So the thing is that based on your use case, you carefully choose which machine is best for you. Similarly, based on the simple business use case, you choose which instance type is best for you. Okay. What's instance type? It's a virtual representation of the underlying physical resources. It equates to the compute capacity. Now, this can be resized. So I showed you yesterday that there was a whole list that I showed you. It's very flexible. You can change the instance type of so that's why it's called resizable compute capacity. For example, there is an instance type which is labeled as this T2.micro, right? Which gives you one, so it belongs to the T2 family, 1 GB RAM, low to moderate network performance, and one virtual CPU, one virtual core. Now you want to have one more virtual core. In that case, you go with the T3.micro. You can, so basically you can change the instance type, you can upgrade or downgrade. This concept is called the resizable. The compute capacity can be easily resized on the fly. Of course, there will be certain downtime if you shut down the server, but this is very flexible to use. Fine. So it gives you resizable compute capacity in the cloud. Now, the next question that comes in that what about the software? Because a machine has two main components, hardware and software. We already discussed hardware. What about the software? The software includes the operating system of a machine. Very obvious. You have to install the OS upon it, plus the application services and scripts. Now, this entire software unit is bundled in a capsule, or it's in a single unit. That's called the Amazon Machine Image. It's a pre-configured template. For example, we discussed Ubuntu 22.04 is the base operating system, Apache PHP proxy server, web server, WordPress 5.1.1, MySQL 5.3.3, right? So this is a complete package that we put in the form of a custom image or a custom Amazon Machine Image, right? That's what we have discussed. Then also we discussed that tagging is super important because first thing first, it helps us to easily recognize and group the similar instances together. We can also push the automatic updates to multiple instances at the same time based on the tag. And also it helps us to generate the billing reports. So I give you the example that, for example, I have a few instances with the same tag, right? So I can push the update to the tag, and all the 4 instances or 40 instances or 400 instances with the same tag will be updated. Fine. So these are the 3 main benefits of the tagging that we have discussed. There are 2 approaches. Either you manually go instance by instance, log into it, and install the update, which takes a lot of time. The other approach is that if all the instances are tagged together with the same tag, same name, you point the update to the same tag, and all the instances, the 400 instances with the same tag, would get updated with the same update, same software patch or upgradation, I would say that. Fine. So in this case, it becomes easy for you to push some new updates or get some backups from the instances. It becomes easier for you to do that. It brings down the time and effort in that case. The next thing that we shall be discussing would be the concept of security groups. Super important thing to understand. There's a concept called ports and protocols. There's a concept that's called ports and protocols. What is that? The network communication that happens between the servers, computers. Basically, the thing is that in this case, there's a big role that's being played by ports and protocols. Right? There's a huge, tremendous.
Let's have a quick quiz question, guys. And the question is, which of the following is a web service that manages memory cache in the cloud? And your options are Amazon Elastic Cache, Amazon RDS, RDMS on EC2, or auto scaling. Please mention your answers in the comment section below.
Just a quick info for all of you cloud enthusiasts. If you want to make a career in AWS, then you might want to check out Intellipaat's AWS Certification Training Course for Solution Architect. Learn from industry experts through hands-on session, projects, and case study. Reach us out to know more.
Usage of the ports and protocols being used. So it's a part of networking generally. What happens is that we use protocols, for example, HTTP, Hypertext Transfer Protocol, HTTPS, which is the secure version of HTTP, SMTP, Simple Mail Transfer Protocol, fine, FTP, File Transfer Protocol, SSH, Secure Shell. So what happens is, at the back end, if you want to communicate with any server or servers need to communicate, the protocols need to be required at the back end. For example, when you use any access any website, what protocol we use? HTTP or HTTPS, right? Now, each of these protocols. I'm sorry. So we use HTTP and HTTPS protocols to access the website. Now, each of these protocols use ports. They have some specific dedicated port numbers for them to operate. Okay, they have the dedicated port numbers to operate on. You can see that. I'll give you the list of these side. So what's a port? It's a virtual point where the network connections start and end. They're software based, they're virtual in nature, managed by computer's operating system. Each port is associated with a specific process or a service. So it's a virtual point where the network connections will either start or end. They're software based. So fine, that they are software based, and ports allows a computer to easily differentiate between the different kinds of traffic. Traffic means it's a communication that's happening between user to server, server to server, computer to computer, and so forth. Now, if I use the term computer, I'm also using the this means I'm talking about the server. Servers are computers only. Fine. Now let's imagine. Okay, so basically what happens is there are a variety of uh, protocol and ports we use in the for the computers to operate. But the ports and protocols that I'm talking about are the ones that we're going to be using the most. So for example, let me just static in nature. Most of the ports are static in nature, which means that they're constant for every traffic. So ports and protocols, or protocols and ports, right? So we use different protocols for communication. There are a lot of them, right? There are hundreds of them, but I'll list down 5 or 10 maximum that we're going to be using, right? For example, we have a protocol which is HTTP, Hypertext Transfer Protocol, which uses port 80, right? We have HTTPS. It's a secure version of HTTP, which uses port 443. Now they're already predefined, and we have been using them from past many decades, right? So it's not that it's a special thing that AWS has designed or invented. It's been there for many decades, right? HTTP uses port 80, HTTPS uses 443. There is a protocol which is called secure shell, right? Short form is SSH. Now this is used to connect to remote. Okay, let's do one thing. I'm not okay. So this is okay. I'll just list down the benefits. This is used for accessing the websites. Fine. These protocols and ports are used to access the websites, web applications or APIs. Then we have, for example, the secure shell I was talking about. Secure shell, the short form of which is SSH. It uses port number 22. Now this is used to connect to remote. Remote means it's not local, it's running somewhere else. Linux server, right? Secure shell is used to connect to the remote Linux servers. Then we have, for example, remote desktop protocol, RDP. Remote desktop protocol. In the short form, it's called as RDP, right? Now, this one is used, this one is used to connect to the remote Windows servers. Which servers? Windows servers. If you are connecting to the a Windows server remotely, then you're going to be using RDP, Remote Desktop Protocol. Now it uses port number 3389, right? Let's take two more examples. One is MySQL, right? It uses port 3306. This is to access the MySQL database server. Fine. I'll give you, so this is the MySQL. We can have some more examples, but I think these are the most common that we're going to be using. HTTP, HTTPS, SSH, RDP, then MySQL. The next one is DNS. It uses port 53. Fine. This is used where? This is used for DNS servers, for DNS communication, or I would say mapping, or this is used for DNS servers. DNS means domain name service. This is used to link or map domain names to the IP addresses. What do you mean by that? For example, if you type in facebook.com, at a backend, it gets converted to an IP address of the Facebook server. Fine. So these are the commonly used protocols that we're going to be using, protocols and ports. So these port numbers are static. You can also use your own custom, but not for these protocols. So in order for the machines to communicate with each other, you want to communicate with the machine. These are the protocols and ports we use to communicate at the backend. Why did I discuss this basic concept with you? Even though I was not supposed to discuss that, but why did I discuss it? Because this is not a very special thing about AWS. I discussed it because for one reason. The reason is, let's suppose this is the AWS cloud. So let's imagine this is the AWS cloud you have, right? And this is an EC2 instance. Right? Now, depending upon the type of application and services and the operating system this is running, it will receive the traffic from outside. From the instance perspective, this is the inbound or incoming traffic. Traffic means it's a communication, inbound or incoming. And any traffic or communication that's initiated by the instance, it is outbound or it's outgoing. Now, why am I discussing this thing? Because you are concerned about the safety of the instance. We want to restrict the incoming and the outgoing traffic using a firewall. Firewall is a networking component. It's a component which is used to perform restrictions based on some filters. Filters means, for example, I want to restrict. Filter means that how am I going to restrict the traffic? What's the way around? Filters include, the first one is the protocols. I can restrict which protocols I want to allow or deny incoming and outgoing. I want to restrict ports. Fine. I want to restrict the IP addresses. IP addresses are used for network communication because it gives the identification to your computer or a server. So I want to restrict the incoming and the outgoing traffic based on the protocols, ports, and IP addresses, right? This will enhance the security of my instance the data it is storing, right? So for example, you're going to a banking website, right? Would you go and do some transactions if you find that that banking website is not safe or secure? The answer is no. We make a lot of transactions using Paytm, UPI applications, because we feel them safe, because we know that they have all the security encryption mechanisms at place. So our transactions will not be tampered with, or our account information would not be stolen. So if we have full faith on banking websites, UPI based applications, service providers, we know that they have all the mechanisms to make our data safe, to make our transactions safe and money safe. Now, where those applications are running upon the servers only. What's an instance? It's a server. When you go to a banking website and you do a transaction, at the back end, a server is operating. That website is running where? Upon a server only. Okay. So it is important that you perform very strict restrictions incoming and outgoing towards that server. You can't allow every traffic to hit from anywhere. There are few things that need to be blacklisted, few things that need to be whitelisted. So we'll discuss that concept. Fine. So in this case, we use the concept that's called, there's a virtual firewall that we use in this case. Virtual means because we can't see that. And firewall is a very old concept, but in this case, we're using virtual firewall because we can't see it physically. It's called security group. Okay. So I'll give you one example to understand the entire scenario. Now, in this case, let's take a scenario. Let me just help you to understand that how you can perform restriction based on the ports and protocols and IP addresses. Let's take a scenario. The scenario is very simple. Let me just try to list down the scenario for you. The scenario is, and this will help you to understand the concept. What is the scenario? The scenario is plain and simple, that this is the AWS cloud that you have. Fine. This is the AWS cloud that you have. Fine. And inside this AWS cloud, this is an EC2 instance. Now, let's suppose this EC2 instance is running. This is a Linux instance with a Python web app running upon it. There's a website running upon it. Right? There's a website running upon it. It's a Linux server with a web application running upon it. Fine. For example, this web application has this address xyz.com. This is linked to your website. Okay. Now you have two set of users who will be accessing these servers. Who are those users? The first set of users would be the internet users, your own customers. These internet users will be sending the HTTP and HTTPS requests to the server to access the website. I'll come to that. The other group of people who will be accessing the server would be the administrators in your organization. So for example, on the right hand side, now I'm very bad in drawing the thing, so please bear with me. What I was saying is, for example, this is your branch office or corporate office or branch office, whatever you want to say. This is your corporate environment. Fine. inside this this branch office or this office, you have a bunch of system administrators. The purpose is that they want to access your website. They want to access the website. That's the purpose of the internet users. What's the purpose of the administrators? They will be doing the server management, right, which includes administration, which includes installation of the software or installation of the patches, upgradation and configuration, etc., etc. So these people would be, they have a different purpose, right? There are two set of people, one on the internet, other one sitting in the corporate office. They have their own purpose to connect to the instance. Fine. Now, this means that these people need the server access. They need to get to the core server access. They need to have to get the core server access. They need that. Because they need the core server access, they'll be sending a different type of traffic to the instance. Okay. So how you differentiate the traffic now? The internet users, because they have to reach your website, they'll be sending either of these two types of traffic. Either they will be sending HTTP traffic, which uses which port number? 80. Either they will be sending the HTTP traffic, which uses port number 80. Fine. Or else they will be sending the HTTPS traffic, which uses port 443. Makes sense? Today you go and access the Intellipaat's website. What protocol are you going to be using? Either of these two? Fine. But that Intellipaat website is running on a server. Who will get the server access? The administrators. Because this is a Linux server. This is a Linux server. Okay, one thing I want to tell you. Once you define the protocols and ports, then you have to define that this should be allowed from which IP. What's the IP address? What should be the source IP? From where the traffic should be generated? What should be the source IP? Source IP would be this one, 0.0.0.0/0. Right? If I use a term 0.0.0.0/0, this means that this is any IP on the internet. Any user on the internet can access my website. If you go to Intellipaat website, anyone can access it. You're not being blocked. Fine. So we are saying that allow these protocols from any IP. It doesn't matter. Any person who has access to the internet should be able to access my website using HTTP and HTTPS protocols. Fine. All right. But what about these system administrators? Because they want to get to the server of your instance, server management. They'll be sending the SSH traffic because it's a Linux server, which uses port 22. Now, why we use SSH? SSH is used to connect to the remote Linux servers. Okay, it's an industry standard protocol. It's a remote Linux server, so they'll be using the SSH port number, SSH protocol, which uses port 22 to access the server. so that they can perform server management, administration, installation. They will get to the core of the server. And what's the source IP? From where they will be sending this traffic? What should be the source IP? The source IP should be the one. What should be the source IP? Source IP should be the one which is your corporate network IP address. So for example, it is 13.72.1.0/24. This is your corporate network IP address. Okay, every network, so your company has a bunch of machines, and so they lease some public IPs from the service provider. So an office, a group of network is dedicated a specific IP address range. Fine. So we are saying that the SSH is allowed from only this IP address, which means that no other IP address which is not falling in this range can access the server using SSH. So only my administrator sitting in my office can gain access to the instance via SSH, being the part of my corporate network. They can easily access my instance via SSH and perform the server management. Fine. This is how you need to differentiate between the different types of people accessing your server. So only the people in your office will be able to get to the root or core of the server using SSH protocol, which uses port 22. Fine. Now again, I just give the layman example. We access Intellipaat site, right? So I'm an internet user. So I'm saying any user on the internet, that's why I use this IP address, can access the website. But can we access the server upon which this website is running? No. We can't access the server, the backend server. Who gains access to it? The IT or software people, the people in the Intellipaat's IT team. The people in the internal, they are the Intellipaat employees, maybe on the contract, but they are the IT people. They have got the server access, not us. We can only see the front end, but the backend access is given to whom? To the system administrators. You can't give this IP address to everywhere. Okay, so in this case, this is what you have to understand, that for security reasons, these two protocols, this is a very, very important thing. This is super important from the business perspective. Two protocols, SSH, this is for accessing the remote Linux servers, and Windows. For Windows we use RDP. I'm sorry. For Windows we use RDP. Linux and RDP for Windows. This is super important for you to understand that these two protocols should not be allowed from 0.0.0.0/0, because this means from anywhere. Fine. These two protocols they give the server access. You should not allow these two protocols from anywhere. especially these two protocols. Because if you do that, then this is a security breach. Any person will somehow try to get access to your server, which it's not a good thing to have, right? So this is what the concept of security group is. What is this? It's a virtual firewall, which ensures that you can perform restriction incoming and outgoing both, right? For example, you can say that the server can send back this traffic back to the a user, right? I can say that it can send back HTTP response back to the user. So that's the outgoing, or HTTPS. Whatever I want to say is that this is super important for you to understand that you have to perform restriction using these firewalls. There's an advanced firewall which is called the access control list. We're going to discuss it afterward. That's the concept of the security group is. This is what the concept is. Now I'll do one thing. I'll show you the configuration of the security group. I'll show you this thing. Just allow me a few seconds over here. I'll just show you the configuration. I just got to the this website, AWS website, the management console. I go to the EC2. Now on the EC2 dashboard, you can locate security groups. Now there are two ways to locate any service. There's a search menu on the top. There's a search menu that you can see on the top. You can just type in, for example, security group. Security group. I don't think it will show up because it's a service within EC2 only. Yeah, basically because security group is a part of EC2 service. You can see that it's a feature. You can just click on the feature right now, and then it will take you to the security groups dashboard, right? Or the other way around is that you can just go. You can just click on EC2, right? You click on EC2. On the left hand side, there are a bunch of options. We can slide up and down. On the left hand side, you can see that we have network and security groups, elastic IPs, placement groups. If I go to security groups, right, these are the bunch of security groups I have. Okay, let me just switch to a different region because I have hundreds of security groups over here. So I want to make sure that I can show you from scratch. So for example, I switch to a different region and I have a default security group. Now, generally, we don't go with the default security groups. We can create our own custom one. Okay. So what I do next is that I click on create security group right away. And you can easily see a definition on the top. A security group acts as a virtual firewall for your instance. And that's being meant to control the inbound and the outbound traffic. So the purpose of this virtual firewall is that it performs the restrictions to the incoming traffic or the outgoing traffic with respect to the instance. Okay. The very first thing is that you have to assign a name to the security group. You can just put in any name over here. For example, let's name it as my first security group. It's a simple name that you want to assign to it, right? Then you put a description just for the documentation purpose. So this will be my first security group. That's it, to be configured. You can put anything over here just for the documentation purpose. Once you put the description, the name, VPC will discuss afterwards. We don't change this value. These are two things that you have: inbound and outbound. Inbound means what traffic can hit the instance. Outbound rules means what traffic can leave the instance. As if now the inbound says this security group has no inbound rules. So I click on add rule, right? In the add rule section, I can see there are different types of protocols on the left hand side. You can see that. Protocol type. These are different protocols. For example, I choose HTTP. HTTP is a TCP type protocol. There are two types of protocols: TCP, UDP. We don't have to get into details. It's a port. It uses port 80. HTTP uses port 80. Okay. For example, I use HTTPS, it uses port 443. I use RDP, it uses port 3389. I choose SSH, it uses port 22. Right, so basically it can use any of the port. These are static ports. We don't change them. If you want to have your own custom port, then you can choose custom TCP and you can define that port number over here. Now, for example, I choose HTTP, which uses port 80, and now it was asked me for the source IP, right? I can choose anywhere IPv4, anywhere IPv6. Now, if I choose anywhere, generally we choose anywhere IPv4. This is the IP address it shows over here. So I can put a description. This will allow HTTP traffic from the internet, right? So it will allow the free access, HTTP access from the internet users. Then I can choose HTTPS, right? I can choose anywhere IPv4. So I can say that this will allow the HTTPS traffic from the internet users. Fine. But what about the SSH access? Maybe this will be sent to my Linux server. So I choose SSH. Now SSH, if I by mistake choose from any IP, then from production purpose, this is not a good thing to do. So I should choose either my IP. My IP is this computer's IP I'm working on, upon which my AWS management console is running, right? My AWS management console is running on a computer, iMac. This is the IP address of it. This means that from this computer, I can connect to my remote Linux instance. No other IP or no other computer can do that. Or I can choose custom IP, and I can choose, for example, 13.45.0.0/24. So this is restricted SSH access from my corporate network. So I've restricted access to only a bunch of IPs. Fine. Okay. Outbound generally we don't change it because outbound generally don't post any thread. Outbound says all traffic, all protocols, all port ranges, all the destinations, which means that free outbound access, free, or I would say, I'll use the word unrestricted outbound access, right? You can also use the same protocols if you want, okay? But generally we don't restrict the outbound traffic, but if you want, you can also do that. You can choose the same protocols and ports in the outbound, right? This is how you create and configure a security group. You can do that. Now I can add a tag to it over here. For example, tag, we are understood the tag, right? So I just copy and paste the same security group name, and that's it. Fine. I click on create. Create it. This is what it needs to be done. Fine. This is created, and I can see over here. The next thing is that DHCP. So in this case, you're saying that my computer, because of the dynamic nature, my computer will get a different IP. But in a corporate network, right? Whether using DHCP server, the range is same, right? Your computer may get a different IP. So you're sitting in a branch office. You're sitting in a branch office. What my understanding says that if you remain in the same network, right? If you remain in the same network, no matter what's basically the thing is that sitting in the branch office, or the corporate office, whether you're using DHCP or not. Let's suppose you're using DHCP. Randomly, your laptop picks any IP address range in the corporate environment, but it would be in this range only, not outside that. Think from the business perspective. You're sitting in an office environment. You plug in your laptop wirelessly or using a Ethernet connection, but it will fetch an IP address. A DHCP server will give the IP address from this range only. Fine, the range will be the same, whatever IP you get. Okay, it will pick from this range because, for example, this consists of more than 200 IPs. Fine, so it will give any range of I'm sorry, yeah, so it will give any range. It will just allocate any range to your computer, and if the IP address range is within the same limits, then your computer can access the server or the instance via SSH. Fine. So there's no provisioning of the MAC addresses allocation as such. Fine, because that will be too much complicated. As of now, there's no such provision. The next thing that I'm going to discuss with you is the concept that's called the authentication. Authentication is done using a concept called key pairs. What are the key pairs? What do you understand by that? Key pairs is nothing but it's the key pairs are used. Basically, the purpose of the key pair is, so key pairs are used as a method of authentication. It's a default method. What do you mean by authentication? Authentication means when you log into your smartphones, your computers, use a user ID and password, right? By default, we don't use that. We use the same kind of mechanism, but in a different way. Okay, you might have visited, or might have. Now, I don't personally access the lockers in bank premises. Lockers generally. In banks, we have a huge room with a lot of lockers inside that. We use lockers to put our jewelry, our valuables into that. Okay. Why I'm using the term lockers over here? Why the locker analogy is coming into this picture? When you go to access your locker in the bank, the process is that you go to the bank. Now, I personally I don't use locker. My wife or my parents do that, but I've seen this when I was kind of maybe 10 or 12 years old when I used to go to my parents to the bank. So you go to the locker room with a bank official. The bank official will escort you to the locker room, and the bank official will have his own key, right? He uses the key to open the locker. Then you have your own key, and you use your own key to finally open the locker. So there are two keys are needed. One is with the bank official, and the other one is with you, right? So if the two locks are if you're able to open both the locks, then you can easily open the locker. So the locker has two locks. One key of which is with the bank official. The second lock key is with the customer, right? This enhances the security. The same concept applies over here. You have an instance running which will generate two keys. One key is with the AWS, other key is with the customer. The same mechanism. Fine. Even though it's not the locker that we're accessing. So for example, this is an EC2 instance. Right. Now this instance will have a public AMI. Now public key, which is embedded into the AMI of the instance. Okay, it is there in the AMI of the instance. You can't see that, but it's there in the thing in the AMI. Then you are the system administrator, right? You have the private key with you, right? Which is saved on your computer, which is saved on your local computer. Okay. Now, when you want to SSH, so you want to initiate the SSH or RDP connectivity. You want to connect to the server, right? You want to connect via SSH or RDP. What you do is that you upload your private key, right? Now, if this private key matches with the public key, then you're able to safely authenticate and connect. The same mechanism. One key is in the instance, other key is with you. You provide the key, the private key. If it matches the public key, you're able to authenticate and safely connect to the instance. Fine. Now, this is saved on a computer. This comes in two types of, there are two file extensions we have. File extensions means the format. For example, we have .doc, .pdf, .xls. Similarly, we have .pem, and .ppk. .ppk is used if you're using a Windows local computer to connect. Generally, right? And if you're using Mac OS or a Linux computer, then you're going to be using PEM. It depends upon the software that you're using to connect to the instance. So it comes in two file extensions, PEM and PPK. You provide this key at the time of gaining connection to the instance. If the key is accepted, you're able to unlock the instance and get into that and perform the server management. Fine. This concept is called public private key cryptography. Even in the banking transactions you do online, this is used at the back end. Fine. Having said that, this ends the theory as of now for the EC2. I'll discuss more theory with you, but at this stage, this is more than sufficient as of now. Fine, we'll discuss more things going forward, but I want to make sure that we can discuss some basics first, and then we can just take it forward afterwards. Some more discussion in depth. Fine. So what we can do is we can take a 10-minute break. Once we after we come back from the break, then we'll start with the hands-on. It's already 8:11 a.m. Let's get started with the hands-on. What needs to be done is there's a folder that's called EC2, and under EC2 there's a PDF which is getting started with Amazon EC2 Linux instances. You have to download I would say you can download all the 3 documents if you can. And also I'm going to drag and drop these 3 documents in just type it down. Once you have done these 3 things. Now, once you have downloaded all the 3 documents and accessed your dashboard, you have to gradually move to the, just give me a second over here. Okay, so you have to go to your this, open the PDF. Okay, now this is the PDF that we'll be using as a reference manual document to perform the hands-on right away. Now, what's the purpose of this document? The purpose of this document is that we start with the process of launching the instance now. Fine, we'll be launching a very basic Linux instance, very basic Linux instance with a simple web application launched upon it. Having said that, let's start with the first few steps. I'll show you the first few steps. And now once I just go to the this AWS Maven console, I go to the EC2, right? Now the thing is, once I just land to the EC2 dashboard, the next thing that it shows me is the complete instance EC2 dashboard, for where I can access a lot of things at the same time. Now, the most important thing that you have to focus on is the region. What happens is that when you deploy something inside a region, it is contained in that region only, which means that, for example, I deploy my instance in Frankfurt, it remains in Frankfurt. Okay. Now, because this is a free tier account, right? 90% of the times will be sticking to one region only. 90 to 95% of the times we can easily perform the hands-on in one region only. Fine. Now, what you have to do is choose North Virginia to perform all your hands-on. Now, some will say, I'm in India, you're asking me to access North Virginia, I'll experience lag, latency, there's nothing like that. Okay. You can access the dashboard with a single millisecond delay. Why I'm asking you to choose North Virginia? There's a reason behind that, because North Virginia has abundant free tier resources. You'll not find any shortage of the free tier eligible resources. For example, I've seen people using Mumbai. Even I experienced this thing in Mumbai. You're restricted in terms of using T2.microinstances. You don't get in Mumbai very often. So stick to only North Virginia to do the hands-on. And also there's a reason behind that. If you stick to only one region to perform the hands-on, the chances are you'll be able to easily track your running resources in the same region. You don't have to switch to different dashboards. Fine. This will keep kind of keep sanity check. You're able to easily track the resources on a single dashboard. Okay. Once you switch to North Virginia, you go to launch instance and click on launch instance again. Now, this will present a simple interface, intuitive interface, which gives you one-page experience. Now, previously when there was an old interface, we have to go through multiple pages. On a single page, you can scroll down and up and you can configure everything. Now, the very first thing that we have to do is when we launch an instance is to tag the instance, right? We discussed tagging, why the tagging is used. To name the instance, for recognizing it, to automate the things, and to generate some billing reports. For example, I can type in my demo web server. Yeah, you can just put anything over here. It doesn't make any difference. It's a simple tag. Then the next thing that you ought to use is the application and OS images. What is this? The purpose behind this application and OS images is that you choose the AMI. What is AMI? AMI stands for Amazon Machine Image, as we've discussed. The purpose of the AMI is very simple. It ensures that you can define that what's a software bundle you want to install upon the instance. You can see that. An AMI is a template that contains a software configuration, which includes operating system, application server, and applications which are needed to deploy your instance. Right. Now there's a complete catalog. For the hands-on purpose, we will be using these free tier eligible. For example, Amazon Linux 2 AMI. It's a free tier eligible. You can see that free tier eligible. So for this hands-on, we'll be sticking to the Amazon Linux 2 AMI. So Amazon Linux 2 AMI. So it's a operating system. It's a Linux distribution which is being developed by Amazon. Yeah, we're going to be using this one for this hands-on. You can use any one of the AMIs over here, but for this hands-on, we'll stick to the default one. It's the Amazon Linux AMI. Now, every AMI consists of a unique AMI ID, so that's auto-generated. Now, once you scroll down, the next thing that comes into this entire conversation is instance type. What's instance type? Instance type is the physical, I would say it's a virtual representation of the underlying physical resources. Fine. You can see a whole list of instance types, but the one that we're going to be sticking to is the T2.micro, which gives you 1 GB RAM, 1 virtual core. That's it. It's a decent amount of specs to go forward. Now you see that even though it's free eligible, why it's showing me pricing per hour. This is for the business accounts. Okay, don't worry about that, because if you use T2.micro instance type, then you're not being charged. Performance test 1 to 6. Basically, you just have to tag the instance. Don't change the AMI. Don't change the instance type. Just go through them, and that's it. Steps 1 to 6 based on the document. Let me know once you're done.
Let's have a quick quiz question, guys. And the question is, Dash is a billing and account management service. And your options are Amazon Mechanical Turk, Amazon Elastic Map Reduce, Amazon Dev Pay, or multi-factor authentication. Please mention your answers in the comment section below.
Just a quick info for all of you cloud enthusiasts. If you want to make a career in AWS, then you might want to check out Intellipaat's AWS certification training course for Solution Architect. Learn from industry experts through hands-on session, projects, and case study. Reach us out to know more.
The next thing that we're supposed to do is the key pair mechanism, the key pair login for authentication. If you remember, we just discussed right now what we discussed. In the term of key pair, what we discussed that key pair is a method of authentication. It uses 2 keys. The public key is inserted into the AMI of the instance, which we can't see. And you have a copy of the private key saved on your local computer, desktop computer, or laptop, whichever you're using. It has 2 file extensions, PEM or PPK. PPK is ideally used for Windows computers. PEM is used for Mac OS and Linux computers. So you provide the private key at the time of authentication when you connect, and if there's a right match between the public and the private key, then you're able to get access to the instance. You're able to authenticate. This means that you are the authorized person. Now, in this case, what happens is, you can see that you can use a key pair to securely connect to your instance. Ensure that you have access to the selected key pair before you launch the instance. Now, there's an option which you can see on the right-hand side. It says create new key pair. Can you see that? Let's click on that. Now, it pops a window in front of me. Create key pair. Key pairs allow you to connect to instance safely or securely. Now, we have to enter the name of the key. We are downloading a private key on our computer. So for example, name it as, let's suppose, web server -kp. You can assign any name to it. Even you can just put your first name. It doesn't make any difference. Even you can put your first name. Fine. Once you assign a name to the key pair consists of 2 different authentication standards, RSA EC2 5519. Generally, we don't change this thing. RSA is the is the industry acceptable standard. It can be used for Linux and Windows computers both. Don't change the keypad type. There's no need to change that. So make sure that you don't touch upon this setting. Keep it static. Don't change this thing. Okay. What's the next thing? Next thing is the private key file format. See, basically, you'll be saving a private key on your computer. Generally, if you're using a Windows computer, Windows 10, Windows 11, Windows, whichever Windows computer you're using, Windows 10 or 11, these are two, the latest one, Windows 11, you have to use .ppk. If you're using Mac OS or a Linux computer, use PEM. Now, the thing is, you can also convert PEM to PPK as well afterwards, right? If you want to avoid the confusion as if now, okay, you can use .pem for any computer, whether it's Windows, Mac, Linux computer you're using, you can use PEM safely because later on PEM can be converted into PPK using a software. So use PEM, right? Now, what's next? Click on Create Key Pair, and then you will see that if you just go to the downloads, there's a key saved on a computer, PEM key. This is a private key that you have to safely save on a computer. It's being saved. It goes to your downloads folder, right? So what you can do is that based on the documentation, please perform the step 7 only 7. Let me know once you're done. Step 7 only. Keep it as done. What's the next thing? Next thing I'll show you step number 8, and I'll go till 15. Okay. Steps 8 to 15. Fine. So in this case, all right. So step 8 to 15. What's the next thing? The next thing that comes into this picture is network settings. Network settings means that, because see, the thing is that the instance that you're going to deploy or the server that you're going to deploy would be a part of a network. What's a network? Network is it's a combination of servers and computers or machines. I'll discuss the network part, subnet part afterwards, not right now, because this will confuse you. The next thing that we have to configure is a security group, right? This is the same concept that I discussed with you. What is security group? It's a firewall. It's a virtual firewall that restricts the incoming and outgoing traffic with respect to the instance, right? So in this case, we have to make sure that if we deploy a web application upon the instance, we can allow the HTTP and HTTPS from anywhere, and SSH should be allowed from known IP addresses. If you apply the same concept in this case, you can see that it says allow SSH from anywhere, right? Now, this is not recommended for production environment. For testing, it's okay. But we can choose my IP, and I can choose, this will automatically picks my computer's IP address automatically. Or I can choose custom, and I can define the custom IP address range of my data center network. Right, I can do that. But I can choose my IP. This will automatically pick the IP address of my computer on which I'm just running all these things. But what I will do is that you can choose my IP from the business perspective, from production perspective. If it is doing the testing thing, then you can choose anywhere. But from business perspective, logically, SSH should be allowed from a known IP address. Now, if you choose my IP, if you choose anywhere, it will not make any difference because we're just doing testing. Then check this thing, allow HTTP and HTTPS from the internet. This means that you are opening these two protocols from anywhere. All right. So it will create a new security group with these three rules. You scroll down, storage. See, basically what happens is that because we're launching an instance, it needs a storage, a virtual hard disk. If you have a computer, installing the OS upon it, can you install the OS upon it if there's no hard drive, right? Your virtual machine needs a hard disk to boot up, a virtual hard disk. This is the 8 GB of virtual disk storage linked with the instance. Okay, this is the 8 GB of virtual disk storage linked with the instance. Harita, you have to click on create security group. Create security group. Okay. So you configure storage means that you'll be adding on 8 GB of virtual hard disk for the instance to boot up. We're not going to change it. Let's go to advanced details. As of now, you don't have to learn these advanced details. It's a very early stage. The only advanced detail that you have to look into is the user data. There's a blank column, blank field you can see, which is in which you can write a script. Now, we can put a script, a bash script, a Python script, a Perl script. The script will run as soon as the instance is launched. So why we run the scripts upon the instance? To automatically install the things at the time of instance launching or booting up. This is a bash script. This will run the it says yum update -y. This will update the, so basically this will run the update upon the instance. It will install the HTTPD Apache upon the instance, start the service, check the run services level and start the service, go to its HTML directory and put this text into its index.html file. So we're configuring an index.html file and putting this text over there. Fine. So we need to copy this script and put that in the user data. This script will ensure that it installs an Apache PHP website or web application upon the instance. It will update the instance, install the HTTPD Apache upon it, start the service, go to its HTML folder, and write this text into its index.html file. Right? You have to click on launch instance, wait for the instance to deploy, and then you can test this instance afterwards. Please perform the steps. Let me know once you're done. And then you can just click on the instance ID, and this will present this instance page in front of you. Let me know once you're done with this thing. Based on steps which is documented, if you select the instance, you will see that you can find some details over here. The detail that you're looking for is the public IPv4 address. What's a public address? Public IPv4 address means that if you want to communicate with the server using internet. And private is if you're using on the same network. We're not on the AWS network as of now. So we're going to be using public IPv4 address because we want to access the website using its public IP, internet IP. You copy it. There's a copy icon. Click on this copy icon, open a new tab, and browse this this instance IP, and this shows you the website, the web page. So you have deployed the first website upon the first instance that you have deployed. This is what you get as a congratulations page. So congratulations, you've deployed the first website upon the instance. If you select the instance, there's a public IPv4 address, right? You have to copy the public IPv4 address, put that in the browser, and that's how you access your website, and this is what you will get. And based on the documentation, this is the step number 13, 14, and 15. Okay, so steps 13 to 15 based on the documentation. That's fine. Okay, you have to basically click on launch instance. You have to click on launch instance, step number 12, and go up to step number 15. Either you right click, right, or you just go to instance state. Stop it, reboot it, or terminate it. Stop means you can come back and start it again. The billing will stop at that time when it stopped. Reboot means you're rebooting the operating system. Terminate is that you're permanently getting rid of it. If you don't want to use this instance no more, then you can safely terminate the instance. Now, because we don't have to use this instance now, terminate means that you can't get it back. It's gone. Stop means that you can stop it. The billing will stop for the meantime. You come back and start it the next day or after some time. So click on terminate. Now, if you terminate this instance, it's gone. You permanent, it cannot be undone. So click on terminate, and this will initiate the process of terminating the instance. Now, the terminated instance shows for 1 hour. That's okay. You're not being built for that. Once it's been terminated, no. Himanshu, I said before, when you stopped, the billing stops at that time. And the billing resumes once you restart the instance. You have to go to the actions. Go to the instance state, and then you have to terminate the instance. Terminate means you're killing the instance. It's killed, you can't get it back. And it's okay because we don't have to start the instance again. Fine, that's it. This is about the stuff. And the next one is the EFS. Elastic File System. There's that. Yeah, here we go. Fine. So if I just go, for example, let's imagine if I go to the EC2, right? And I don't have an instance running. So I just quickly go ahead and launch one instance real quick. Fine. Now the benefit that you get from the EC2 disconnect is that even if you choose proceed without a key pair, still without having the key, you can access the instance. Fine. For example, I just go ahead and click on launch instance right now. The instance has been launched, right? Now, if I click on the instance right now, click on instance ID. And choose instance. Because it's still in pending state, you can see there's an option on the top which is called connect, right? So once I click on connect, then it shows me this process that's called EC2 Instance Connect. That's a browser-based shell prompt, and if I just click on connect, then if the instance has initialized properly, then you should be able to connect. Now, because my browser doesn't support that, because I'm using Safari version 16 point less than that, that's why I'm getting some error message. But you got the idea exactly that what needs to be done. Fine. So this is also one of the methods we use, EC2 Instance Connect, to connect to the instance. Fine. AWS has designed its curriculum in such a way that the order of the topics, they don't matter much. Okay. So if you just go to actions and you go to instance settings, networking, security, image and templates. Now, for example, image can't be changed. Once you deploy the instance, you can't change the AMI of it. Fine. You can change its security group. You can change some of its network attributes. You can change its behavior, how it functions. But there are a few things you can't change. For example, the AMI can't be changed. Fine. So if you just go to actions, go to instance settings or networking, most of the things can be changed under instance settings or under security. right? But the things like images can't be changed. For example, you have a document in two formats, .pdf and .doc. These are two different formats only. Basically, it all depending upon which client software you use different formats of the key. For example, I was talking about PuTTY. PuTTY can be only used if you use PPK key, right? For the Mac terminals, if you use Mac OS terminals to connect, then the PEM keys are used. Then the PEM keys are used in that case. So in this case, you can choose any of one of these two cases. Now the thing is that because if you use EC2 Instances Connect, then it does not matter which of the two formats you use. Because if you use EC2 Instances Connect, even if you don't generate the key pair, it does not matter which key pair you generate, PEM or PPK. Why we're discussing EBS and EFS right now? There's a reason behind it. The reason is very, very simple. We want that we're trying to achieve this thing that is, okay, so what we're trying to achieve over here is we want to ensure that we can cover all the aspects of the instance storage. We discuss about EC2 instance, right? What's an EC2 instance? An EC2 instance is nothing more than it's a virtual server in the cloud. What's that? It's a virtual server in the cloud. Fine, that's what the concept of EC2 instance is. It's a virtual server running inside the cloud itself. Now, there's one challenge over here when you deploy the virtual server in the cloud. That is, it needs a virtual disk to boot up. A storage is important for every machine, whether it's physical, whether it's virtual, right? A storage is important for every machine, whether physical or virtual. Now, in this case, because we're talking about the instance itself, we'll be discussing two types of storage options. So in terms of in terms of instance storage, right? In terms of instance storage, we shall be discussing two things over here. The one thing that we shall be discussing would be the elastic file system. So we shall be discussing first thing, the elastic file system, which is called the EFS in the short form. It is called as EFS in the short form. And the second type of storage option that we're going to be discussing is the elastic block store. What's that? Elastic block store. Which is called the EBS in the short form. Fine. These are two different storage options that we have in terms of instance storage, and there's a third one that's called instance store, which is not a very reliable storage, but we're going to be discussing these two different storage options, elastic file system and the elastic block store, both, right? Both we shall be discussing in depth. I'll pick the elastic file system first, right? Okay. So what is this elastic file system all about? Let's try to discuss that. Let's understand its relevance. Let's imagine. So, okay, let's do one thing. Let me discuss that. Let's imagine you have a bunch of instances running in different availability zones. So I'm trying to draw. So for example, these are my two EC2 instances which are running. Fine. These EC2 instances are running in different AZs. For example, this is running in US East 1A, and this is running in US East 1B. Fine. Okay. Now, what is happening is that we need to connect it to a common storage, which is called the EFS file system. So for example, hang on one second over here. So this is the EFS file system. Fine. Now this is a common storage which can be associated or linked with both instances at the same time. This is a common storage which can be associated or linked with both instances at the same time. Okay. So what happens is this EFS file system will have some virtual interfaces that's called mount targets. What are these? These are the virtual network interfaces. Interfaces kind of, we can say that it's a network card, right? These virtual interfaces are called as mount targets. What are they called as? Mount target. Right? And EFS file system will create one virtual interface for every availability zone. For example, this virtual interface is for US East 1A, and this is for US East 1B. Okay. Now, in this case, what happens is, because we have these two instances running in different availability zones, and the EFS file system is a storage that can be linked with both instances at the same time. In this case, if this instance is running in US East 1A, it will be using this interface to connect to the instance. And if this instance is running in US East 1B, it will be using this interface to connect to the instance. Fine. So in this case, using the mount targets, the instances will be able to connect to the EFS file system. And for example, this is instance A, this is instance B. Both instances will be able to access the same file system, and they will store it, and their application data, their files will be stored over here. Fine. So the instances can have, so in this case, the instances will use the same storage that's called the EFS file system or EFS file system or the Elastic file system. Now, basically, what happens is, in order for the instances to communicate with the EFS file system, there's a protocol that is used. Protocol that's used is called NFS. Network file system. It's a protocol that's being used. What's that? It's a network file system. It's a protocol that is being used. NFS, which uses port 2049. What port it uses? 2049 is a port number that it uses. Fine. This is the protocol and port that's being used to for the instances to connect to the file system. Fine. Now, this is done. What happens in this case is that when you do the configuration, so at the time of configuration, at the time of, I would say, at the time of connecting, or I would say that at the time of launching the instances, or I would say that if you want to connecting instances with the file system, there are two things which are needed. There are two things which are required. One thing is that there should be a security group, right, which should be created, which, if you remember what's a security group, it's a virtual firewall that restricts the incoming traffic with respect to the instances, and also you can have the security group assigned to the file system as well. We want that there should be a security group created where The EC2 can access the EFS file system, fine, via NFS protocol 2049, right? So a security group has to be created where this testers can access the file system using network file system 2049 protocol. Second thing is that an EFS agent software need to be installed on each instance. Now, in this case, these two things are required. Fine. When you connect to this, when you want to connect to the when you want to connect to the connect the instances with the file system, the security group should allow the outbound access from the instance of EFS file system via NFS 2049, and an EFS agent software need to be installed upon the instances. Now, fortunately, AWS has made the things easy for us. These two things can be automated. These two things can be easily automated. Right? These two things can be easily automated. So I'll show you that there will be a simple hands-on that we will be performing collectively as a team. These two things can be easily automated, very easily. There's no challenge as such. These two things can be easily automated. Very easy. Fine. So that's the main thing. And basically, this EFS file system will have all the instances data stored upon it. All the instances data stored in it. Fine. This EFS file system will have all the instances data stored in it. So all the data will be stored inside this AFS file system, this test data. I would say the documents, the application data, log files, everything will be stored over there. Fine. Now, the storage has to be made redundant. What do you mean by data redundancy? Basically, data redundancy means that, okay, I'll show you that option afterwards. I'll discuss with you. But basically, the thing is that this is how the EFS file system functions. It's a common storage that can be used with multiple instances so that the applications, the software running upon these instances can have a common storage to access. You can have a cluster of instances running in a single region, and all the instances can have the same storage that can be accessed. Fine. So if there's a requirement when you have to create a cluster of instances in a region, and all the instances should have the same storage that can be accessed, then in this scenario, you can make use of the EFS file system or the Elastic file system, and that's how it functions. Let's start with the hands-on because I'll discuss with you a lot of concepts during the hands-on as well. From the document and sign into the console. The name of the document is Getting Started with the Amazon Elastic File System. Getting Started with the Amazon Elastic File System. That's the name of the document that you have. Fine, that's the name of the document. Okay, if you want this document is very simple and easy to follow. The process is the same that we have used for EC2. What's the process? By the way, just give me a few seconds over here. The process is very simply laid out. And what I will do is that I'll explain you few things along the way, right? And then I show you some steps, explain you the concept behind those steps, fine. And then once I'm done with the steps, using this document, you can perform the same steps on your own. Getting started with the Amazon Elastic File System, this is a document which gives you a very common, I would say, scenario that how the Elastic File System can be accessed by multiple instances at the same time. Now, what is EFS? Let's understand that. EFS is a simple, serverless, elastic, and set and forget file system that automatically grows and shrinks as you add or remove the files with no need for management or provisioning. See, the elastic file system is a simple storage capability, whereas serverless means that you don't have to deploy any virtual server to get it. It is elastic. Elastic means that it can grow or shrink, which means that you don't set any size for it. Depending upon your addition or removal of the files, it can change its amount of space, right? So it's when you deploy an EFS file system, you don't have to specify any storage space you require. It will increase or decrease itself depending upon how many files you add or remove. Fine. Now it can be used with EC2, Lambda containers, Kubernetes containers, or even with the on-premises servers as well. Fine. So in this case, there are 3 steps that we have to perform. One is create your Amazon EFS file system, then launch 2 Amazon Linux instances, connect them to the EFS file system at the same time, and then test the file system. Fine. I'll show the step from 1 to 8. I'm sorry, 1 to 9. Right? Again, don't rush. Focus what I'm explaining to you. EFS can be easily accessed if you just type in EFS on the top. You can see that it says EFS managed file storage for EC2. I click on the EFS, and this will just take you to the EFS dashboard. So EFS dashboard is different. Now, one thing, please make sure that all of you use the same region, North Virginia, to practice, because it has abundant free tier resources. So the EFS file system and the instances should be deployed in the same region. All right. Now, it says Amazon Elastic File System, scalable, elastic, cloud-based native NFS file system. You click on Create File System, and the very first thing is that you have to assign a name to it. Now you can assign any name. It doesn't matter what name you assign. So name it as, for example, demo EFS file system, right? So I've just assigned a simple name to it. Don't change the VPC. VPC basically it's a virtual data center which will consist of all your resources. We'll discuss VPC in depth afterwards, but don't change it. Now, this is what I want to explain to you as a theoretical concept. Storage class, standard, and one zone. Pay attention to what I'm saying. Storage class means that this file system will consist of your instances data. If you choose standard, your data is stored redundantly across multiple AZs in this region. What do you mean by that? Let's imagine, okay, let me just, why my iPad gets disconnected in between. All right, it's connected now. What I'm saying is, storage class, if I go back to the storage class, which is, let's go back over here, standard, right? So if let's suppose I go with the storage class as standard. Right? In this case, the data is stored redundantly in all the AZs of your region. For example, my EFS file system is in North Virginia, right? North Virginia has 6 availability zones. So North Virginia is labeled as US East 1, right? It has 6 AZs. US East 1A, then it has 1B, it has 1C, 1D, one E, one F, right? So how many AZs are there? There are 6 AZs, right? Now, if I use standard, the data is multiplied and stored across all the AZs, right? Now, in this case, this is feasible for data which is critical for you, right? So the data is critical. It's a very important data. So in this case, you want that data to be synced across all the availability zones. Multiple copies are being saved across all the ACs. But this thing is costly. This will cost you more because you're saying, hey, Amazon, go ahead. Any data which is stored in EFS file system should be replicated in all the AZs of my region. In this case, AWS, there's no any substantial evidence or documentation uh, how many copies will be generated, but it will generate a fair number of copies of your data and save across all the AZs, right? This is when your data is very important and you're willing to pay the price for that. But what if the data is not important for you? You can just go with one zone over here, right? In this case, uh, the data is stored, the data is redundant, the data is stored in one AZ only, right? So in this case, this is cheaper for less critical data. Any data which is not that much important, because in this case, if your AZ goes down, you may lose this data. If the AZ goes down, if the availability zone goes down, then you can lose that data. So in one zone, the data is stored in one AZ only. It's a cheaper version for less critical data. Fine. So in this case, if I go with standard, it says stores data redundantly across multiple AZs. If I choose one zone, then I can choose in which of the availability zones I want my data to be made redundant. This means that, for example, if I choose one zone, I pick only one availability zone, US East 1C. If this AZ goes down, if the availability zone goes down, my file system will also go down. If my file system will go down, my entire data will be lost. So this is a risky thing. But again, if you're tight on budget and if your data is if you lose that data, then it doesn't impact your production environment, then you can go with one zone. Fine. We go with standard. In our case, and click on create. Now it will take a few seconds and it will create the EFS file system. Now, if I just go to the EFS file system, click on that, you will see that this file system is created. I go to network, and these are the 6 mount targets. So you can see that under network, I can see that 6 mount targets will be created for each of the availability zones, which means that the instances inside each of these AZs can use the mount targets to access the file system. See, automated backups, basically it uses AWS backups capability at the backend to back up the data, or it can store the data in terms of replication or snapshots. But because you're not storing huge quantities of data as of now, so it will not cost you anything. So the next thing that you're supposed to do is that we have to start with the launching of the instances. See, the thing is, because we have deployed the EFS file system, the next thing that we're supposed to do is that we have to connect this file system with at least 2 instances that we're going to deploy next. So in this case, what we're going to do is that I'll show you the step from 10 to, let's go to 10 to, okay, I'll go from 10 to 16 only. That's it. Yeah, or 10 to 15, not more than that. Let's go with 10 to 15. Okay, I'll go with step 10 to 15, and then I'll give you sufficient time to do it by yourself. Steps 10 to 15. See what I'm doing? I have to go back to the, I have to navigate back to the EC2 dashboard. So I just go to the EC2 and click on the EC2. It's just a dashboard, or I can just go to simply just go to the EC2 dashboard and just try to initiate the process to launch instances. So let me just go there. Okay, I'm there. Fine. Now I just click on launch instance right away, and I'm being presented with the screen to deploy the instances right away. The very first thing I'm supposed to do is I have to assign a tag to it. Now, if you remember, what's the process of tagging? Tagging allows you to group the instances together based on their the value that you assign to them. It helps you to recognize the instances of the group of instances. It is also a wonderful feature to help you automate the things, to extract some complex big reports. Now we have discussed all those things. So what we're going to be doing right now is that I'll just tag the instances right now. Yeah, update the instance to right. And sure. So name it as, for example, demo EFS instance. Now, this tag will be assigned to both instances. Fine, this tag will be sent to both instances. Then comes the AMI. What we discussed, AMI is it's a software part of the instance, and AMI will show you that what's the software configuration of the instance, the operating system, application server, application. So it's a software bundle. Now, in this case, we'll go with the Amazon Linux AMI. So it's a default AMI. You don't have to change it as of now. It's free to eligible, it's free of cost, and you don't have to pay for it. Then comes instance type. What's instance type? It's the virtual representation of the underlying physical resources. Instance type, we just go with the T2.micro, which gives us one virtual core, one virtual CPU, 1 gigs of RAM, and it's also free of cost. It's a free tier eligible instance type, so you don't have to change it. There's no need to change it. Now, under the key pair login, now why we use a key pair? So that we can securely connect to our instance or instances. We can securely connect to our instance or instances. Click on create new key pair, and for example, in this case, you can just type in EFS-KP. Now, don't change anything over here. Keep the key pair type as RSA. Private key file format should be PEM. I would say don't change anything. Don't change anything over here. Simply click on create key pair. Fine, and that's it. Perform the steps from 10 to 15. Okay, so let's go to the next step. 15th. Okay, 15th is done. Now it will save the PEM key on your desktop in the downloads. I'll show the step from 16th and 16th and 18th only. Yeah, 16, 17, 18. Only 2-3 steps. That's it. Because I want to explain a few things over here. You scroll down, and there's something called network settings. Click on edit. Now, under network settings, if you see based on the step number 16th, let's show that, and 17th, right? So what you have to do is based on step number 16th and 17th, that you have to choose subnet no preference, and if you have to pick any one of these availability zones in the list. See, what's a subnet? I explained you this concept afterwards in detail, but a subnet is nothing but it's a bunch of private IPs. It's a small network which can support your multiple instances. It's a small network that can support multiple instances. Now, these subnets are linked with different AZs, availability zone. For example, this subnet links with USS 1D, 1F, 1E, 1B, A, and 1C. Now, you pick any one of these subnets / AZ in the list. That's the main thing. You have to pick any one of this subnet or AZ in the list. Any one of them. Any one of them, right? And then in your case, you just choose. So we have to go with the firewall security group. Make sure, see, in this case, what you can do is, if you just go with this thing, you can click on create new security group and name this security group as my EFS, SG, or anything. For example, you can just put a name over here. This is the security group or a demo. Hang on 1 second over here. EFS, SG, or SG stand for security group. You can just put any name over here. It doesn't make any difference. Now, basically what I've proposed in the document is that you should choose SSH from my IP, which is this one. But the problem is, in this case, because we have to use EC2 Instance Connect, right? You choose anywhere. So that's a difference from the document. In the document on step 18, I've documented that you should choose SSH from my IP, right? But I would suggest you choose anywhere. Fine. So I'll step in. So please choose SSH from anywhere. This is very important because this will help you to use EC2 disconnect without any trouble. Please choose SSH from anywhere. Fine. And that's it. Perform the step from 16 to 18. Let me know once you're done. So you have to go to the network settings, choose one of the, click on edit, choose any of the AZs, and choose SSH from anywhere. The difference between these two, Kalyan, is my IP will pick the IP address of a computer only. Anywhere means that any IP on the internet can access your instance via SSH. That's a difference. My IP means that only your computer's IP can access or can initiate the SSH connection towards the instance, right? And anywhere means that any IP. Now, why? Basically, it's a security breach. If you see from the production business perspective, it's not the right thing to do. It's a security breach. It's not the right thing to do, but because we just do the hands-on, just to make sure that you guys don't face an issue with the EC2 Instance Connect option that we're going to use to connect to the instance, to be on safer side, we're doing that. RDP and SSH should not be allowed from anywhere, right? Because in a business environment, it's a security breach. It's a security issue. But because right now we are doing testing only, so it's okay. It's not a business production workloads we are running. For testing, we can do that. Okay. The next thing that you're supposed to do is I'll show the step number 19th and go till up to 24. The next thing that you have to do is that you have to configure storage. Now, I discussed with you two storage options, EBS and EFS. I didn't discuss with you, but I said to you that there are two different storage options you are presented with: Elastic Block Store and Elastic File System, both. Fine. Now, this configure storage option that you can see over here, this is the EBS volume. elastic block store volume linked with the instance. Now it should be linked with the instance because this is the root volume. This is where the system will boot from. This is the main volume. We don't have to change it or remove it. It will stay as it is. You can see that right now it says 0 into file systems. Right, this file system is set to 0 file systems. It's not doing which we said as of now. There's no file system which is connected with instance. You have to click on edit, and click on add shared file system. Automatically, it will pick up the file system that we deployed previously. Right, in the previous step, we deployed the EFS file system. It will automatically pick it up, and this is the mount point, which means that this is the path of the file system. This is how you're going to be accessing the file system. We'll see that. I discussed with you this thing, that is, when you start accessing the instance storage, there are two options that you have. One is EFS file system, and the other one is the elastic block store. Right? We discussed that. Now the thing is, I discussed with you that there are two things that you need to have for the instances to access the file system. One is the security group. I'm sorry. Security group. A new security group has to be created so that the instances can access the file system using NFS 2049 protocol. Right. The communication between these two different components can be easily done if this port is opened. So a new security group has to be created. And also upon these instances, an EFS software, client software needs to be installed. So an EFS agent software needs to be installed upon every instance. Fortunately, these two things are automated. How? Because if you go back, you will see that there's an option to check these two things, automatically create and attach security groups, automatically mount shared file system by attaching required user data script. So basically, if we just go to the advanced details, under user data, it includes a script so that the EFS file system can be, or the utility, the client software can be installed upon instances. And then these instances can connect to the file system. Fine. So you have to make sure that these two options are checked. Don't uncheck them, so that automatically it adds on one more security group so that the instance can access the file system over network file system NFS protocol 2049. Fine. And it includes a script to install the client software upon the instances. The last thing that you're supposed to do is that under summary, there are a number of instances that you have to mention. You have to remove one and put two over here. Put two over here. Fine. Because I want to deploy two instances and have them connected with the same file system. Click on launch instance and let me know what's done. Steps 1924. Enable if you want to connect EFS after launching the instances, then the process will be different. You have to manually log into the instances, and you have to what I would say that you have to run some commands. To manually launch the instances, and you have to manually execute some commands to connect. So in that case, the process becomes a bit complicated. So I have to log into instance by instance and install the EFS client software upon them. So guys, if you just go to view all instances, you will see that these two instances can be easily showing up, right? Let's wait for a few more. Okay, I think it's been done now, and we don't have to wait. What's the next thing? Let's go with the testing part. Testing part is very important because basically you can easily verify that the thing is working or not based on the testing. So what you have to do is in terms of testing is that you have to first thing first connect to any one of these two instances. Now, basically, I haven't mentioned that that step because it's a very simple thing. We know that how to connect. You choose any one of these two instances, any one of them. Okay, choose any one of these two instances. There are two options to use EC2 Instance Connect. Either you right click, you have the option to connect, or you can choose that there's an option to connect on the top. Okay, click on connect. Okay, I just have it for you. So you have to select the instance, right? Click on connect. You'll just be presented with the EC2 Instance Connect. Immediately, you don't have to change anything over here, and simply click connect. You don't have to change anything over here. Simply go ahead and you have to click on connect. Fine. So if you just click on connect over here, this will okay, now because I'm sorry, I'm using Safari, which doesn't support this thing. I need to just go ahead and use Firefox. I'm going to just use Mozilla Firefox to connect. My browser doesn't support it, unfortunately, so I have to use Mozilla Firefox. So I just go to the EC2 right now. Just go to the instances. Choose from the instance. Click on connect. Click on connect one more time, and then it will just open the shell prompt, which is browser based. Now I'll show the steps from, for example, 26 and 27. 26 and 27. See what I'm doing? Steps 26 and 27. See, basically the thing is that you have to go to the you have connected to one of the instances. You have to see the file system. Just type in df -space capital T. It will show you the list of I would say linked storage, internal storage linked with instances, the file systems. So if you see over here, this information which you can see, MNT EFS FS1. This is the information which shows you that there's one file system which is connected with the instance. There's one file system which is connected with the instance. Now, basically, what is supposed to do now? You have to create a document in this file system. Just type in sudo, because you have to have some privileges to do that. Sudo touch. Now you have to mention the complete path of the file system, right? And assign any name to this test document. For example, I just type in rohan.txt. Right now, this will create a text document in the file system. I press enter. Now, if I wish to see this document, is type in ls, then mnt, EFS, and FS1. Now you can see that this document shows up, which I just got created. Right? Every time if you want to add the data, do we need to type in the path, or we can make it default? Mohammed, whenever you configure, if I see, the thing is that you'll be using the EFS file system so that the applications or the workloads can have the common storage to dump their files. So for example, you are creating a web application which which will store its files somewhere. So that application needs a path to store the files into. So you can measure this path, which is mnt efs fs1, this one, mnt efs fs1. Automatically, your front-end application or the back-end application server, whichever you're running, when you configure it in the code itself, you can mention this path, and it can dump its files over there. So basically, this is for the testing purpose I'm showing you. Once you start with the app deployment stuff and your front-end applications, for example, deploying a Python Django website, right? It has to save some of its, for example, pictures or videos into a storage device. So in the code itself, you can mention this path, and automatically the application will be able to understand that if it has to store its images or the videos, it has to be stored in this file system, right? So that's how it goes. If basically after running the first command sudo touch these the I would say mntfsfs1 the path, and just type in, for example, your name.txt. If the command executes properly, this means that the file system is mounted. Somehow you're not able to see that. All right, now guys, to test that the same file can be accessed by the second instance, I'll show you the step number 27 only. You have to do this thing. You have to disconnect from the first instance, go to the instances, and you have to connect to the second instance by SSH. Same process. Choose the instance, click on connect, and click on connect one more time. This means that your file system is not being connected to the instances. This means that you somehow skip the step. No, I'm talking about the step number, this one. You by mistake, you didn't perform the step 20, this one. You forgot to add the file system. You somehow by mistake skipped step number 20. The file system is not being connected. Okay, that's a problem. Now guys, what you have to do next is that you have connected to the second instance. What you have to do is that run this command, ls for listing, ls mnt, then efs and fs1. Press enter, and the same file that you created from the first instance shows in the second instance. The same file that you created via the first instance now shows up on the second instance, which means that this file system, this is the file system path. This is connected to both instances, which means that, which proves this fact that if instance A puts any data to the file system, instance B can also access it. Fine. So this is a kind of a common storage for both instances. Any instance puts any file into this file system, the other instances can also access it. This is for the testing purpose, where we are testing that if we connect the file system with multiple instances. So we have successfully tested the file system. For example, I'm in the second instance, right? I do one thing. For example, I just type in, let's suppose I just type in echo and just type in this is a simple. I put that text into my document.
Let's have a quick quiz question, guys. And the question is, which of the following is a structured data store that supports indexing and data queries to both EC2 and S3? And your options are CloudWatch, Amazon SimpleDB, Amazon CloudFront, or all of the above. Please mention your answers in the comment section below.
Just a quick info for all of you cloud enthusiasts. If you want to make a career in AWS, then you might want to check out Intellipaat's AWS Certification Training Course for Solution Architect. Learn from industry experts through hands-on session, projects, and case study. Reach us out to know more.
Okay, I go 1 second. I think I did type something wrong. Let me just go to directory. I mistyped the thing. Sorry about that. Here we go. All right, so I have to just type in sudo to get the root privileges. All right, hang on 1 second over here. Fine, and let me just copy and paste this text one more time. All right, here we go. So I have put a simple text into my document. If I just type in cat and mnt, I'll just go to the drive only. So I'll do one thing. If I just type in cat MT, EFS, FS1, rohan.txt. This is the simple text that shows up, right? I just put a text in the txt document, rohan.txt. Now, if I connect to the first instance or another instance, and I run the command again over here, cat mlt efs fs1 rohan.txt. You can see that from the second instance, I'm able to access the same. Changes made to the document. Fine. So this proves that if I make any changes to any of the files, it can be easily synchronized across multiple instances in real time. So this means that you can easily make the changes to your text document, and that's how they will show up. Fine. Now, time to clean up the things. To clean up, first thing first, I'll show you the step from 28 till 30. 28 to 30. So in this case, what you have to do is you have to terminate your instances. Choose both instances, go to actions. Okay, by mistake, I have switched to the old interface. I choose both instances like this, go to instance state and click on terminate. You have to go ahead and terminate the instances. So basically the thing is, EFS file system doesn't gives you the capability to perform the modifications in terms of read, write, access, or execute permissions. This has to be done at the instance level, right? This has to be done at the instance level. So at the instance level, you have to execute some commands so that you can define the permissions, the read, write, execute permissions to modify the files in the file system or the directory in the file system. If the instances are terminated, they will show up for next 1 hour, but your billing has stopped. After 1 hour, they will be removed from the dashboard, but your billing has stopped now. Okay, so don't worry about that. Now you also have to delete the file system. Step number 31 and 32. See what you have to do is steps 31 to 32. To delete the file system, go to the file system. Fine. You simply have to check it, click on delete on the top. Now it says that this is a destructive action that cannot be undone. You have to confirm that you have to delete the file system. So there's a file system ID. You have to just copy it like this, and you have to paste it in the box itself. Click on confirm, and this will be a confirmation for you that yes, you wish to delete the file system. And after a few seconds, this will be removed from your interface. It takes some time and it will be removed. Fine. That's what the concept is. That's what you have to do to remove the things, right? So we saw that how you can make use of the file system in order to have multiple instances sharing the same storage, and you can cluster instances together and have them access the same storage, which is the EFS file system. Fine, that's it. So you have to copy and paste this file system ID. Can you see that? In this case, it shows your file system ID. This one, you have to copy and paste it over here with no blank spaces at the end of it. And then click on confirm. Fine. It's a simple process. Because if you don't enter the file system ID properly, then it basically, it's a destructive action. You will lose the data if you remove the EFS file system. So as a caution, it gives you that please make sure that you remove the file system properly. So it's kind of a check that you have to go through. Now, in terms of the concept of ELB and autoscaling, I'll discuss with you the purpose of the load balancer, the purpose of the autoscaling, how these two different services fit with each other, how they fit together to give you a very robust infrastructure. And basically, these are the high availability options, right? If I show you right now, sign in real quick. Okay, if you just go to the course section, you will see that under the study materials, this shows under this thing. In Load Balancer, ELB Autoscaling Route 53, right? So we have done Introduction to Cloud Computing. We have discussed EC2 and EFS because these two topics are interrelated. Now, in terms of the load balancer and autoscaling, what you need to understand is that these services would be used if you are going with a big infrastructure. Big infrastructure means that you are not depending upon just one single instance. There's not one instance involved, the multiple instances involved which are there to support infrastructure. Now, what is this load balancer all about? Why exactly you need the load balancer if you have an application which is supported by multiple instances? A load balancer is required because it's a service that uniformly distributes network traffic and workloads within different servers or multiple servers or a cluster of servers. Okay, so the load balancer is required if you need to have multiple instances running at the back end. There are group of servers, group of instances running at the back end, which are supporting your application. Now, the load balancer is used to increase the availability and fault tolerance of an application. The purpose of the load balancer is that it's used to manage the traffic. What do you mean by manage traffic? See, the thing is, if you pay attention over here, these are your end users. These are your customers. Fine. They are using maybe your web browser, maybe the mobile app, whatever they're using. Let's imagine that they want to access your website. Let's take this into example. They want to access your website. They will type in, for example, xyz.com. They'll just type in xyz.com. Now, this will be translated to the DNS name of the load balancer. So what is this? This is the DNS name, and this is what is this? This is the LB. This is the load balancer. This is the load balancer. Fine. Now, all these users are sending the traffic to the load balancer. How they're sending the traffic? They just type in xyz.com, your domain name, and the xyz.com is further being translated to the DNS name of the load balancer. The load balancer then receive the traffic and forward the traffic and distribute the traffic equally across all the instances which are running at the backend, right? So for example, there are three instances: instance A, instance B, and instance C. These three instances running. Every instance will receive 33.3% of the traffic. Why? Because load balancer performs an equal distribution of the traffic across multiple servers at the backend, right? So what is this? The load balancer is sending 33.3% of the traffic in each of these different instances. Fine. So the main purpose of the load balancer is that it is used to balance the load. It is used to balance the load. What's the load? That's trying to balance this one. This is the traffic load. What's this? This is the traffic load. So to balance this traffic load, the load balancer is needed, right? To balance this traffic load, the load balancer is required. To perform the equal distribution of the incoming traffic, to balance the traffic load, the load balancer is needed. So the main purpose of the load balancer is that it receives the traffic from the clients, from the end users. It gets all the traffic and performs a load management or load balancing and performs equal distribution of the traffic across multiple instances which may be running in different availability zones. Fine. Now it says load balancer increases the availability and fault tolerance of an application, right? It increases the availability and fault tolerance of an application. What do you mean by that? This means that, let's imagine if instance A goes down, right? In this case, the traffic that should go to instance A will be now distributed between instance B and instance C, which means that both these instances will now, each of these instances will now receive 50% of the overall traffic. Each of these instances will receive 50% of the overall traffic. That's why the load balancer is designed to increase the availability and fault tolerance of an application. So if any fault happens, it will it ensures that there's a tolerance towards that, and your application is highly available. If out of these 3 instances, 1 or 2 they go down, you still have 1 or 2 instances left to enable the continuity of your application. To enable the continuity of your application. Fine. So I guess this is clear why you need a load balancer. The purpose of load balancer is simple: to perform the load balancing and equal distribution of the traffic across the instances which are supporting your application. Fine. Because in a big architecture, you don't depend upon just a single instance. You have to use multiple instances to reap the benefits, to get the benefits of high availability. That's what the purpose of the load balancer is. Fine. All right. Now, so these things have load balancer is a separate service. All right. Now, I'll help you understand exactly that how the load balancer functions. Try to understand it, because it is very, very important for you to understand that what is the modus operandi, what's the methodology that the load balancer uses to operate. Pay attention to what I'm saying so that you can easily understand this concept. All right. So let's take one example over here. All right. So what we're discussing the concept of elastic load balancing. I will just jot down the exact name of the topic. Just allow me a few seconds over here. Let me just remove the drawings from the previous annotation. All right. So this concept that we're going to discuss is called the elastic load balancing. Let's try to discuss this concept. So over here, let's imagine that I have a load balancer which is running. This circle represents ELB, which stands for elastic load balancer. Right now, this load balancer is working with 2 instances over here. I'll draw one instance A. So this is the first instance I have. And this is the second instance. All right. So this is, for example, yeah, I have 2 instances over here. This is instance A. What it says, this is instance A. And this is instance B. Right now, each of these instances is in a different AZ. For example, this is in US East 1A, and this is in, for example, this is in US East 1B. Fine. So I have two instances running. So let me just put them in, just put them over here, and I have the loop balancer in between. Fine. Now, these two instances are identical in nature. What do you mean by identical? Identical means that the application and services running upon these instances are same. What do you mean by that? So, for example, both these instances are running a Node.js app, right? Both are running Node.js web application. They are running the same application upon them. They're identical in nature. They have the same software, same services running upon them. Now, what I do is that I want that my front-end users, for example, these are my customers. These are my, let's imagine, these are my internet users. Okay, now these internet users, they want to access my website. What they will do is that they will just type in my domain name xyz.com. Now this will be picked by a DNS server. DNS stands for domain name server, and translated to the ELB's load balancer's DNS name. In this case, the users will type in xyz.com. Fine. This will be translated to the load balancer's DNS name. From there, the load balancer will forward equal distribution of the traffic. It will perform the equal distribution of the traffic. So the users are sending the request. These requests, once they hit the load balancer, the load balancer will perform equal distribution. So this means that this instance will get 50% of the overall traffic, and this instance get 50% of the overall traffic. So the traffic will be split into half between two instances because we have two instances running as of now. Fine. So the internet users type in the domain name xyz.com. The DNS server picks the incoming request because the xyz.com, it's being converted into the load balancer's DNS name. And from there, the load balancer performs the equal splitting of the traffic and distribution. Right. Now, the load balancer is designed for the incoming request only. Incoming traffic only. The load balancer is designed in such a way that it is there for incoming request only. It doesn't entertain outgoing request, which means that who will respond to these users back? The users are sending the request. The load balancer is receiving that request and forwarding and performing the equal distribution. It is sending the traffic to the instances. So the question that comes in, that who will respond back to the user? The answer is the instances will respond back to the instances will be responding back to the end users. The instances will be sending the responses. These instances, hang on one second over here. These instances will be sending their responses back to the users. So these instances will respond. These instances will respond back to the users, and the users will be able to see the web pages. For example, just type in www.intellipaat.com and you're able to see the Intellipaat web page because the server at the backend will serve you the web page. So the instances will respond back to the user. That's how the process goes. Fine. Now, these instances over here, hang on one second, these instances over here can run in different availability zones, but they should be in. So, but the problem is, the main thing is that this entire thing, the ELB, let me just write down over here. This thing is important to note that the ELB, or I would say the load balancer and instances should be in the same region, should be in the same region. They should be deployed inside the single region only, right? And the instances can be scattered in different availability zones. Fine. Now, the purpose of the load balancer is that, so what are the benefits? So the benefits of the load balancer, as we have seen, is that first thing first, it performs equal distribution of the traffic, or I would say this is mainly used for traffic management. It is used for traffic management. Plus, it is used for high variability and fault tolerance. What do you mean by that? Let me show you. High variability and fault tolerance. What exactly are being meant by these terms? For example, in this case, let's imagine if any one of these two instances go down. Let's imagine instance A goes down. It can be any reason, maybe some problem with the instance itself. Just give me a few seconds over here. Let me just put them as separate. So the second benefit is that it's used for high variability and the fault tolerance, traffic management, these are three main benefits. So for example, in this case, instance A goes down. There can be any reason. Maybe the AC is affected or the instance is affected. Just give me a few seconds over here. I can see some questions over here. So in this case, if instance A goes down, first thing first, if an instance is not responding, this means that instance is unhealthy. Unhealthy means that there's something wrong with the instance and it is not responding. So for example, this instance is unhealthy. How the instance is being termed as unhealthy? What happens is that load balancer performs health check. So that the next benefit of the load balancer is that it performs health checks. Okay, so if it performs health checks, how basically what's a bit how this benefit is useful for us? The load balancer does this thing is that it generates a traffic. That's a health check traffic. So it sends a ping message. It's a health check traffic. It's a health check request, which it sends by default every 30 seconds, right? By default, every 30 seconds, it performs a health check for every instance. So every 30 seconds, it is going to perform the health check. So it's going to perform the health check by default every 30 seconds. Fine. Now, once this instance is healthy, for example, let's imagine, so for every instance, it performs the health check. Fine. Now, in this case, So if the instance is healthy, the instances will get back to the load balancer with the 200 OK as the acknowledgement message. 200 OK is the message that the instance will respond to the load balancer. So what happens is the load balancer, this is my load balancer, it sends the health check request to the instance. Basically, it will ping one of the pages. Let's suppose this instance has a website running upon it. We give it a path. So for example, we set a ping path that the health check should be sent towards the index.html page of our application running upon the instance. Fine. So the load balancer will ping one of the pages of the instances of the web application. Now, if the instance is healthy, it will get back to the load balancer. It will get back to the load balancer with the 200 OK acknowledgement. If that's the case, if the instance gets back, so this health check is performed every 30 seconds by default. This is the default frequency. Now, if the load balancer sends a health check every 30 seconds, and the instance immediately responds back to the load balancer with a 200 OK message, then in this case, load balancer will say, all right, this means that this instance is healthy. This instance is responding. This instance is healthy. There's nothing wrong with the instance. It is running fine. So this instance is healthy. In this case, it will say that this instance is healthy. It is running properly. There's nothing wrong with that. So in this case, the load balancer continues sending the user's traffic to it. Now, if the instance is not healthy, for example, if the instance is down, let's imagine if the instance is not healthy, then it is very obvious that it will not respond with this message. If it doesn't respond with this message, the load balancer will say, okay, this means that the instance is not healthy. It is not, because if it's not running properly, if there's something wrong with the instance, then it's been declared as unhealthy because it didn't respond to the load balancer with exactly the 200 OK acknowledgement. Now, this is a backend process. Fine. So I repeat what I said. The purpose of the load balancer is simple. It receives the traffic from the client and forwards the incoming request to the instances. The instances will respond back to the users directly. The load balancer ensures that it performs a health check and it sends the traffic to the healthy instances only. In this case, a healthy instance should get back to the load balancer with a 200 OK acknowledgement. If the load balancer doesn't get that message, then that's been declared as unhealthy. In this case, the unhealthy instance never receives any upcoming traffic. The traffic is being cut off, and all the traffic is being diverted to healthy instance. So this instance B, which is healthy, will now receive another 50% of the traffic. Right? So it reroute the traffic from, so if any instance is found as not fit, it reroutes the traffic, or I would say that any upcoming request will now be sent to healthy instances which are available. So this means that this instance B will receive entire traffic because now instance A is down, so this will receive entire traffic. Fine. And what's the deciding factor? The health checks. The health check is the main thing based on which the load balancer operates. So for example, I can say that my ping path is the home page of my website, which is index.html. So in this case, if I set the ping path, which is the index.html page, so in this case, what happens is the load balancer will send the ping message to this page only, right? And this will ensure that the application, the web application that I'm running upon this test is running properly, right? So it will ping one of the pages that you have configured upon the instance of its application. I just reiterate this concept. What's the load balancer? The purpose of the load balancer is that it takes incoming requests from the end users and perform the equal distribution of the traffic between the instances, which may be running in different availability zones. Apart from the load balancing or the traffic management, it performs high availability, fault tolerance for you, and performs the health checks. How it does that? It sends a ping message to one of the pages of the instance every 30 seconds. If the instance is running properly, it's healthy, it should respond back with a 200 OK acknowledgement message, right? Now, if the instance fails to do that, if the instance does not acknowledges back to the load balancer with the 200 OK message, the load balancer would declare the instance as unhealthy, not fit, and then it will stop sending the traffic to it, stop sending the user's traffic to it, and any of the future traffic will be diverted to other healthy available instance. Fine. So these are the benefits of the load balancer. It performs the traffic management, high availability, fault tolerance, and perform the health checks. Okay, this is the modus operandi of the load balancer. This is how it operates. One instance is down, and the other instance B, which is this one, this guy on the just bottom, this is getting all the traffic. This is getting the entire traffic. If the instance B is getting all the traffic, it's getting double the amount of load. For example, you go to the office today or any day, for example, and your boss gives you double the amount of work that you're supposed to do. What will happen to us? If we have to do double the amount of work that we have to do, what exactly will happen? Performance issues, absolutely. Performance will downgrade. It will be severely impacted because this instance B was supposed to get only 50% of the traffic. Now you're sending double the amount of load to it. What is supposed to happen? After some time, there's a higher possibility that either it will go down, either it will fail, or it will slow down. It will become slow. So basically, at the end, the performance of your application would be severely impacted, would be adversely impacted. Now, the load balancer has limitation in this case. The purpose of the load balancer is that it performs a traffic management, ensuring that if any instance is not fit to respond to the user, then it will send the traffic or divert the traffic to other instances which are healthy. And it's a good strategy. So this means that we should have something we on our plate or in our basically set of services or a service which can launch a new instance as a replacement. See, in this case, we don't have the time to do troubleshooting. Fine. Troubleshooting is done in those cases when you are working on manual infrastructures. In automation stuff, and when we're automating the things, generally we only troubleshoot if it's very much required. So in this case, what happens is I want that there should be some capability enabled that a new instance, a replacement. So for example, a duplicate instance A is launched. Just so I want a capability that duplicate, or I would say a replacement instance is launched automatically. Fine. And the load balancer starts sending the traffic to it. Fine. So that now this gets the 50% of the traffic. There has to be some capability that should launch a new instance. It should launch a replacement instance. A new instance is launched to replace instance A. This is the replacement instance launched automatically. Fine. So in this case, the replacement is launched automatically and the load balancer quickly sends the traffic to it. Fine. We have to use a capability that's called auto scaling. Auto scaling is used in these scenarios when if there's an increased in demand or there's a requirement of extra instances or new instances, auto scaling will launch new instances automatically. Fine. So auto scaling will do this thing. It will automatically deploy a new instance automatically as a replacement. Without any further delay, it will automatically deploy a new instance as a replacement. So you can use auto scaling along with the load balancer, ensuring that if any one or two instances or three instances or multiple instances go down, it can easily deploy extra instances to replace the older ones which are unfit, which are unhealthy. That's what it's been designed for. And this is what our discussion for the next section. That is, we'll discuss the concept of auto scaling. Fine. So it doesn't matter how many instances fail. Auto scaling will ensure that if it finds that you're running below the capacity, fine. If you're running below the capacity, it will automatically deploy the same capacity of the instances as a replacement. That's it's being designed to do. Fine. So auto scaling will launch new instances as a replacement. So how the auto scaling operates? Let's try to understand this thing. So what is auto scaling? Let's try to understand this thing. So auto scaling is a service which is based on the principle of elasticity. What do we mean by elasticity? Elasticity means that it is the ability to grow or shrink your infrastructure based on these three factors: patterns of the incoming traffic, time of day, and the demand. So it's a service which is based on the principle of elasticity. What is that? Elasticity. Elasticity means that you can increase or decrease the number of instances based on these three factors. For example, demand. We have a demand of at least two instances. If one instance is not fit, if we deploy a new instance as a replacement automatically. Fine. There are a few more examples. Let's go with the first example over here. Let's imagine this example is time of day schedule. You're running some in-house business applications. For example, you're running, you have ticketing tool that you're running. Fine. Maybe Microsoft 365 applications. For your business, you're running in-house business applications. Now, during business hours from 9 a.m. to 6 p.m., your employees will be using your business apps the most. Fine. So in this case, you need 100 instances. To support your business applications, you need 100 instances. But after 6 p.m. till 9 a.m. next day, very few people will be working from home. Maybe you have customer support who will be working in night. So you need very less number of instances. So it can shrink the capacity from 100 to 10. So it's minus 90. So it will stop. I would say stop. It will terminate 90 instances and just have 10 instances being running. Fine. And the next day after 9 a.m., it will grow back to the same size. Fine. So during main business hours, you have more instances. During out of business hours, you have less number of instances. So it can automatically launch, or I would say launch or terminate these instances based on the time frame that you mention over here. Fine. Let's take another example. Let's imagine you're running an e-commerce platform. Let's suppose you're running Flipkart, right? You have Flipkart as a business. During normal days, you just need 100 instances. But let's imagine you're running some big promotions. You're offering huge discounts on your products during Christmas. Fine. So in this case, you expect that during Christmas sale, because you're offering 20% discounts on your products and the cashback offers and all kind of stuff, you expect a lot of users will come in. So from 100, you grow up to 1,000. You're adding 900 more instances. So what you're doing is that you're growing the infrastructure. But once the sale is over, after 25th of December, you shrink back to the normal size. So it's the ability to grow or shrink your infrastructure based on the time of day. It can be the dates that you define or the exact time you define. Okay, this comes under the schedule-based actions or time of day. Fine. Let's take another example. Let's imagine that what happens is, okay, so for example, let's imagine that you group this test together in the form of something called auto-scaling group. What is an auto-scaling group? It's a logical collection of identical instances. The instances will have the same hardware and software capabilities. You set a metric, a parameter, that if the overall CPU usage of the average CPU usage or the CPU utilization is more than 80% or equal to that, then add 3 more instances. Okay. Now, when the auto scaling has to launch something, that's called a scale out action. You have to remember this thing. If auto scaling, hang on one second over here. If auto scaling has to launch something, it is called as scale out action. Scale out action. Launching means that it's scale out. So if the CPU usage of these instances is more than 80%, I'm saying initiate a scale out action and add 3 more instances in this group. But if the CPU utilization is less than 30%, terminate. Now, if the auto scaling has to terminate the instances, it comes under scale in action. What's that? It's a scale in action. Fine. So what is scale out? Launching the instances. Fine. Launching instances is scale out. And what is scale in? Terminate the instances. You have to remember this thing. Fine. So I'm saying that if the CPU usage is more than the threshold, initiate a scale out event and add more instances. On the other hand, if the CPU usage is less than a specific threshold, for example, less than 30%, then terminate the instances. We don't need the extra instances now. So it will remove 3 instances from the group. Fine. Okay. Now the question comes in: who decides that these instances should be identical? Basically, the instances should have the same AMI, same instance type, same security group, same storage options, and same key pair. What you do is that we put them in a template that's called the launch configuration. So the launch configuration or the launch template consists of these parameters. These parameters are being picked to deploy the instances inside the group, so that the instances will have the same AMI, same instance type, same security group, same storage settings, and same key pair. You have to create a template and put all the parameters in a document. Fine. This is what the concept of the auto scaling is. Now, I understand that it's a bit complicated topic, but once you start practicing, once you start doing the hands-on, it's very, very easy. That unhealthy instance which was not running properly, it's being taken out of the service. It never comes back. For example, a company has employee strength of 1,000 people, right? They expect that during night hours, maybe out of 1,000, only 50 or 100 employees will be working at night. Fine. If there's a possibility that suddenly there's a spike of out of business hours users going from 50 to 500, then they have to see that what could be the main reason. Fine. You have to find out those days based on your past experience running the business, then when and how the traffic will grow after the business hours. Generally, from my experience, it never happens, because the companies follow a very similar pattern when they start working. But if you find those areas, then in that case you can change the configuration. The best thing about the auto scaling is that if you think that there's an increased demand out of business hours, then you can change the number of instances in the configuration, and it can grow up based on the configuration that you specify. Fine. When you run any application, you expect that how many users will come in, and on an average, how many instances can be used to serve those customers. Fine. So you run some tests at the backend, some load test, see that if let's suppose 10,000 users are sending the request to your load balancer, how many instances you want, so that there's no latency. Basically, you want very minimal latency, right? So load balancer will show you the latency values. If the latency is very low, in this case, this means that you're running exactly the number of resources that you should be running. Fine. So how much resource can be used in auto scaling depends upon that how much traffic is coming in and how much traffic needs to be distributed to the backend. For example, I hit refresh and Intellipaat takes me to some other page, or to, for example, I go to a different website, maybe Google or Facebook. It should not happen, right? If I hit refresh, every refresh means that I'm sending a new request. Fine. So any new request can land to any of the instances at the backend. Even Intellipaat is using AWS. Intellipaat is using AWS to run its web-based infrastructure. These pages are identical, running on the web applications, and these instances are what I would say is that these instances are running in the background, which are serving you the same web pages. So it's not about mandatory or not mandatory. This is the requirement that we have to have. So the answer is somewhere yes, it is mandatory to have the instances to be identical. Auto scaling works on horizontal scaling. Vertical scaling is not the part of. I would say vertical scaling is not possible through auto scaling. Vertical scaling is not supported. So guess what we're going to be doing is that we'll be doing the hands-on. If you start doing the hands-on, you get a sense of it. One thing you need to understand that we are learning the solution architect curriculum. Don't expect that it would be super easy. Okay, there will be. I see the thing is that learning is hard. If you're learning some advanced concepts, there is some struggle in the beginning stage. But once we start practicing these concepts in the live session, you will start making the sense of these different concepts. So let's start with the hands-on, guys. Now, again, as I said before, you'll be able to better understand this topic if you do the hands-on. It's a bit complicated topic, but becomes easy once you complete the hands-on. See, the document is scaling the instance based on the monitored CloudWatch metrics. What do you mean by that? Basically, we're going to be using the mix and match of different services like instances, load balancers, auto-scaling, CloudWatch to automatically increase the number of instances if there's a peak in demand. Let's take one example. Let's imagine that you're running a Hotstar-based OTT platform. Right, Hotstar is one of the popular OTT platforms, and for example, they're streaming a FIFA World Cup match. Right, the FIFA World Cup match, and they expect that because the match will be streamed through their platform, millions of customers will be joining in and streaming the videos or the match, the live match. Now, they want to serve the customers with no latency. They want to make sure that there's no latency. They want to offer the jitter-free experience to their customers. Or for example, let's imagine you're running an e-commerce website like Amazon.com, Flipkart, Alibaba, and during some sale periods, during big promotions, sales going on, you expect that the number of users coming in will triple or quadruple, or they will increase multifolds, who will be trying to access your website. To take care of that requirement, you'd be using the mix and match of all these services: CloudWatch, auto-scaling, EC2, and load balancer, to automatically increase or decrease the number of instances based on the increase or decrease in the demand. Fine. So what you're going to be expecting from this hands-on, the expected deliverables. You have to use auto-scaling to manage instances and capture the metrics in the CloudWatch. So based on the CloudWatch metrics, it will increase or decrease the number of instances. For example, we have discussed the example of CPU utilization. We have discussed that, right? Let's put that into practice. Now, these are the 9 steps involved, including cleanup. And what's the first thing we are supposed to do? The very first thing that we're supposed to do is we have to deploy a demo web application upon the instance. Okay. Now, why we're supposed to do that? What's the purpose we're going to be achieving from this thing right away, right now? See, what we're trying to achieve is that we are trying to ensure that our instance can deploy the same software upon them. So when we deploy a web application, we'll capture the image out of it. That image would be captured in the second step. Before that, we'll create a web application or deploy the web application upon the instance. Okay. Now you have to launch instance using a bootstrap script. This is the same script that I've shared with you right now. If I open this script, this is the same script that we have used in the time of instance deployment. If I show you this thing right away, here we go. This is the same script that we have used for this instance deployment. This script will install the Apache PHP web application upon the instance. So it will update the instance, install the HTTP Apache upon it, configure the service, go to its HTML folder, and put this text inside the index.html file. Fine. Now what you have to do is that I show you the step from 1 to, let's go from 1 to 14. Fine. I'll show you the steps and see what I'm doing. Then I'll give you sufficient time to do it by yourself. Okay. So this is fairly easy. You have to go back to the instance dashboard. Let's go back to the EC2 service. Right. Once I just go to the EC2 service, I go to launch instance again. Just the launch instance. Then once I just go to the launch instance dashboard, the next thing that I'm supposed to do is that now there's no need to tag the instance. There's no need to tag the instance. You can just make sure that you accept the default AMI. Don't change it. Don't change the instance type. Now in the key pair, choose proceed without the key pair. Even though it's in the bracket, it says not recommended. But because in this case, we're just launching the instance for the getting the image out of it. So technically will not connect to the instance by SSH. So you can choose key pair login, which is proceed without a key pair, because we don't need the key pair in this case. There's no requirement to perform the key pair. So you choose a default AMI, you choose a default instance type. In the key pair login, choose proceed without a key pair, which is set to not recommended. But it's okay because we just have to get the image from the instance. Now make sure that you have this create security group showing up. You can choose allow HTTP and HTTPS both if you want, or you can simply choose allow HTTP. It's purely your choice. You scroll down, go to advanced details. Under user data, what you have to do is that you have to copy and paste the script. Now make sure that you copy and paste the script from the notepad. Don't do that from the browser, right? So go ahead and click on launch instance. And then once this instance is launched, using its public IP, you need to access the instance's website. So I click on this instance ID right now, and you will see that after a few seconds, instance will launch itself, and I can access its website using its public IP address. So if I just go to the instance right now, I have the public IP address. After some time, I shall be able to access the website. Please perform the step. We don't need to connect to the instance. Because we don't need to connect to the instance, that's why we don't have to SSH to it. As an output, what is supposed to get is that if you just copy the public IP address of the instance and paste that in the browser, this is what you're supposed to get, right? What we have done this thing that we have deployed using a script. You have deployed a simple Apache web application upon it. What we have done, we have deployed a simple Apache web application upon it. This is what we have achieved. Okay. Now I want that when the auto scaling launches the instance or instances, it should use the same operating system, same web application running upon them. Every instance that the auto scaling can deploy in the future will have the same operating system, Amazon Linux 2 AMI, and the same web service that I've just deployed upon it. Fine. So in this case, we'll create a custom image. Custom image means that auto scaling will see, basically, the custom image will ensure that when the auto scaling launches new instance, the instance automatically install that web service, this web application upon it. We perform this manually using the script. Fine. Now, we'll say that when a new instance gets deployed, this web application is being launched upon every instance automatically. Because of this, we will. Now, the main thing is that you should get this output. If you're getting this output, this means that now you can go to the next step. The next step is 15th step. In the next step, which is 15th step, we have to create a custom image. See, basically, after you customize instance to suit your needs, you create and register a new AMI, which you can use to launch new instances with these customizations. The custom image will be included as a part of a launch template to be used with autoscaling. We want the instances to be launched with the same customizations, right? And this custom image would be included as a part of autoscaling launch templates. To make it very simple as if now, because it will confuse you, we want that autoscaling when it needs to launch some instances, it will deploy the same web application upon the instances automatically.
Just a quick info for all of you cloud enthusiasts. If you want to make a career in AWS, then you might want to check out Intellipaat's AWS certification training course for solution architect. Learn from industry experts through hands-on session, projects, and case study. Reach us out to know more.
Now, one thing I want to tell you, this is a one-time cost you have to pay, which will cost you, I think, almost, 10 to 15 cents. It will cost you because image is not free of cost. The cost of image creation is one time in that month. This is the month of November, right? So for the month of November, for the November's billing cycle for November, you have to pay 15 cents. It's a one-time cost. The cost of this AMI is a one-time cost, which will cost you 10 to 15 cents. So in this case, I'll show you step number 15. See what I'm doing. I just go back to the instance dashboard. My instance is running. I go to actions, go to image and templates, and click on create image. Then it says enter the image name and image, for example, Apache HTTPD image. I can put a description. This is a custom image to be used with autoscaling. Fine. I put a description over here. Now, when you take the image from any instance, it takes a backup of its storage in the form of snapshot. You don't have to change anything over here. Simple, go ahead and click on create image. Now it will take 3 to 4 minutes and your image will show up. If you just go to the AMIs on the left hand side, if you go to AMIs, you will see that your image will show up over here. You can see that right now it says pending. After some time it will be available. So there's a one-time cost of 15 cents, 10 to 15 cents you have to pay. Otherwise the rest of the components that we will deploy are free of cost. Only this image creation will cost 10 to 15 cents. Rest of the things are free. Image is AMI only, Amazon Machine Image. Amazon Machine Image defines the software configuration of your instance, including the OS and the services running upon it. So in this case, what's the operating system we're using? Amazon Linux 2 AMI. And what's a service that we have deployed upon it? The Apache PHP web application. Now this custom image will include the OS and the custom web service that we have deployed upon it in a custom image package. So image is nothing but it's an Amazon Machine Image. It consists of all the software parameters of the instance, including the operating system, applications, and services bundled together in a package. Now, if you see that after a few seconds, if you hit refresh, the state of this image will be available, right? Just in case if it's not, you hit refresh on the top, it should be available, right? If the state is available, now you can go ahead and you terminate this instance because this instance is no longer needed. The purpose of this instance was to just deploy a web application upon it and get a custom AMI from it. This AMI, if you go to images on the left hand side, this AMI will now be used by the autoscaling to deploy an instance with the same application running upon them. Same, so the software configuration of all the instances would be the same. So you can have once the AMI is available, you can choose an instance like this, go to instance state, and you can safely terminate the instance. Right? You can, so this is important. So after the AMI is available, you can terminate the instance. What I'm saying is that once your AMI is available, we don't need this instance anymore. The purpose of this instance was just get the image out of it. We got the image. The purpose of this instance is over. You can safely terminate this instance if you want. If I go with the document, it's over the document right now. So we have done the first two major steps, or we have done, let me show you that exactly. So the first thing is that we launched one instance, and at the same time, we launched a demo web application upon it using the script. After that, we extracted the image out of it. Fine. So these were the two things that we performed. These were the two things that we performed. The next step is that now you have to start working on the deployment of the load balancer. Right? We discussed what's a load balancer. A load balancer is a component that takes incoming request from the front-end users and distribute it equally across all the backend servers, all the instances that are running. So it performs the load balancing or the equal traffic distribution of the or I would say it performs the traffic management, or it ensures that it equally distributes the traffic across every single instance that runs at the backend. Fine. So it's a service that uniformly distributes the traffic and workloads across multiple servers or a cluster of servers. So the thing is, we want that these instances, which are identical in nature, should be grouped together in a target group. What's that? It's a target group. Now, what's a target group? Target group is a grouping of similar targets. Targets can be instances, your Docker containers, your on-premises servers, and so on. Fine. So in this case, we first create a target group, a group of targets, and these target groups register themselves to the load balancer. What they do is that they register themselves to the load balancer. So you have a target group, a group of targets. These target groups, the group of targets, register themselves to the load balancer. So what is this? This is LB, this is the load balancer. Now, in this case, first thing first, what we're going to do is that we'll create a target. Now, we don't have any instance as of now, right? The instances will be launched by the auto scaling. But we just create a target group first. Before the instances are launched, we create a target group. So in this case, if you just go back, you can see over here. Each target group is used to route request to one or more registered targets. So in this case, I'll show you the step number from 16, and we'll just go up to 20. Fine. So show the step from 16 and 20. Once I just go to the EC2, you will see that on the left-hand side, you have a bunch of options. The option that we're looking for is this one, which is the load balancing, load balancers, and target groups. Click on the target groups first, and then this opens up. I already have a target group created, so I'm going to just remove it because I don't need it as of now. Okay, anyhow, so just give me a few seconds. I think I have a load balancer running. Yeah, let me just remove it. I don't need this as of now. Fine. So in this case, I click on, just try one time. All right, here we go. So I just click on create a target group. Now, as a part of basic configuration, it will show me that the targets are your instances. These are the on-premises IP addresses of the on-premises servers. Lambda function, we'll discuss that afterwards. It's an advanced feature. Or maybe you want to link it with a different load balancer. Fine. So a target group, you can see that your load balancer requests to the targets, routes requests to the targets in a target group and performs health checks on the targets. So the targets can be instances, the on-premises servers, Docker containers, Lambda functions, and so forth. So in this case, I choose instances, which is the default one, and we name it as, for example, HTTPD target group. Fine. Now, the thing is, let me start from scratch. I think I did make some mistake over here. Yeah. So in this case, I name it as HTTPD target group. Fine. Now it will ask you that what's the protocol and port? What's the type of traffic that will hit your instances? I will go with HTTP port 80. You don't have to change the VPC, don't change the protocol version. The main thing is that you have to configure the health check. What's a health check? Health check means that, if you remember, we discussed that the health checks have been performed because the load balancer wants to ensure that it sends requests to the healthy instances, and if the instance is healthy, it will respond back with a 200 OK message. Now we have to give a ping path, which means that we want the load balancer to initiate the HTTP ping message to one of the pages of your website. Now, in this case, if you remember, we use a script. Let me show you that. Right? This is the script we used. This is the script we used. In this script, you will see that we have the index.html page configured. What's that? This is the index.html page configured. Now we'll be sending the HTTP ping messages to the index.html page. We'll be sending the HTTP ping message to the index.html page. Fine. Popular saying is mandatory. Yes, it's mandatory. Otherwise, your instances will be declared as unhealthy. Okay, you have to give it a path. Basically, you have to instruct it where should be sending the ping messages to. Fine. Now, this should be a ping. This should be a health check path or ping path. This is important. The health check path should be. Let me just copy and paste this for you. /index.html. Right now, this is case sensitive. Please make sure that you don't include lower cases. Upper cases. I'm not sure why people include upper cases in these configurations. Make sure that the index.html, the /, so you put a / and index.html should be in lowercase only. Don't include upper cases. Please don't include upper cases. Fine. So the load balancer should be sending the HTTP ping messages to the index.html page. Go ahead, click on next. And now it says, do you want to register any targets as of now? The targets will be registered afterwards once we deploy the auto scaling. Simply click on create target group, and that's it. If you go by the next step, we have to start with the load balancer creation. So I show the step from 21 to, let's go up to 24 only. So I go a little bit slow over here because this is the very first time we are going with the deployment of the load balancer. So I'll go a little bit slow over here. Now, once the target group is created, on the left-hand side, you can see that it says load balancing and load balancers. Let's go over there, right? Click on create load balancer. Now, we haven't discussed the load balancer types, but I'll discuss with you right now. See, these are the different types of load balancers which can be used in different conditions, conditions. For example, application load balancer is generally used for web applications. So if the two protocols you're working with, HTTP and HTTPS, so only only two protocols that you're looking for, then you go with the application load balancer. It's a very advanced load balancer with very advanced capabilities, can be used for microservices and even Docker containers. Network load balancer is used in those cases when you want to include almost all the protocols. Fine. Also, it is one of the fastest and highest performant. I would say this gives the highest performance. Network load balancers are designed to handle millions of requests each second, right? It has a capability of handling millions of requests per second while maintaining ultra low latencies. Fine. So the network load balancer is the fastest, but it's the costliest. Gateway load balancer is used for third-party virtual appliances or third-party virtual machines. Still not I've seen that being used that much. Most of the times you're going to be using application, or I would say at max you're going to be using network load balancer. Fine. In our case, we'll be choosing or using the application load balancer. Scroll down, click on create. Now, the very first thing is that you have to assign a name to it. Just name it as HTTPT Apache, for example, load balancer. Fine. Scheme would be internet facing because our load balancer would be facing the internet. So by default, we go with the internet facing scheme. IP address type. IP address type means that the machines that would be registered with the load balancer, are they having the IPv4 addresses only? Or if you just go with the dual stack, there's a combination of the IPv4 or IPv6 addresses you're using. In our case, we are only using the IPv4 addresses. So we just go with the default value. Okay, so you just have to name the load balancer. Please don't change the scheme. Please don't change the IP address type. Don't change these values. Under network mapping, you don't have to change the VPC. You have to simply select all the AZs over here. So check all the AZs in this case. Now, why did I select all the AZs in this case? Because I want the load balancer to route request to every instance in these AZs. Now you can see that in this AZ we have subnet. Subnet is nothing but it's a grouping of multiple instances. It's a small network. So I'm saying that the networks which belong to my AZs, the instances inside those AZs must get the traffic from the load balancer, right? So so in our case, we select all of them. Now, as per the best practice, you should select at least 2 AZs so that you can achieve high availability, right? At least 2 AZs need to be selected, but yeah, at least 2 AZs, not less than that, and you can go with more. So in our case, we'll be selecting all the AZs. Fine, we'll be selecting all the AZs. So you have to perform the step 21 to 24. The next thing that you're supposed to do is that I'll show the step number from 25 and go up to 30. Okay, so what is supposed to be done? If you go back over here, the next thing that you're going to do is that you're going to apply a security group to the load balancer. Okay. What is a security group? It's a virtual firewall that you link with the instances, and even in this case, it can be linked with a load balancer. Now the question comes in that why do I need to link my load balancer with a security group? The answer is very simple, because load balancer would be receiving the traffic from the internet. We want that the traffic that's coming towards the load balancer or going out of the load balancer should be secure enough. So in this case, you have to create a new security group while including the HTTP traffic from everywhere rule inbound, and apply that security group to the load balancer. So what's the approach over here? You click on, there's an option. Now, please pay attention to what I'm saying. Don't rush, because this is where people get confused. You click on create security group. A new page opens up. Okay. Then you have to name it, for example, name it as Apache Web LB, or I would say load balancer security group. Fine. I just copy and paste the same in the description. Now you don't have to change the VPC. The main thing that you have to do is that you have to include the HTTP traffic from anywhere. You have to include the HTTP traffic from anywhere. Scroll down and add a tag over here, and just add a tag to the load balance, this security group. So what we're trying to achieve, we are trying to create a new security group that will be assigned to my load balancer. Now the same one I'll be assigned to my instances as well. And we want to allow the HTTP traffic inbound from everywhere. Okay, so I click on create security group. My security group gets created. Now people get confused because they get lost in this way. You have to go back to the previous tab, right? And there's a refresh button. Refresh it and search for the security group that just got created, and cancel the one out which was labeled as default. So you can see that there's a default security group, this one. It has to be canceled, or it needs to be removed. Fine. So in this case, I cancel it, and this applies the new security group to this load balancer. So again, I repeat this process. You click on create new security group. A new page opens up, a new tab opens up. You have to create a new security group. Come back to the previous tab. There's a refresh button over here. Hit refresh. Apply the new one and remove the default one. So guys, it's clear as if now what we have done is that we have deployed a load balancer along with the target group. Fine. What's next? The next thing that we're supposed to do is that we have to create a launch configuration, right? What's launch configuration? Launch configuration is a template that the auto scaling will use to deploy its instances. Fine. See, whenever we want to automate the things, we have to put the parameters in a simple document. The document name is called a template. Now, this template is called a launch configuration. It's a very, very easy process to create it. See what I'm doing? I'll explain the few steps, and then I'll give you sufficient time to do it on your own. So you can see that a launch configuration or a launch template. Now, what template I'm talking about? If I go back to the notes that I shared with you, let me just go back to the notes. One second over here. I discussed with you this fact is the fact that I discussed with you was that whenever the instances need to get launched by the auto scaling automatically, they're supposed to be getting the information or the parameters pulled from the launch template or the launch configuration. So a launch configuration configuration is the instance configuration template that the auto-scaling group will use to deploy the instances. Fine. So I'll show you the step number from 34 and take you up to 37. You go back to the browser. On the left-hand side on the EC2 dashboard, just under the load balancer, you have this thing called auto-scaling launch configurations and auto-scaling groups. I go to auto-scaling launch configurations, right? And I click on create launch configuration, right? What's that? Create launch configuration. Now, once I do that, the next thing that I'm going to do is that I'm going to assign a name to it. I name it as HTTPT launch configuration. Fine. Now, the very first, so it's kind of a checklist. Auto scaling will use this checklist to deploy the instances with the same software and hardware configuration. So I choose the AMI. Now, which AMI will I choose? The same image that was selected or that was launched in the second step, which will come under my AMI. So under AMI, pick the image that you created that asks you to preserve it. Under instance type, click on choose instance type, and then you have to search for which instance type, T2.micro. Choose it and click on choose. Now we will not go with the additional configuration, will not change the EPS volume. The main thing is that we have to click on select an existing security group and select the same security group that you have created for the load balancer. The same one will be also assigned to the instances as well. And under the key pair login, choose proceed without the key pair because we don't need to SSH to these instances. Fine. So what we're trying to do over here is we're creating a launch configuration, a template with the custom image, T2.micro instance type, a security group that needs to be applied to every instance, and that's it. And also, we don't we are not generating any key pair for this hands-on. Click on create launch configuration, and this result in the creation of the launch configuration or the template. So we have done almost most of the steps. Only the last step is left off, which is a bit lengthy. Okay. In the last step, what we have done is that we have created. What we have done is that we have created a template that's called the launch configuration. Fine. Now, through this template, we'll deploy an auto-scaling group. The instances launched inside that group will pick up the same configuration. Fine. So this process is lengthy. Then we're gonna test it, and that will be the main agenda of this hands-on, to test whether the auto-scaling functions when the demand goes high or not. The next thing that I will discuss is how to create an auto-scaling group. What is this? Basically, an auto-scaling group is nothing but it's a collection of identical instances. The instances are the instances need to be put in the auto-scaling group, and the auto-scaling group will consist of the instances, and the instances will increase or decrease automatically within the auto-scaling group. You can see that. An auto-scaling group contains a collection of instances that are treated as a logical grouping for the purposes of automatic scaling and management. Now, in this case, what you're going to do is, let me show you. Go back. Once you go back, choose launch configuration that you created in the previous step. Go to actions and click on create auto-scaling group. So I'll show you the bunch of steps. Step number 38. And yeah, that's it, 38 and go up to 41. Click on create autoscaling group. The very first thing that I'm going to do is that I'm going to assign a name to it. I name it as, for example, HTTPD Apache ASG. ASG stands for autoscaling group. Now it says that you can also use launch templates instead of launch configuration. Launch templates, it can include some more details. We're going to discuss them afterwards. But right now, we'll be launching this instance by picking the parameters like the AMI, security group, and instance type from the launch template or the launch configuration. Click on next. Now it says which of the AZs must contain your instances. So choose all the AZs. So autoscaling will automatically launch instances. If there are multiple instances need to be deployed, those instances will be distributed across all the AZs. Fine. Click on next. Now it says that, do you want to attach load balancer with this autoscaling group or not? Choose attach, and then choose the target group of the load balancer, right? So what we're doing in this case is we are merging load balancing service with the autoscaling service. We are merging load balancing service with the autoscaling service. Health checks. We choose ELP so that the load balancer will perform the health check for every instance. Health check grace period is 300 seconds. What is this? Basically, it's the amount of time that we give to the newly launched instances to boot up and be in service before the health check can be performed. We can see that it's the amount of time until the autoscaling performs the first health check on new instances after they're put into the service. So we want the autoscaling or the load balancer or both to test the instance after 5 minutes, because 300 seconds defaults to 5 minutes and wants to 5 minutes. So we're saying that after 5 minutes, since this test is deployed, it is in service, then you perform the health check. And that's it. We'll not go with the additional settings. Click on next. I'll show the step number from 42 and we'll go up to 50. See, the thing is that when you set out an autoscaling group, the very first thing that you're supposed to do is that you have to set the group size. And in the group size, you set the capacity. What's the capacity? Capacity equals to number of instances. Now we keep the desired capacity and minimum capacity as same, which is what's a bare number of instances, healthy instances running to support your application. So in this case, we put 2 as a desired, or minimum capacity is the same thing. So we want that we should have a minimum of 2 instances running inside our autoscaling group. Okay, what's next? What's the maximum capacity? What's the rooftop capacity? We'll make it 4. This means that autoscaling will increase up to these many instances if there's an increase in the traffic load or increase in the demand. So we're saying that we need minimum of 2 instances and maximum of 4 instances. Okay. Having said that, we scroll down and then we have to specify that what are the conditions that should trigger increasing or decreasing of the instances. I discussed this thing with you that if you want to launch instances or increase their count, you initiate something called scale out event. Scale out means you want to launch the instances. What's a scale out event? You want to launch the instances or increase their numbers. Opposite to it is scale in. Scale in means that you wish to terminate the instances. The instances need to be terminated or subtracted. So autoscaling can launch or terminate the instance, not stop them. Either it can launch or initiate a scale out event, or terminate or initiate a scaling event. So the scaling policy means that what are the conditions that need to be fulfilled, based on which a scale out event or a scaling event can be triggered. So in this case, if I scroll down, you choose target tracking policy. In the target tracking policy, you can choose any one of these CloudWatch metrics. We can go with average CPU utilization, number of packets coming in, number of packets going out, and the last one is how many requests one target can handle at any given moment. You can see that. Application load balancer request count per target. What's a target? That's instance. So if we start with 2 instances to start with, in total, we should not have more than 4 requests going on. Fine. So on an average, per instance, should get only 2 requests to process. If it, for example, or 2 requests or 20 requests, for example, if I just go with application load balancer request count per target, and I choose the target group of the load balancer, I'm saying if I set the target value to 50, that at any given point of time, each instance should not get more than 50 requests to process. If it gets so, then in that case, please increase the number of instances from 2 to 4. Fine. So in this case, what happens is we choose a metric type application load balancer request count per target, which means that at any given moment, for example, if I set the target value is 50, we start with how many instances to start with? 2, right? So on an average, 50 requests should be landed to every instance. For example, I have this first instance and 50 requests going to the second instance. So what's the average of requests going on? 50. As soon as they increase in numbers, for example, from 50, they become, let's suppose 60, and this becomes 70. Then please increase the instances from 1 to 4. Add 2 more instances because we've set the maximum capacity as 4. So the average aggregate of 2 instances, the request is 50. Once this gets increased in number, then I can increase number of instances from 2 to 4. Fine. So in this case, because we want to get a faster output, let's make it as 2. I'm saying that as soon as the number of requests per instance goes more than 2, then please increase the number of instances from 2 to 4. Then in that case, it will not go further, Rita. It will not go further. Okay, because that's a maximum capacity you have set in. That's the maximum capacity you have set in. If it means plus 2 instances will up after reaching the limit, absolutely. It will go from 2 to 3, then to 4. So it will increase gradually. So in this case, you have to set the target value as 2. So the target value is 2. And then we give an instance warm-up period of 300 seconds, which means that we give that much of time for the instance to boot up. Fine. Click on next. There's no need to add notification. Click on next. You can add a tag. You can add a key name, and for example, demo AHE instance. So the same tag is assigned to every instance. Click on next and click on create auto scaling group. Now, once we initiate this thing, you go to the auto scaling group, go to the activity, and you will see that now it will start with the minimum instances, which are 2. If you click on the auto scaling group, go to the details, scroll down, click on this thing called under load balancing. You can click on edit, right? And you can select the target group, right? So you have to click on your auto scaling group, go to load balancing, and click on edit. If you just go to the activity, you will see that it has deployed 2 instances. What's next? Let's test the deployment. I show the step from 51, 52. I would say I'll show the 51 to 56. See what I'm doing? You need to access the application by going to the load balancers on the left-hand side, right? You need to select the DNS name of the load balancer. Now I discussed with you, the users will be sending the request to the DNS name of the load balancer. You copy it, and then you just paste that in the browser. Fine. So in this case, through the load balancer, you'll be able to reach your website. Let me show you that. Firefox is not responding properly. Let's do it one more time. I paste it, hit refresh, and now this load balancer takes me to one of the instances at the backend. Now you hit refresh, you may be going to a different instance this time. You can't see that, but now the thing is that you have to hit few refreshes. Hit 30, 40 times, and you will see that it will eventually, after 5 minutes or so, will increase the number of instances automatically. So you hit few refreshes because you're sending the amount of traffic. You're sending the amount of traffic to the load balancers page. This is going to the backend instances, the targets. If the number of requests count per target, because we're sending the request is more than 2 at any given moment, auto scaling will initiate a scale out event and increase the number of instances. So I'm sending some requests from the front end. Please perform the step 51 to 56, hit few refreshes, and this will eventually increase the number of instances automatically at the backend. Hit few refreshes, 30, 40 refreshes. In next 5 minutes, it will increase the number of instances automatically. If you go to activity, so you can just open that in a new tab, the auto scaling activity, and you will see that within the next few minutes, it will 2, 3 minutes or 4 minutes maximum, 5 minutes, I'm sorry, it will increase the number of instances. Now, can you see that under activity, if I go, it has launched 2 instances in my case. Guys, please check my page, what's happening. It has launched 2 new instances because I hit few refreshes. The number of requests count per target hit, it went above 2. And then you can see that my number of instances increased gradually. In this case, I'm just trying to access HTTP site only. It's not opening up. So this means that the auto scaling was not configured properly. Because if you just go to the activity and see the you will see that your instance will fail eventually, or they will be terminated. You can see that when you, for instance, warm up, in next few minutes, the instance will be in service and be a part of the entire infrastructure. Even though you're using free tier resources, because you have 4 instances running, you'll exceed the 750 hours limit that you can get a month. You have to go to the auto scaling group, choose the auto scaling group, and click on delete on the top. And to confirm, just type in delete and just type in delete and click delete. Please delete your auto scaling group so that you are not being charged if you exceed the 750 hours free limit for running Linux instances. So first thing first, delete the auto scaling group. Let me know what's done. Under AMI, you have go to Elastic Block Store and go to snapshot. Now, when you take the image, it takes a snapshot of the volume of the instance. Now you have to choose the snapshot. You will see that in the description, it will show you as created by create image. Can you see that, right? You have to select it. So you have to go to snapshots. So under the Elastic, so snap shots, then you have to choose a snapshot, choose snapshot, right? Go to actions and click on delete. Go to snapshots. This snapshot is of 8 GB, which was created at the time of image creation. That backs up your image files. You have to choose it, go to actions, and click on delete snapshot. And click on delete. It's been removed. See that. This also deleted to the CMI. Don't need this. Okay. Now it is safe for me to delete the image. Snapshot, I'm sorry. Gone. And also, let me just delete this snapshot. S3, CloudWatch, and VPC. So S3, CloudWatch, and VPC, these are the topics that we are supposed to discuss. We discussed the concept of load balancer and auto scaling. Fine. So ELB and auto scaling was discussed, and EFS. Discussed ELB, auto scaling, and EFS. Yeah, these 3 topics were discussed. This is the hands-on document that we have performed, and this is what we have done. We'll be picking up S3, simple storage service. Now, S3 is fairly simple to understand, and it is really important. I would say that the few concepts that are very important in terms of the business use cases, because you'll be using S3 a lot for backing up the data, archiving the data, and so forth. So we're discussing all the use cases of the S3, say the implementation of those use cases. So we'll discuss all those things. So let's get started. So S3 stands for Simple Storage Service. S3 is an online cloud storage. What do you mean by online cloud storage? Online cloud storage means that you can upload files, images, folders, songs from a machine, from a computer, and you can access them from anywhere in the world. For example, we have Dropbox, OneDrive, iCloud, Google Drive, right? So these are the very popular online cloud storage platforms that we use nowadays to store our contents. The only thing is that we need access to the internet, right? So the files from machines can be easily being saved to any one of these different storage options, and you can easily access these files. Fine. So in terms of the online cloud storage, it is very, very important that we discuss the S3, the stands for Simple Storage Service. Simple Storage Service is also an online storage, much like Dropbox, Google Drive, Microsoft OneDrive, iCloud, that can be maintained and accessed over the internet, right? It's a web service that can be used to store and retrieve untold quantities of data. You can store any amount of data that can be accessed using APIs, or for example, you can make use of the S3 interface to store or download the contents from. So the purpose of the S3 is that it's an online backup storage, very convenient to use, and you can back up the data and you can access the data from anywhere on the web. All right. So in terms of S3, I'll discuss with you a few simple concepts using my whiteboard experience, using the iPad, and then we will take it further. So in terms of S3, you need to understand some important components to start with. Components include the buckets, the objects. So I'll discuss all those things with you. In terms of S3, you need to understand that to store the data, the main thing that you need is a bucket. Okay, let me just connect my iPad. All right, so in terms of S3, the main component that we have to understand is called a bucket. It's called an S3 bucket. Fine. So what I was discussing in this case was that in terms of the S3, that there are two or three main things you have to understand. The concept itself, there are two things we need to discuss in depth. One is the components, and the other one is the use cases. First thing first, let's discuss the use cases first. Why are you going to be using this concept called simple storage service? So these are the features. I'm talking about the use cases, the benefits. It can be used if you use it with content delivery. First thing first, it's used for backup and archiving. So any data which needs to be backed up or archived, you need a storage for that. It can be any data, application data, log data, your files internally. So backup and archiving are the two main things why we use S3. The second thing is that it is used for content delivery. Content delivery means that you want to share the content with your users. That content can be shared using S3, right? Now, if you might have observed this thing, whenever you go to Intellipaat's LMS and try to download the PDFs, it is the bucket name live LMS ip.s3.amazon. So basically, this is the link that it generates, right? This is the S3 link. Now, what is Intellipaat is doing is that it is delivering its content through the S3 bucket storage. Whether it's a LMS videos, it is the PPTs, it is being delivered to you through their website, but the content it's being stored where? In the S3. You can see that in the link itself, you can easily detect that it's being fetched from the S3 packet. So the content delivery is one of the things. Content delivery, content sharing, you can see the same thing. Is being done using S3. Whether it's a videos, it's a photographs, any type of content can be delivered through the S3. Fine, you can just create some links of your content, and you can share your content through your website, or directly you can just share the link. Fine. The next thing that it's being used for, and I just got that input as well, is the logging, or I would say storing your logs. Right? It can be audit logs, troubleshooting logs. Whenever you store any logs, they have to be saved somewhere. The logs can be easily stored in the S3 bucket. The fourth use case of the S3 is that it can be used as a version control service, or VCS. Version control system or version control service, VCS. Basically, the thing is that it works like GitHub, right? If you enable versioning, on the S3 bucket, you can store different versions of your contents, right? It can be used as a version control service. You can store multiple versions of your content, right? So it works like GitHub as well. It's not that much well advanced, but yes, you can store multiple versions of your contents. The next thing is that it can be also used for something called static website hosting. You can use it, or you can deploy a simple static website upon the S2 bucket, which does not require any server-side scripts. So backup and archiving, content delivery, storing logs, version control system, static website hosting. These are 5 use cases. The sixth is it is used for data migration. Now you must say that how it is used for data migration. Data migration, because it's an online cloud backup storage, you can use it to move your data from on-premises infrastructure to AWS. Fine. You can, or I would say, or vice versa. You can just go from AWS to the on-premises cloud. So you can easily move your data between your data center to the AWS or vice versa. Also, you can move the data from AWS to other cloud domains. For example, Microsoft Azure, GCP, or vice versa. So because it's an online backup storage, you can easily move the data around between different platforms very, very easily using S3. So it is used for data migration. It is one of the, I would say, most robust and very convenient service to use to migrate huge quantities of data from data center to the cloud, to AWS, from AWS to other cloud domains as well. So in terms of data migration, it is one of the most important features that you use. The seventh benefit or the use case of the S3 is the following. It is used for disaster recovery. Right? Because you can keep multiple copies of your data in the cloud, in different regions, you can duplicate the data in AWS. Also, you can have the backup data on premises. It can be used as a disaster recovery strategy. For example, you have one S3 bucket. A bucket is it is the one which contains your data in North Virginia, right? You have another S3 bucket, for example, in Mumbai, right? You have the second bucket that you have. Now, what you're doing is that there's a concept that's called replication or synchronization. You can synchronize your data between these two different buckets. You can sync your data between these two different buckets. Now, if any one of these buckets become unavailable, you can still retain that. For example, your Mumbai bucket goes down.
Just a quick info for all of you cloud enthusiasts. If you want to make a career in AWS, then you might want to check out Intellipaat's AWS certification training course for solution architect. Learn from industry experts through hands-on session, projects, and case study. Reach us out to know more.
So in this case, if any one of these two buckets become unavailable or go down, then in that case, what happens is, so in this case, Virginia goes down, right? Because you have the duplicate data showing up in Mumbai, in this case, what happens is that your data is safeguarded, right? there's very less chance that you may lose your data, right? So for data migration, data duplication, disaster recovery, S3 would be used. Data migration, data duplication, the S3 would be used in this case. Fine. Okay. These are what are the use cases of the simple storage service or S3. Fine. For example, if there's an EFS file system which is connected with the instance, I have to access the instance first via SSH and RDP, and then access the EFS file system of it. But S3 works like Google Drive. You don't have to bypass any boundaries of any machine to access it. Fine. So in this case, it's very convenient to use. You don't have to log into any virtual server to access the storage. It can be accessed directly over the internet. The components of the S3 are the following. Okay. So what are the components of the S3? Components means that what are the building blocks of it? How the S3 is now there are multiple components, but I discussed two main components. The very first component of the S3 is the bucket itself, right? So this is the visual representation of the bucket. So over here, this is my this thing that you can see right now. This is called S3 bucket, or simply put it as bucket, right? Now, what's a bucket? A bucket is nothing but it's a fundamental container, right? It's a simple container that contains your data, right? It's a simple container. It's a simple storage container that can contain your data, right? So this is the basic fundamental block of the S3. That's a bucket. It's a fundamental container. Any data that you put inside the bucket is called an object. So if you put any data in this bucket, now that's called object. What's an object? It's a fundamental entity. What's that? It's a fundamental entity. Fine. Now, a PDF can be it's a file of any format. It can be of any format. It can be a PDF, a PPT, it can be a spreadsheet, it can be anything, right? So it can be, for example, it can be a PNG image, it can be a JPEG image, it can be a PDF, it can be document, it can be an AVI video, an MP3 file, it can be anything, etc., etc., any format, it doesn't matter, right? So in this case, what we do is that we store our data as object inside the bucket. S3 is designed as an online backup storage. So for example, if you want to access Google Drive, you simply open Google Drive, you have the web interface, and you simply access the data. So based on the use case, it doesn't make any, I would say, it is not appropriate to link it with the instance. Fine. So it's designed for a different use case. All right. What's the next thing? Now, a bucket is a container which can contain your data, and the object is nothing but it's a fundamental entity. It's a simple file which can be of any format. What's the next thing? The next thing that you have to understand is that if this is the case, what's the amount of data that I can put inside the bucket? The amount of data that you can put inside the bucket is unlimited. You can store unlimited amount of data inside the bucket. So there's no limit as to how much data you can put in. So you can the storage limit equates to unlimited storage. You can put in any amount of data inside the bucket. There's no limit as to how much data you can put in. However, the size of a single object that you're putting in, a single file, should not exceed more than 5 TB, 5 terabytes. Right? It's very unusual that you have a single spreadsheet, a single picture, a single video of more than 5 terabytes. 5 terabytes amounts to 5,000, more than 5,000 GB, right? So you cannot insert any object more than 5,000 GB of size. Otherwise, you can store as much data as you can inside the bucket itself. So this is what exactly the concept is. So a size of a single object should not exceed more than 5 terabytes. Now, in each account, there's a limit to have, you can have up to 100 buckets. You cannot maintain more than 100 buckets at a time. This is the maximum limit you have. In any account, you cannot have more than 100 buckets. That's the maximum limit. Fine. So these are the two fundamental blocks or the components of the S3. Bucket, it's a container that can contain your data, and the object, it's a fundamental entity. It's a file of any format that can be stored inside the bucket, right? Inside the bucket, you can store the unlimited amount of data, right? And but the size of that single data or the object should not exceed more than 5 terabytes. Fine. It's like we have to pay according to data size. Yeah, you see, basically S3 is all about the data storage. So you have to pay for each GB, each terabyte of the data stored, right? So in this case, the amount of data storage that you've consumed, the amount of data storage that you've consumed, you have to pay for that. Fine. But in a free tier account, in a free tier account, you have a limit of 5 GB each month, right? So this is free of cost, 5 GB each month of worth of storage you'll get to store your contents inside the S3 bucket. Fine. We need to be discussing the properties like versioning and, for example, transfer acceleration, static website hosting. We should be discussing the permissions as well. Under the management, we will be discussing lifecycle rules and application rules. So we'll be discussing some of the properties of the S3 bucket. So let's move on to the next stuff. Let's start with the concept called versioning. All right. First thing first, I'll go to the bucket. Now I have 72 buckets as of now. So in this account, I can maintain up to 100 buckets. Fine. So in each account, I can maintain up to 100 buckets. That's the limit that I have. Now, I just go to create bucket on the right hand side, and it simply gives me the page to create the bucket. I do want, so in this case, what I can do is that I can go ahead and start mentioning the name of the bucket. Okay, let's do one thing. This will also save our time. I'll share a document with you that's relevant to the static website hosting. We can simply just go ahead and start with the hands-on, and I'll explain you a lot of concepts of the static website hosting and the versioning when we do this hands-on. So this is the document. Fine. The name of the document is hosting a static website using Amazon S3. This will help us to understand that how the S3 can be used to host a complete static website upon the S3 bucket. All right. So what do you mean by the static website? What exactly we mean by the term static website? On a static website, the web page includes the static content, right? There's no server-side scripts we are using. No PHP, no JSP, no ASP.NET. It does not support the server-side scripting. If your content is static, it does not change. It's not interactive. You just want to deploy a simple kind of, you can say that a few pages upon the S3 bucket, then you can make use of this feature. Now, in this case, what you're going to be doing is that there are 5 main steps that you have to perform. You have to create a bucket. Now, when you create the bucket at the time, and explain a few things, including the concept like the permissions. What are the things that are important for the bucket to be created? Fine. And then we enable the website hosting, upload an index.html document, make it public, and then we're going to be testing our website. Then we're going to be testing our website. All right. Now I'll show you the step number 1. Step number 1 pertains to creating a bucket from scratch. Fine. It's super easy. But the thing is that because we have to discuss some concepts, I need to make sure that I can elaborate a few important things for you. Fine. So the thing is, whenever you create a bucket, there are few things that you have to keep in mind. What are those few things? First thing first, you have to be aware of the naming convention. Naming convention means that when you start assigning the name to the bucket, when you start assigning name to the bucket, then you need to follow certain protocols and certain rules. Fine. We're going to be discussing those protocols and rules from beginning, right? So in this case, you have to search for the S3. Just type in S3 on the top, and the page appears. S3 scalable storage in the cloud. You can use the search bar on the top and click on the S3 to open the S3 dashboard. Fine. Now, once you go over there, the next thing that it will ask you for is so basically the thing is that you'll be getting a dashboard, right? This will give you the interface to create a bucket. So you click on create bucket, and then it will give you the prompt to assign a name to the bucket. Fine. So the very first thing is that you have to mention the bucket name. There are a few things you have to keep in mind. First thing first, the bucket name should be unique in nature. Understand? Bucket name should be unique, which means that no 2 buckets can have the same name across AWS. For example, if you just type in test and click on create bucket, you will see that it says the bucket with the same name already exists. It's like no 2 people can have this, no 2 cell phone numbers can be the same. No 2 people can have the same Gmail user IDs. Fine. Similarly, no 2 buckets across AWS can have the same name. Across Amazon Web Services, infrastructure, no 2 buckets can have the same name. Fine. So you have to think of a unique bucket name. Now, it can be alphanumeric. It can be alphanumeric. So it can be a combination of different characters. It can be alphanumeric, right? Lowercase characters are only allowed. Lowercase only, and only 2 special symbols allowed. What are the 2 special symbols that are allowed over here? One is hyphen and a dot. And it can be between 3 to 63 characters long. The name can be 3 to 63 characters long. Fine. These are few things you have to keep in mind. when you assign the name to the bucket. So it should be unique. You have to think of a unique bucket name. It can be alphanumeric, only lowercase, no uppercase, 2 special symbols allowed, hyphen and a dot. And you can just choose, or you can put anywhere between 3 to 63 characters. So the very first thing is that I assign a name to the bucket, which is unique in nature. For example, just type in my AWS bucket, Intel, Virginia, something like that. Fine. Now it says bucket already exists. I name it as, for example, S3 bucket. So I put any name over here, which I think it is unique in nature. Fine. Once I put a unique bucket name, the next thing that I have to choose is the region. Now the buckets are the region-specific resources that contained inside the region. The buckets are contained inside the regions. Fine. So this means that if I put anything, any data inside this bucket, that data stays in the same region where the bucket resides. Fine. Then you scroll down. Then it says that object ownership. What is this? Inside this data, inside this bucket, you'll be putting some data into that. That data is called object. Right? What we have discussed is that what's a bucket? A bucket is a fundamental entity. What's a bucket? It's a fundamental container, I'm sorry. A bucket is a bucket is nothing but it is a fundamental container, right? It's a fundamental container. And anything that you put inside the bucket is called an object. Anything that you put inside the bucket is called an object. Now, so an object is nothing but it's the data that you put inside the bucket. Now, you want to ensure that you can change the permissions of that object. For example, the object can be shared with internet users. What I do, when I share the Google Drive link with you, I say share, and I share with this link with you, internet link, so that anyone with a link can access the documents. Similarly, object ownership means that you claim the ownership so that you can change the permissions of the object later on. Fine. You choose ACS enabled and choose bucket owner preferred. ACS stands for access control list. This enforces permissions. What we're doing is that we're saying that we're enforcing the permissions so that we have the ownership of the object and we can change the object permissions afterwards. Fine. So much like I share the Google Drive link with you, what I'm doing is that I'm sharing the permissions. For example, I click on share. I can say anyone with a link, I can restrict it. I can make it you as commenter, editor. What I'm doing, permissions only. The contents that I'm sharing with you, I'm changing the permissions of that content. Similarly, object ownership means that you claim the ownership that you may change the permissions of the object in the future. So choose ACS enabled, go with bucket owner preferred, and being a bucket owner, you get a complete ownership of the object. Then what's next? Block all public access settings for this bucket. What it says? By default, every object that you save in the bucket, or I would say the bucket is private in nature. What do you mean by private in nature? Which this means that the bucket contents are not visible or can't be shared on the internet. By default, the bucket's contents cannot be shared over the internet. You can't do that. Yeah, it's not accessible to others, especially on the internet. Now you want to say, I want to change it. You have to uncheck this option. Now you must say that why I'm doing so as if now. Because what is the purpose of this document? Hosting a static website using this array. It's a website. So if I don't uncheck it, I can't make my website public. Make sense? So you have to uncheck this option and you have to acknowledge that I understand this risk. Right? Because if you don't make the website public, it will then the people on the internet can't access it properly. They will be getting access denied message. So you have to uncheck it. Now this does not mean that if you put anything inside the bucket, it will be public. No, this means that you get the capability to make some data public. It's completely under your control. It's completely under our control. We can change the permissions management, the permissions level of different objects, depending upon our choice. Fine. We scroll down. Versioning, tags, encryption we'll discuss afterwards. Fine. So I'll repeat what we have done. You have to simply send a name to the bucket. It should be unique in nature. Fine. You choose any of the regions. Change the object ownership to ACS enabled so that you get the complete ownership of the bucket so that you can change the permissions afterwards. You uncheck block all public access so that you can make your website public and acknowledge that you understand this risk. And you don't have to change any one of the other options. Click on create bucket. And this creates a bucket for you. This creates the bucket for you. This is my bucket which is created, this one. The next thing is that you have to enable the website hosting. You have to enable the website hosting. So I'll show the step from 8 to 14, I guess so. 8 to 14. See what I'm doing? See, what we're going to be doing in this case is that we have to enable the static website hosting. You have to go to the bucket. Under the bucket, you have to go to properties. On this properties page, you have to scroll just down at the bottom, and there's a feature over here which is called static website hosting, which needs to be enabled. It is disabled by default. So click on edit, and it says edit static website hosting. Use this bucket to host this website or redirect the request. Now, the static website is set to disable. You have to enable it, right? Now you've been prompted with two options in front of you. One is host a static website and redirect request for an object. Host a static website, or you can just do the redirection. So redirection means that, for example, you redirect from one website address to another IP website address. Redirection generally we don't use with the S3. So you have to go with the hosting a static website, because that's what our purpose is. Now, once you host a website, you have to define the home page. In this case, it should be index.html, which is basically the root document or the home page of our website. Now, make sure that index.html should be case sensitive. It should be lowercase, and don't misspell it, because lowercase only. Sometimes people put uppercase I. So make sure that it should be in lowercase. Yeah, it should be in lowercase. Index.html in lowercase, case sensitive. Error document means that this page will appear just in case if you can configure the error.html page, which will prompt a pop-up if the user is trying to access any page which does not exist. For example, you might have seen this thing. If you go to, let's suppose, if you go to aws.amazon.com and let's suppose you give a / and type some gibberish and press enter, most probably get 404 page not found, something like that, right? What is this? This is the error page. This is the error page which comes up if you're searching for the page which does not exist. Fine. You can also configure this page, but right now we're going to skip it. Okay. So you have to host a static website, define the root document on the index.html document. There's no need to define the array document. Redirection rules would be blank because we are not doing any type of redirection from one website to another one. So you have to enable the static website, mention the index.html in the index document field, and click on Save Changes. This will enable the static website hosting. And if you scroll down, this is the endpoint, the domain name, the URL of your website. Step number 3 is you have to configure an index.html document, right? Now, you can create your own index.html document, but I've already created the document for you. In the 15th step, it says for this demo, the index.html document is already created and pre-configured. Click here. If you click here to download, this will download an index. So you have to download the index.html document on your computer, right? The next thing is you have to upload this index.html document and make sure that you can make it public. So step number 16 to, let's go to the 16 to 21. Fine. See what I'm doing? Steps 16 to 21. The next thing that you're supposed to do is go to the objects. Now, this is where you upload and access your contents. Click on upload, click on add files, and you have to add the index.html file. Just click on upload to upload this index.html document to your S3 bucket. Now you have to scroll down and you have to go to permissions. Under permissions, you have to choose grant public read access and choose I understand the stress that I'm making this object public in nature. And it makes sense because if we don't make this index.html public, how can we host our website, right? But AWS gives you a warning message just in case if you are by mistake making a private object, a confidential data public. Okay, so I've just uploaded the index.html document, made it public, or changed the permissions, and click on upload. And it gets uploaded. Click close. The next step is nothing but it's a testing part. Step number 22 to 25. It is super easy. Basically, what you have to do is that you have to choose the index.html. Okay, or you just have to go to properties, scroll down. Under static website hosting, there's a link. You click on this link and the page appears. So this is, if you share this link with any other person on the internet, he or she would be able to access your website. He or she would be able to access your website. If you just go to the, for example, at the object level, if you want to get a link, just choose the object and click on copy URL. So that URL is for the object itself. Let's suppose at the application level, you have to link the S3 to upload the documents. In the application itself, you have to specify the folder, or you have to mention something called S3 URI. For example, if I go to the bucket, choose a bucket, I can specify something like that, ARN, Amazon resource name, or what I can do is that I can create a folder. Let's suppose I create a folder, and this is the folder to store my, I would say, website data. Okay, I can create the folder. Now, let's suppose I want my application or my website to put the data inside this folder. I click on copy S3 URI or URL. Let's suppose it's an internal application, S3 URI. It generates a link. That link, and it do just mention that in the front-end application code. That link needs to be configured in the application code itself. So guys, this is about the static website hosting. The next thing that I'm going to discuss with you is called bucket versioning. What's versioning? Versioning is a concept that's being used to ensure that you can create multiple versions of the same object or the same data. Let's go there and discuss that. What is versioning? Versioning means that you can keep multiple versions of the same object in one bucket. You can keep multiple variants. You can keep multiple versions of the same object inside the bucket. Now, basically, the thing is that this ensures that your data is not overwritten. It has to be enabled explicitly. Each version will have the version ID. The main feature, the benefit of the versioning feature is that the objects are not overwritten. The objects are not overwritten. Okay, so in this case, versioning has to be enabled. I'll show you the demo of it. It's very simple. Okay, before we enable versioning, let's do one thing. Let's try to upload some content. So I click on upload, add file, and I try to add some files over here from scratch. Let's suppose I go to my desktop and okay, all right. So I already have the text editor. So I add the file that's called demo.yaml, right? So, or this one. This file I'm just going to upload to the S3 bucket. I click on upload and this file gets uploaded. It's a very small file. It will get uploaded. Click on close and you can see that this file is uploaded. Right. Now, if you see the timestamp, it's 8:53 a.m. 53 seconds when this file was uploaded. Now, if I upload the same file again, what's the default behavior? Generally, what happens is that if you upload the same file again, now it's being overwritten. The previous timestamp was 8:53. Now it is 8:54. It is overriding. It's overwriting the previous stuff. Now you may not like this. You're saying, I don't want the files to be overwritten. My business use case is I want the data, every upload that I make is taken as a version, right? So the existing objects are not being overwritten. So in this case, what we do is that we go to the properties and under bucket versioning, click on edit, choose enable, and click on save changes. Done. Now, once we do that, once we enable the bucket versioning, it's being enabled. Fine, it's being enabled right now. From now onwards, if I try to upload the same data again and again, let me just try to upload the same data again. I'm uploading the same data multiple times. I'm just trying to do it right now in front of you so that I can show the best example that how the versioning can be used to have different versions of the similar objects. So I'm just making some uploads of the same RTF file. Right, so I've uploaded 4 or 5 times the same document, right? Now you will see that there's no change. There's no change, fine. But if I do one thing, if I go to the document itself and go to versions, I can see all the versions of the same object, right? Now you can see there's a version ID null. Null means that this object was uploaded before versioning was enabled. Thereafter, after the versioning was enabled, every object generated a separate version ID, right? It's a unique in nature, or it's auto-generated. We don't have to modify it or concerned about it. The main thing to be concerned about is the timestamp, right? Because you can maintain multiple versions of the same data based on the timestamps, you can easily navigate to any of the timestamps and retrieve the data from there. For example, I'm saying I want to retrieve the data based on this timestamp, 8:55:43 seconds. You click on the version ID and click on download or open, and you'll be able to get that data from that specific date. You can see that I just got access to the document. Now, how it is beneficial? What's a use case? Developers will use it because developers need to make sure that they can have, if they make changes to their code, their application source code, they want that their application source code should have different versions. Fine, so that if the new version has some bug, they want to go back to the previous version, they can easily go back to the previous version, right? So in this case, you can maintain multiple versions of the same object so that the existing files are not being overwritten. Mostly used by developers because the developers have to ensure that any changes that they make to the main source code, those changes are being saved as different versions, and anytime they can refer to the previous versions to rectify the bugs, some errors if they want. Fine. But this comes with a downside. The downside is, which is clearly evident, that it increases your storage cost because the size of this object is 1.3 kilobytes. But because I've uploaded these many versions, it's 1.3, 1, 2, 3, 4, 5, 1.3 to 5, right? So it has increased my storage cost 5 times because every version of every object would take its own space. Fine. From the enterprise perspective, you have to pay for every single bit of data GB you consume. I'm talking about only 1.3 kilobytes. Once you start working in the large enterprise environments, the changes are done on daily basis in gigabytes on daily basis, right? So for example, if you are changing, if you have 50 GB of data generated on daily basis due to versioning, 50 GB every day. So in this case, this will be a huge bump up, or it will spike your storage cost. How to solve that? We're going to discuss it afterwards. Fine. So versioning is a wonderful feature, or it's a tool which makes which ensures that you can save multiple copies of your data, multiple versions of the data. Fine. That's the concept of versioning. The next thing that we're going to be discussing would be something called transfer acceleration. This one, what it says. I'll give you one use case, try to understand this use case, because I'm talking from the developer point of view, that how these S3 buckets can be used based on different use cases. Let's imagine that you have a bucket that's being accessed by developers. So I'm talking about this feature that's called transfer acceleration. Hang on one second over here. So this feature is named as transfer acceleration. Fine. So let's take one simple scenario. Simple one. Let's imagine that you have an S3 bucket. Okay, you have an S3 bucket which needs to be accessed by developers across the planet. So for example, you are working for a global organization, it's an MNC. This bucket is being used to store your application data, right? And the developers across the globe are committing the changes. So they're doing commits, they are uploading the data. So there are huge quantities of data being saved. Now this bucket is in, for example, it is in North Virginia, right? But the developers, for example, let's suppose in Asian countries, for example, from Europe, from North America, and from Africa, they're putting in huge amounts of data. So these are developers who are putting in a lot of data inside this bucket on daily basis. They're making a lot of commits. Now, what is the so in this case, if you see this scenario, the bucket is in North Virginia, but the users across the globe are trying to access the bucket from their end and putting a lot of data into that. Now, this may slow down the process of uploading because the bucket is North Virginia, but the users are somewhere else. There's a huge distance between the users and the bucket. Now, what you do is that you make this uploading process up to 300% faster. Okay, and what happens is the users, basically the data gets transferred through the edge locations. Now, edge locations are nothing but these are the AWS edge network locations. Now, these edge locations are nothing but these are the AWS managed data centers, which are used for content delivery or accelerating the content to be delivered to the users around the globe. So through the edge locations, the data has been transferred, and the data speeds gets up, the uploading speeds gets up to 300% faster. Fine. So this bumps up, this increases the uploading speeds. And this is useful, especially in those cases if the users are far away from the bucket. They're very, very far away. If a person is from Japan, he or she is trying to upload some data to the bucket in US, it can take some time, right? Now, if they have to put in a lot of data on daily basis, we can accelerate this process by enabling transfer acceleration. It will increase the uploading speeds. At the back end, the data goes to the edge locations, which are owned by AWS. So they make the process, they find the shortest and the best route possible for the data uploading. So the data goes through the edge network locations, which is the backbone. I would say this comprises of the so basically this comprises of the AWS own private network. Okay, having said that, this is exactly the overview is. Now, how to enable this feature? It's very simple. You go to edit, click on enable. Now it generates an endpoint URL. You don't have to be concerned about it. It's a backend process. Click on save changes, and that's been done. From now onwards, it will increase the uploading speeds from the user to the bucket. So you can see that use an accelerated endpoint for faster data transfers. Now, there's one downside of this process, that it will append few cents per GB to storage cost. It will add on few cents per GB to your storage cost, right? But it's a feature that you can enable if you want. Policy can deploy the files directly to the S3 bucket from any developer tools like Visual Studio or Visual Code. But basically, to deploy the files directly to the S3 bucket from any developer tools like Visual Studio, Visual Code, you have to make use of the APIs or the external software programs that you may develop on your own that can help you to upload the files to the S3 bucket automatically based on some certain events, right? So some APIs can be developed. You get a complete kit, the SDK kit from Amazon, and you can develop your own APIs, and you can have those external programs upload or extract the files from this bucket. Having said that, let's go to the S3 right now. And we had created one bucket. The next thing that we're supposed to discuss is a bit of theory. I wouldn't say not a bit of theory, but it's complete theory now. That is called the storage classes, right? Storage classes is very, very important to learn the concepts, because you have to understand that what are the different situations where the different storage classes can be used by you or by your business. Over here on the right hand side, and let me just explain you. All right, so having said that, what I mean by this thing called storage classes, let's try to understand it. Let's imagine that you take a bucket, and so for example, this is the bucket right now. Inside this bucket, you put an object. So what's a bucket? It's a fundamental container, and inside the bucket, you put the object. So you go ahead and you put the object inside the bucket. This is the object. Fine. It can be PDF, it can be of any format. Now what happens is that to ensure that this object remains redundant means that it is safeguarded by ensuring that, so so basically data redundancy.
Let's have a quick quiz question, guys. And the question is, which of the following is Amazon's technical support and consulting business? And your options are Amazon Virtual Private Cloud, AWS Premium Support, Amazon Fulfillment Web Services, or all of the above. Please mention your answers in the comment section below.
Just a quick info for all of you cloud enthusiasts. If you want to make a career in AWS, then you might want to check out Intellipaat's AWS certification training course for solution architect. Learn from industry experts through hands-on session, projects, and case study. Reach us out to know more.
Has to be ensured, right? Now, how this data redundancy is being managed? What happens is that the bucket is in a region. For example, this is in US East 1A. I'm sorry, US East 1. US East 1 is what? It is the region. US East 1, it is the region. It consists of 6 AZs. US East 1A up to US East 1F. Fine. Okay, so this is a bucket in US East 1, which consists of 6 AZs. Now, when you put any object to the bucket, by default, Amazon will create multiple copies of it. Now, there's no any evidence or any documentation that what's the number of copies that are being generated and stored across all the 6 AZs, so that your data can be retrieved even in case of any one of the AZs go down, your data can still be accessed. Fine. So it creates multiple copies of it. It creates or generates multiple copies of the data and put those copies across all the 6 AZs. That's what exactly the bucket is meant for. Or I would say that's what exactly how we achieve the data redundancy, or we make the data more redundant. Fine. So what is this? This is one of the performance metric, right? We get the performance from the bucket itself in terms of how much data redundancy we are achieving. How much, so to what extent the data is made more redundant. Okay, if it's a very critical data, very important data, of course it has to be made more redundant. If it's a less important data, less critical data, it can be made less redundant. Now, apart from data redundancy, you also need to make sure that your access is faster, or you want to get a faster access to data, faster access and retrieval. What do you mean by retrieval or access? See, this object is in the bucket now, right? So you as an administrator, you want to get it back. This is called get operation. Fine. So get means that either you want to open it or you want to, so either you want to open it or you want to download it. In any one of these two conditions, you're trying to get the data, or I would say you're trying to retrieve the data. Get the data. So this is purely get operation, or this is purely retrieve operation. Basically, what you're trying to achieve is you're trying to get the data back and save it or access the data. Right now, how faster you can access it, that makes a very big difference, right? So if you're able to access the data very much faster and retrieve it faster, it's a good thing for you. But what if the data is not very important? You don't want to access that data very frequently. So in that case, if you access it slowly or there's a slow retrieval process involved, in that case, it doesn't make a difference to you. So how redundant the data is, how faster you can access that data and retrieve the data back to a computer. These are the two things you need to keep into your account or keep in mind before understanding that which storage class is best for you. Fine. So how redundant the data is, how faster you want access to it, how fast you want to retrieve it, and also what's the frequency of the access? What is the frequency of access? How frequently you access the data? That is also one of the important factors you have to keep in mind. How redundant the data is, how faster you want access to it and retrieve it, and what's the frequency of access? Do you access the data on daily basis, on weekly basis, monthly basis, yearly basis, or maybe you don't access the data for 5 years or 10 years down the line? Fine. So these things that need to keep in mind before deciding that which of the storage class is the best fit for you. Okay, so based on that, based on these different factors, you carefully choose the storage class. You carefully choose the storage class. Whenever you go to the AWS Environment Console, let me show you this thing right away. Whenever you just go to the bucket, you put any object, you will see that on the right hand side, by default, the standard storage class shows up. Can you see that? Right. Let me just turn on the video now because I want to make sure that it's interactive. Yeah. So if you see on the, I go 1 second. Okay. Now, if you see on the right hand side, what storage class you can see over here? Standard. What is this? This is the standard storage class. Now, for example, I want to upload a new data. I want to upload a new object. I just add the files and try to add any of the files over here. For example, I just upload this file. Before I hit upload, if I go to the properties, under the properties, I can change or switch between different storage classes. Standard is a default one. Standard is the default storage class that you can see over here, right? So standard is the default storage class. It's the default storage class. So under the properties itself, the storage classes can be changed very easily. But the question really is, what are what are these different storage classes all about? The different storage classes are all about is that how much data, to what extent the data is made redundant, how much data redundancy you're getting out of it, how fast access you want to, how fast you want to access the data, retrieve it, and what's the frequency of access. Having said that, first thing first, I'll start with the first storage class that's called standard. Now, standard storage class, the standard storage class is I'll list down the points for you. It's a default storage class, right? Default means that if you don't explicitly define that which storage class you have to go for, it will pick this up by itself. This gives you 11 nines of durability. 11 nines of durability. What do we mean 11 nines? If I say 11 nines, this means that I'm talking about 99.9999 11 nines%. So there are 11 nines, 11 nines of durability, right? It gives you 99.99% of availability. This is what you get in terms of, so availability that you get is 99.99%, right? This is the amount of availability that you get. Your data is replicated across all ACs. Fine, across all ACs. This is used for critical data, which is very important. And this is the costliest of the entire lot. This is the costliest. Okay, so it gives you this amount of availability, data is replicated across all the ACs. It is used for critical data. So it is used for, so it is used, it is used for critical and infrequently accessed data. It is used for critical and infrequently accessed data. I'm sorry, frequently accessed data. I'm sorry about that. Frequently accessed data. Any data which is very, very important, which is super important, right? Any data which is extremely important. So it is a default storage class. It gives you 11 nines of durability, 99.99% of the availability. The data is replicated across all the ACs. It is used for critical and frequently accessed data, and it is the costliest. See, cost depends upon that. How much performance you get out of it. Because, see, one thing you need to understand: Amazon is creating multiple copies of the data. So, for example, for you, that's a 1 GB of data. But for AWS, it can be 20 GB of data, because might be they are manufacturing 20 copies of it. There's a possibility they're creating 20 copies of it. So the cost depends upon that how much, if for example, in the standard storage class, the data is replicated across all the ACs, right? So this means that multiple copies will be generated and saved across all the ACs. So it will lead to more storage consumption at the backend, right? That is one of the big deciding factor that what should be the storage cost imposed upon you by Amazon, and what's the performance, right? So this gives you a very fast access to your data. This gives you very fast access to your data. So the more performance you get, the more you have to pay. Fast access to your data. You can access the data very fastly. It's a backend operation. This is not feasible because that's being decided by Amazon at the backend. So we don't have control upon it. Fine. So this is what exactly the concept is. All right. So what exactly the standard means that multiple copies are being generated at the backend, stored across all the ACs, costliest of the entire lot. This is used for critical and frequently accessed data. Now, this is very important. Frequently accessed data means that you're accessing at least once in a day, or I would say at least once in 30 days, right? Frequently accessed data means that you are accessing at least so in for frequently accessed data. So frequently accessed data means that you're accessing it at least once in 1 month. It's very frequently accessed, or maybe on daily basis, on weekly basis, but at least once in a month you're trying to access it or open it. Fine. And the data is very important, very critical. The next storage class that I'm going to discuss with you is called standard IA. IA stand for infrequent access storage class. So what is the standard IA, standard infrequent access storage class all about? See, basically, you get the same performance as standard, which means that same availability, same durability, fine. And data is replicated across. So in this case, the data is replicated across all the ECs. Fine. I'm sorry. Yeah. So in this case, it gives the same performance as standard, but with a lower storage cost. Same performance as standard with a lower storage cost. It is ideal for critical, which means it's a very important data, and infrequently accessed data. Any data which is not accessed very frequently, infrequently accessed data. Now there's a catch over here. Even though you must say that it gives the same performance as standard with a low storage cost, why should I use standard then? If standard IA gives me same performance with a low storage cost, right? You have two options. Both options give you the same performance. One is cheap, other is costly. Which one you will go for? A cheaper option, right? Even if you're paying less, you're getting the same performance. So why should I go for standard? If standard IA guarantees me same performance, same availability, same durability, the data is replicated across all the ECs, but why should I go for standard then? Because there's a catch over here. The catch is, or the difference is, there's a small per GB retrieval fee imposed upon you. I'm sorry, there's a fraction. So basically, there's a small per GB retrieval fee imposed upon you. You have to pay a small amount if you retrieve the data, if you access the data, you download the data, you open the data. That's why it is ideal for that data which you don't access very frequently. Because even though you're paying a load storage fee, but if you try to access that data very frequently, so infrequently means that you are not accessing the data, for 30 days at least, for 30 days at least. So if you're not accessing data, if you are not accessing the data for 30 days at least, you can put that under the not accessing for 30 days at least. So if you are not accessing the data for 30 days at least, then in that case, it can be safely put under the standard infrequent access storage category. It guarantees low storage cost, but there's a small per GB retrieval fee imposed upon you. Are these two differences clear to you? Fine. Now, this is important from the business operations perspective, from the certification perspective, because you may come to some scenarios where in certification exams, you're being judged based upon different use cases given to you, and you have to tick out or check out the best possible storage class based on your understanding. The next thing is intelligent tiering. What is intelligent tiering? Intelligent tiering means that you are confused at which one is best for you. Okay, so what is this intelligent tiering storage class all about? I said you that standard is for the frequent access data, the data that you access very frequently. Standard I is for the data that you don't access very frequently. What if you are confused between these two? You have unknown or changing access patterns. You are confused right now that which of the two storage classes is best for me. You have the unknown or changing access patterns. You must be confused that which one of these two is the best for you. You have the unknown or changing access patterns. You don't know which one of these two are the best for you. In this case, you use intelligent tiering. What happens is that based on your access patterns, it will change its tiers and bring down the cost of the storage. How? I'll give you one example. Try to understand this example, or I would say this is the cycle. This is the complete cycle. For example, let's imagine this is the bucket that you have, right? This is the storage bucket that you own, and you put some data into the bucket. You put some data inside the bucket. Now, once you put some data inside the bucket, as of now, you're going to be seeing that as soon as you put the bucket inside the bucket, as soon as you put the object inside the bucket, if the data is put under the frequent access category for first 30 days, frequent access tier for first 30 days. For first 30 days, this is labeled as frequent access tier, which is costly, which has a high price tag, right? So for the first 30 days, you don't access the data. Whether you access the data or you don't access the data, for the first 30 days, it will be labeled as a frequent access tier, which will have a high price tag. Now, what happens is, for the first 30 days, okay, I want to just again repeat with some corrections. For the first 30 days, your data is being put in the frequent access tier, which is a higher price. What if you don't access the data for these 30 days? So this data is put inside the bucket, the object, and you don't access that data for in those 30 days. So the first 30 days, frequent access tier, and in these 30 days, you don't access the data. So no access. You didn't access the data for 30 days. No access in these 30 days. In these 30 days, you didn't open the data, you didn't retrieve the data. It is lying over there, doing nothing. In this case, it's being transitioned to the infrequent access tier, which is a cheaper option. right? This is a cheaper this is a cheaper in terms of price. Fine. So in this case, what happens is, if you don't access the data for 30 days, which is lying in the bucket, then it's been transitioned to infrequent access tier, and it brings down the cost of that that data. All right. Now, what if for 90 days after it has been put in the bucket, so no access for 90 days straight, no access for 90 days straight. You don't access the data for 90 days straight. It's lying over there, doing nothing. If that's the case, it's being transitioned to archive access tier, right? Which is comparatively cheaper, which is comparatively more cheaper. Fine, right? Now, what if you don't access the data for 90 days, for 180 days straight? No access for 180 days straight. So for 180 days, it's not being accessed. Then it's being put into deep archive access tier. Right? Which is the cheapest. So based on your access patterns, whether you access the data frequently or you don't access the data frequently, it will change the storage tiers of your data and bring down its cost. Now, at any stage, if you access the data, for example, at this stage, you access the data, then it's being put back in the frequent access category. The next thing that you have to discuss is the one zone IA. Okay, so it is very much evident what this means. The data is made redundant in one AZ only. Now you can't choose which AZ that is. You store the data in just one AZ. The data is made redundant. Only one AZ, right? This means that this is used for less critical data. Less critical data, right? It is ideal for duplicate backups. It is ideal for, I would say, data that can be regenerated, because data can be lost in event of the AZ destruction. If the AZ is destroyed, it goes down, you can lose the data. Okay, now you must say that why am I compromising in terms of this thing? Because this is a cheaper storage option. This is a cheaper storage option, right? And you get faster access and retrieval. You get very fast access to your data, very fast access to your data. But the data is made very less redundant because it's stored in just one AZ only. So in case of an AZ destruction, you can lose the data. Bucket is stored in a region. A region consists of multiple AZs. If we pick any one of those AZs where the bucket resides, for example, bucket resides in Mumbai. Mumbai has 3 AZs. If we pick any one of those 3 AZs and make the data redundant or stored in just one AZ only. So there's no concept called bucket AZ. Bucket is stored inside a region. The region's data is scattered across all the AZs by default. But if you limit to just one AZ, then that comes under the one zone IA, category. One study example, AZ can be destroyed anything. For example, it's being bombarded. It gets down with natural calamity, floods, there's a power outage, anything. Okay. Any man-made disaster or natural disaster can bring down a data center. What's a data center only? It's a building. It's a huge facility, right? So anything can happen. Fine. So this thing, you must keep in mind that OneZone can be used in those cases where the data is less critical. You're doing there for duplicate backups, and the data can be reproduced. It can be regenerated. All right. That's the concept. The next thing I'm going to discuss with you is called Glacier, right? Glacier, if you see the term Glacier, it simply means that it's used for archiving your data. Any data which you don't access for weeks, months, or years, you put that under Glacier. It is the cheapest. It is a cheaper option. It has a very low storage cost. Okay, but it has a very high retrieval time. So it may have, depending upon what you choose, it may have high retrieval time. Right? So retrieval time means that if you try to download the data, it takes a lot of time to download the data back. So it's a very slow and sluggish storage. It's a very slow and sluggish storage. If you try to download the data from the Glacier storage class, it takes a lot of time. And yeah, so it is used for that data which you don't access very frequently. Low storage cost, may have very high retrieval time. Fine. So Glacier means you're archiving the data which you don't access very frequently. Then comes the Glacier Deep Archive. This guarantees you this is the cheapest storage option, right? And this is used for if you have a retention period, if you want to retain the data between 7 to 10 years. So if you want to retain the data for years to come, then you can store it as a Glacier Deep Archive storage class. So this is what I have discussed with you. Default ones, live session class videos. They're put into these, I guess they should be put in standard only because they're being accessed very frequently. But I think if the class was conducted a year back, then it should go to Glacier by itself. Fine. All right. That's the stuff. Guess any questions and doubts you have? Even though it's a complete theory, it is extremely important for you to learn these points. I've jotted down the bullet points so that it becomes easy for you to learn these concepts. Yes, Vinod, you get the option. You get the option, right? PDF question mark. You have to elaborate the question exactly. PDF question mark. What exactly this means? You're talking about the PDF stored on the S3 bucket by Intellipaat. Basically, generally speaking, I don't work with Intellipaat IT operations. So what strategy that they use in the backend, I'm not sure about it, but I'm pretty much sure that they must be using any of these storage classes to archive the PDFs. PDFs are being used very frequently, so they must be used as standard. Okay. They must be used standard because PDFs are being accessed very frequently. Okay. You can use the data from, if you can see, basically, let's understand why the Glacier is used. Glacier is used to put any data if you don't access for weeks, months, or even years, right? If you access the data from Glacier frequently, because one thing you need to understand, even in the Glacier, there's a retrieval cost you have to pay. There's a retrieval cost you have to pay. There's a retrieval fee that you have to pay. Right? There's a retrieval fee that you have to pay. So if you are accessing the data frequently, then don't use Glacier. It's as simple as that. If you're using the data very frequently, you can use either the standard or use standard or one zone IA. Yeah, but don't use Glacier. Glacier is not meant for the data to be accessed very frequently because it's very slow in terms of downloading the data. Okay, so that's the case. Fine. Okay, so that's yeah, it's very, very slow. It's very slow in terms of getting the data back. It's a very sluggish storage. So I can change any storage. I can go to any of the storage classes if I want. And yeah, so I can do that. Or I can change the storage class of the existing object. For example, I choose this object, go to actions, choose edit storage class, and I can switch to any other storage class if I want. Okay, I can do that. Fine. You can see that I've changed it storage class. All right. Is this clear? Any more questions? If you have, you can ask me. Otherwise, I can just go to the next step now. Okay, just give me a few seconds over here. I need to just put some data out of the Google Drive. Copy shift the data between classes. Yes, you can do that. Basically, we will be discussing the concept of lifecycle management. They will discuss it. There, we're going to be discussing it. Yeah, we know that we're going to be discussing it right now. Okay. There's one thing I want to discuss with you in terms of the exercises that we need to perform. That we are trying to understand that how you can transition from one storage class to the other one. How you can do that? How you can switch from one storage class to the other one? That's we're going to be discussing. Now, if you remember, we discussed the concept of what do you call it as versioning, right? We discussed versioning. So what happens in versioning is that if I go to the S3 bucket, okay, I go to my this RTF document and go to the versions. You will find this thing out by yourself. That is that versioning is great if you want to avoid overwriting of the data. If you want to avoid overwriting of the data, you don't want to overwrite the data. You want that the data should not be overwritten. Fine. But there's one problem over here. The problem is that even though versioning creates multiple versions of the same object, it comes with a downside. That is, each version takes its own space. This means that if you use versioning, your storage cost will eventually go very, very high. It will go beyond your control. The storage cost will go rooftop. And see, right now I'm talking about just 1.3 kilobytes of storage. Right now I'm just talking about 1.3 kilobytes of storage. Let's talk about GBs, gigabytes of storage, or maybe terabytes. So in this case, if multiple versions are being produced on a monthly basis, maybe let's suppose that you're paying for 50 GB or 100 GB of data, extra storage just for versioning, it will bump up your storage cost. Now, version comes into two different categories. What are those categories? The first one is the current version. Current is the most recent version. This is the latest version. This is the most recent. So the current version is the most recent version, and it's fairly evident if you see the timestamp. Right? Current version, if you see the date, it is the most recent version, the latest version. But the versions before that are called the non-current or the previous versions, which are not the latest, which are the previous versions. So the two options you have: current, latest, most recent; non-current, which are the previous versions. Right now, you want to create a cycle. You want to create a cycle based on which you want that. Chaitanya, the answer is no. You want that the transitions can be done based on the current version and the non-current versions. For that, if I go to the bucket, I go to the management. Under management, there's something called life cycle rules. So over here, I go ahead and click on create life cycle rules, and I enter the rule over here. For example, I name it as test life cycle rule. I simply send a name to it. Now it says that, do you want to limit a scope? For example, I say prefix JPJ. So this means that this applies to only those objects with a .jpg extension. But I would say apply to all the objects in this bucket and acknowledge that I want to do it. Now, these are the life cycle actions that you can impose upon on your objects. You move the current versions of the objects between different storage classes. You move the non-current versions of the objects between different storage classes. You expire the current version, which means that once you expire them, they become non-current. You permanently delete the non-current versions of the objects. And what happens is that once you delete the object, there's a delete marker that shows up, which doesn't take any space. Or multi-part uploads. Now, multi-part uploads is the extension of the APIs, where a single large file is being divided into multiple chunks and uploaded. So any incomplete upload is also can be deleted. So these are some actions that you have to that you can see. For example, generally the companies, they target the non-current versions. Non-current versions are the previous versions. They take a lot of space. They should be moved between different storage classes, or you can delete them after some time. So for example, in this case, I'm saying move the non-current versions of the objects between different storage classes and permanently delete the non-current versions of the objects after a gap of few days. Right? I choose these two options. Now comes the transitioning. I can say that, see, by default, whenever the object is uploaded, it's labeled as standard storage class. I can say that it can be changed to standard IA after a gap of 30 days, which is a bit cheaper, right? Now, there should be a gap of at least 30 days between standard and standard IA. If you put it even 29, it prompts you this message. A minimum of 30 days is required before you can change to the standardized storage class. So I make it as 30 days over here. I add one more transition. For example, I can say archive it to Glacier after a gap of 90 days, right? So in this case, I'm saying that once the object is uploaded, by default, it's standard. Change it to standard IE after 30 days, which is bit cheaper. And after 90 days, take it to Glacier, which means that I'm archiving it and make it very cheap. Fine. Then I can say that after, let's suppose, 100 days, remove that. But you can say that I want to retain at least one copy of it. Right? For example, there are 10 copies of the previous versions. If we retain newest version of those, or the newer version of those 10 copies, and remove the other 9. So I'm saying that after 100 days, so once the object becomes non-current, for example, okay, you can see that there's a complete chart. On day 0, object becomes non-current. On day 30, it's moved to standard IE. On day 90, it moves to Glacier flexible retrieval, or it's a Glacier only. On day 100, one version is retained, only one copy is retained, and all other copies are being removed from your bucket.
Let's have a quick quiz question, guys. And the question is, which of the following allows you to create instances of MySQL database to support your websites? And your options are Amazon Elastic Compute Cloud, Amazon Simple Queue Service, Amazon Relational Database Service, Amazon Simple Storage System. Please mention your answers in the comment section below.
So for example, I have 10 non-current versions. It will keep one for me, safeguard it, and remove all of them from the bucket, or remove them from, I would say, delete them from the bucket permanently for me. Now, what's the benefit that you get? You're automating the process to bring down the cost of your S3 storage, and you're creating a complete life cycle for your objects. Fine. So I repeat what I did. Once an object becomes non-current, on day 30, it is changed from standard to standard IA. On day 90, it's changed from standard IA to Glacier. It's archived. And on day 100, one copy is retained out of all the previous non-current versions, and all other non-current copies are being removed from my bucket. I click on create rule, and this rule is being imposed. Fine. This rule is being imposed over here. Okay, I think I need to hit refresh. So that's being done. Okay, this is being created. First thing first, you have to create 2 buckets in 2 separate regions. I'll show you the step. It's super easy. You don't have to be, I would say it's one of the easiest steps out. So I'll show you. So what we're gonna do as if now is, yes, it's global nature means that it is global. The nature means a bucket name is unique globally. You can say that. Okay, first thing first, you have to create 2 buckets in 2 separate regions. I'll show you the steps. I can create bucket. Now I name this bucket, for example, as my AWS bucket replication lab Virginia, right? I choose North Virginia as my region. I scroll down and click on create bucket. You don't have to change any setting. Then I create another bucket. I just create this second bucket in, for example, in Singapore. So I choose Singapore as my preferred region. Scroll down and click on create bucket. So what I've done is that you don't have to change any setting, right? So create 2 buckets with default values. Create 2 separate buckets in 2 separate regions with the default values. So in this case, I've created 1 bucket in Virginia, another bucket in Singapore. The next thing is that you have to enable versioning on both of them. How to enable versioning? It's simple. You click on the first bucket, go to properties, under bucket versioning, click edit, choose enable, and save changes. You go to the buckets list, right? Click on the second bucket, properties, under bucket versioning, click edit, enable it, and save changes, right? You have to go bucket by bucket, right? Just go to properties, versioning, and you have to enable the versioning. Now, why did I ask you to enable versioning? Because to enable that application, versioning should be enabled on both of them. To have that application enforced, it is really important that the versioning is enabled on both buckets. So basically, what happens in this case is that one bucket is the main bucket, primary bucket. Another one would be the secondary bucket. What do you mean by that? If you put any data inside the primary bucket, okay, so what is happening is, what we're trying to achieve over here is that in terms of an application, there are 2 buckets you have, right? So these are 2 buckets. One is primary and the other one is secondary. What I'm trying to achieve is that if I put x.jpg inside this bucket, a copy of x.jpg is being generated and put in the secondary bucket. So it is a one-way application, not the other way around, right? So if you put any data inside the primary bucket, a copy of that data is produced and also saved in the secondary bucket. Now these 2 buckets can be in the different regions or same region. It's purely your choice. But in our case, it's in different regions. These 2 buckets are located in separate regions, but you can also have the same region application if you want. So you have to pick any one of the 2 buckets as primary and go to the management. So for example, I choose Virginia bucket as a primary bucket and go to management. So this bucket that we're accessing right now, in my case, it's in Virginia. You have to treat this bucket as a primary bucket, which means that any object that you put inside this bucket, a copy of that object would be produced and saved in a secondary bucket. So you have to choose any one of these 2 buckets as primary and go to the management. So I have these 2 buckets created, this one, Virginia and Singapore. I pick the Virginia's bucket as a primary bucket and go to its management. Now, these are the 2 steps that you have to perform. I'll show you these steps. You have to scroll down and click on create replication rule. Then you have to assign a name. For example, I name it as test replication rule. You have to simply assign a name to it. Status is enabled. It will ask you which is a source bucket. Source means primary, right? Source means primary bucket. If you see the source means primary bucket. Source means primary. So the primary bucket is the bucket that we're working in right now. That's in my case is the bucket in Virginia. Okay. Then it says, for example, I choose .png. If I do that, this applies to only those objects with .png prefix or images. But in this case, we'll say apply to all the objects of this bucket. Okay, so I'm saying that if any data, irrespective or regardless of which extension the file is of, it's PDF, document, spreadsheet, PNG image, JPEG image, AVI video, MP3 audio file, it doesn't matter. Apply to every single object inside this bucket. Okay, what's your destination bucket? The secondary bucket. You have to click on Browse S3 and you can, or what you can do is that you can search for that bucket name. You search such as I search for the secondary bucket, click on choose path, right? So I'm saying that the Virginia bucket is a source bucket, the primary bucket, and the Singapore bucket is the secondary bucket. It's a destination bucket. So you have to choose create new role. Do you want to change the storage class of the replicated objects to be saved in the target bucket or the secondary bucket? I would choose one zone. You can choose one zone or intelligent tiering, whichever one of these two is best for you. I choose one zone, right? Because one zone is used for duplicate backups. I'm saying that any data saved in my destination or secondary bucket, that data I need to pay less for it. So I'll be using the one zone IA in this case. You don't have to go with the additional replication options. Click on save. Now it says, do you want to replicate any existing object? Choose no, click on submit. So this role will be created by default with some default settings. This will help this replication to happen smoothly by itself. Because you don't have to choose prefix as if now. Choose apply all to the objects. Prefix always JPEG? No, it depends upon your use case and your requirement. But you have, in this case, you have to choose applied to all the objects. You have to go to the bucket, choose any one of the buckets as the main bucket, source bucket. Go to the management. I go to application rules, click on create and name it. For example, test replication rule. Fine. Status is enabled. Now source bucket is the same bucket that you're working on, which means that any data you put inside this bucket will be replicated. In the filter type, do you want to filter any type of object like PDF, JPEG? I would say no. And saying apply to all the objects. It does not matter. It's PDF, JPEG, apply to every single type of object. Destination bucket, which is a secondary bucket where the replicated or the synchronized, I would say, the duplicate copies will be saved. Go to browse and I choose any one of the duplicate, I would say, any one of the buckets where the destination bucket where my duplicate copies of the data will be saved. Now, to facilitate this application, choose create new role. This will create a new role automatically. Now it says destination storage class. When the objects are being replicated, do you want to change its storage class? I would say yes, and I choose one zone. And click on save. What's next? You have to test by uploading an object to the source or the primary bucket. Go to your source bucket, the primary bucket, upload anything. For example, I just go to the upload, add files. I'll add this document. Okay. Let me search for, yeah. I upload this this document like this. Okay. And click on upload. Right. I click on upload. Now I click close. In the source bucket, the data is replicated as is saved as standard, which is default. Standard is a default one. So I just put one text document of just 1 kilobyte in primary bucket or the source bucket. Now I go to the bucket list, go to the secondary bucket or destination bucket, you will see that the same document shows up, but the storage class is a cheaper one, which is OneZone. I'll show you again what I'm doing. So Virginia is my source bucket. I click on that. I click on upload, and I try to upload some data to the source bucket. Right? This is the VF SharePoint link RTF document. Click on upload. Okay, it's uploaded. I click close. Then I go to the bucket list and click on the bucket that's the secondary bucket. Now I hit few refreshes. It can take some time, and after few seconds, it will show up. It can take some time. So you can see that my previous document was just of this 1 kilobyte. It got replicated very fast. This file is not that much large, but it's taking some time. And after a few seconds, it will show up. So that's how you'll be able to see it. It can take some time to show up, but eventually it should show up. Eventually, it should show up. Replication is done to make your data more redundant, so that if you lose your data in your primary bucket, you can retrieve the data from your secondary bucket. If you lose the primary bucket data, you can access the data from the secondary bucket, right? That's what the purpose of the replication is. Now imagine this thing, that if this happens, if this applies to the deletion process, if you delete something from the primary bucket, then the secondary bucket data is also it's deleted. What will happen? Then if you lose, so in this case, for example, by mistake, you delete all the data in the primary bucket, the secondary bucket is also affected. So there's no purpose of backing up the data. Okay, you somehow define the purpose of replication at the very first place. Fine. So in this case, only the write action is being replicated, not the deletion or modification. Only the write, I would say that only the write changes are being synced, not the deletion. Because if that thing existed, this would have somehow defied the purpose of having that application in the very first place. Now my object is still not replicated, the second object. So I'm adding one more file just to make sure that it's being done. If you require modification copy, then then you go to the versioning, right? Modification copy means that basically, see, why did I ask you to enable versioning? Because even the versions of the objects are also replicated. If you make any modifications to the files and you upload it to the source bucket, even the versions of those objects are also replicated, right? So if you go to the, for example, Singapore bucket, you can see that it's being synced. I go to this VF SharePoint link, go to the versions, and I can extract the versions of it. So modifications can be accessed by going to the versions of the object.
Just a quick info for all of you cloud enthusiasts. If you want to make a career in AWS, then you might want to check out Intellipaat's AWS certification training course for solution architect. Learn from industry experts through hands-on session, projects, and case study. Reach us out to know more.